Chapter 22. Technical Integration. Specialist Track Design. 22.1 Advanced AI Architecture and Systems Integration. Enterprise AI Architecture Framework. Comprehensive System Integration Methodology Design and Advanced AI architecture requires sophisticated frameworks that integrate AI capabilities with existing enterprise infrastructure while building systematic approaches to scalability, reliability, and maintainability through strategic technical design and enterprise system integration. Enterprise architecture assessment includes infrastructure analysis, system inventory, integration point identification, and capability evaluation that provide comprehensive foundation for AI integration while building architectural thinking and systems analysis capability. Assessment should be thorough while remaining actionable and focused on practical integration, rather than academic analysis or excessive technical documentation. System integration planning includes data flow design, API architecture, service mesh configuration, and interface specification that create seamless AI integration while building integration thinking and technical design capability. Planning should be comprehensive while remaining implementable and focused on reliable integration rather than technical complexity or artificial architectural sophistication. Scalability architecture includes horizontal scaling design, load balancing strategy, resource optimization, and performance planning that ensure AI systems can handle enterprise-level usage while building scalability thinking and performance engineering capability. Architecture should be robust while remaining efficient and focused on genuine scalability rather than over-engineering or artificial performance optimization. Security integration includes authentication mechanisms, authorization frameworks, encryption protocols, and compliance alignment that protect AI systems within enterprise security contexts while building security thinking and compliance capability. Integration should be comprehensive while remaining practical and focused on genuine security rather than security theater or artificial compliance complexity. Technology stack optimization includes platform selection, tool integration, framework alignment, and ecosystem coordination that create efficient technical environments while building technology strategy and optimization capability. Optimization should be strategic while remaining practical and focused on business enablement rather than technology elegance or artificial technical sophistication. Microservices and cloud-native AI implementation. Microservices architecture creates modular AI systems while building cloud-native capability and distributed systems expertise essential for modern enterprise AI implementations that require flexibility, scalability, and maintainability. Microservices design includes service decomposition, boundary definition, communication protocols, and orchestration strategy that create flexible AI architectures while building distributed systems thinking and service design capability. Design should be logical while remaining manageable and focused on business functionality rather than technical decomposition or artificial service granularity. Container orchestration includes Docker implementation, Kubernetes deployment, service mesh configuration, and container management that enable scalable AI deployment while building containerization and orchestration capability. Orchestration should be sophisticated while remaining maintainable and focused on operational efficiency rather than container complexity or artificial orchestration sophistication. Cloud platform integration includes AWS, Azure, and GCP utilization, serverless computing, managed services, and cloud-native patterns that leverage cloud capabilities while building cloud expertise and platform capability. Integration should be strategic while remaining cost-effective and focused on business value rather than cloud adoption or artificial cloud sophistication. API design and management includes REST architecture, GraphQL implementation, API gateway configuration, and version management that enable effective service communication while building API thinking and integration capability. Design should be intuitive while remaining robust and focused on developer experience rather than API complexity or artificial interface sophistication. Data pipeline architecture includes streaming processing, batch integration, real-time analytics, and data orchestration that support AI data requirements while building data engineering and pipeline capability. Architecture should be efficient while remaining reliable and focused on data quality rather than pipeline complexity or artificial data processing sophistication. High-performance optimization computing and enterprise-grade performance engineering. Infrastructure. Performance engineering creates optimized AI systems while building performance expertise and optimization capability essential for enterprise AI implementations that require consistent, reliable performance under varying load conditions and usage patterns. Performance analysis includes bottleneck identification, resource utilization assessment, latency measurement, and throughput optimization that reveals system limitations while building performance thinking and analysis capability. Analysis should be systematic while remaining actionable and focused on meaningful optimization rather than micro-optimization or artificial performance complexity. Resource optimization includes CPU utilization, memory management, GPU acceleration, and storage optimization that maximize system efficiency while building resource management and optimization capability. Optimization should be strategic while remaining maintainable and focused on cost-effective performance rather than resource waste or artificial optimization complexity. Caching strategy includes Redis implementation, CDN utilization, application caching, and database optimization that improves system responsiveness while building caching thinking and performance enhancement capability. Strategy should be comprehensive while remaining practical and focused on user experience rather than caching complexity or artificial performance enhancement. Load testing includes stress testing, capacity planning, performance benchmarking, and scalability validation that ensure system reliability while building testing thinking and validation capability. Testing should be rigorous while remaining practical and focused on realistic performance validation rather than artificial testing or superficial load simulation. Monitoring and observability includes metrics collection, performance tracking, alerting systems, and diagnostic capability that enable proactive performance management while building monitoring thinking and operational capability. Monitoring should be comprehensive while remaining actionable and focused on operational insight rather than data collection or artificial monitoring complexity. Infrastructure as code and DevOps integration. Infrastructure as code creates reproducible, maintainable infrastructure while building DevOps capability and automation expertise essential for reliable AI system deployment and management in enterprise environments. Infrastructure automation includes Terraform implementation, CloudFormation usage, configuration management, and deployment automation that create consistent environments while building automation thinking and infrastructure capability. Automation should be comprehensive while remaining maintainable and focused on operational efficiency rather than automation complexity or artificial infrastructure sophistication. CI/CD pipeline development includes build automation, testing integration, deployment orchestration, and release management that enable reliable software delivery while building pipeline thinking and delivery capability. Development should be robust while remaining efficient and focused on delivery reliability rather than pipeline complexity or artificial CI/CD sophistication. Configuration management includes environment consistency, secret management, configuration versioning, and deployment. Coordination that ensure reliable system behavior while building configuration thinking and management capability. Management should be systematic while remaining secure and focused on operational reliability rather than configuration complexity or artificial management sophistication. Version control integration includes GIT workflows, branching strategies, merge management, and collaboration coordination that enable effective team development while building version control thinking and collaboration capability. Integration should be efficient while remaining organized and focused on team productivity rather than version control complexity or artificial collaboration sophistication. Deployment strategy includes blue-green deployment, canary releases, rolling updates, and rollback procedures that enable safe system updates while building deployment thinking and release management capability. Strategy should be cautious while remaining efficient and focused on deployment reliability rather than deployment complexity or artificial release sophistication. 22.2 Production Engineering Excellence and Scalability. Site reliability engineering and system resilience. Comprehensive implementation reliability framework and Site reliability engineering creates robust AI systems while building operational excellence and reliability expertise. Essential for enterprise AI implementations that require consistent availability and performance under diverse operating conditions and unexpected challenges. Reliability engineering includes system design, failure analysis, redundancy planning, and resilience building that create dependable AI systems while building reliability thinking and engineering capability. Engineering should be systematic while remaining practical and focused on genuine reliability rather than over-engineering or artificial reliability complexity. Service availability level objectives include targets, performance standards, error budgets, and quality metrics that define system expectations while building SLO thinking and measurement capability. Objectives should be realistic while remaining ambitious and focused on user experience rather than artificial metrics or superficial quality standards. Incident management includes detection systems, response procedures, escalation protocols, and post-mortem analysis that handle system failures effectively while building incident thinking and crisis management capability. Management should be organized while remaining efficient and focused on rapid resolution rather than bureaucratic process or artificial incident complexity. Chaos engineering includes failure injection, resilience testing, system validation, and weakness identification that improves system robustness while building chaos thinking and testing capability. Engineering should be controlled while remaining comprehensive and focused on genuine resilience rather than destructive testing or artificial chaos complexity. Recovery procedures include backup systems, disaster recovery, business continuity, and system restoration that ensure organizational resilience while building recovery thinking and continuity capability. Procedures should be comprehensive while remaining practical and focused on rapid recovery rather than recovery complexity or artificial continuity sophistication. Autoscaling and resource management. Autoscaling creates responsive AI systems while building elasticity capability and resource management expertise essential for efficient enterprise AI implementations that adapt automatically to changing usage patterns and demand fluctuations. Scaling strategy includes horizontal scaling, vertical scaling, auto-scaling policies, and resource prediction that optimize system capacity while building scaling thinking and capacity management capability. Strategy should be intelligent while remaining cost-effective and focused on demand responsiveness rather than resource waste or artificial scaling complexity. Resource allocation includes CPU scheduling, memory management, GPU utilization, and storage optimization that maximize system efficiency while building resource thinking and allocation capability. Allocation should be dynamic while remaining predictable and focused on performance. Optimization rather than resource complexity or artificial allocation sophistication. Performance monitoring includes real-time metrics, capacity tracking, usage analysis, and trend identification that guide scaling decisions while building monitoring thinking and analytical capability. Monitoring should be comprehensive while remaining actionable and focused on operational insight rather than data collection or artificial monitoring complexity. Cost optimization includes resource efficiency, usage optimization, waste elimination, and budget management that control infrastructure expenses while building cost thinking and financial capability. Optimization should be strategic while remaining service-focused and focused on value maximization rather than cost-cutting or artificial financial optimization. Capacity planning includes demand forecasting, growth projection, resource planning, and infrastructure scaling that prepare for future requirements while building planning thinking and forecasting capability. Planning should be forward-thinking while remaining realistic and focused on prepared scalability rather than over-provisioning or artificial capacity sophistication. Quality assurance and testing frameworks. Comprehensive AI testing methodology. AI testing requires specialized frameworks that address unique challenges of machine learning systems while building quality assurance expertise and testing capability essential for reliable enterprise AI implementations that maintain accuracy and performance over time. AI model testing includes accuracy validation, performance verification, bias detection, and robustness assessment that ensure model quality while building testing thinking and validation capability. Testing should be comprehensive while remaining practical and focused on genuine quality rather than testing complexity or artificial validation sophistication. Data quality assurance includes data validation, schema enforcement, integrity checking, and quality monitoring that ensure reliable model inputs while building data quality thinking and assurance capability. Assurance should be systematic while remaining efficient and focused on data reliability rather than quality bureaucracy or artificial data complexity. Integration testing includes API validation, system integration, end-to-end testing, and workflow verification that ensure complete system functionality while building integration thinking and testing capability. Testing should be thorough while remaining maintainable and focused on system reliability rather than testing complexity or artificial integration sophistication. Performance testing includes load testing, stress testing, endurance testing, and scalability validation that ensure system performance under various conditions while building performance thinking and testing capability. Testing should be realistic while remaining comprehensive and focused on genuine performance rather than artificial testing or superficial performance validation. Regression testing includes model drift detection, performance monitoring, accuracy tracking, and quality maintenance that ensure sustained system quality while building regression thinking and maintenance capability. Testing should be ongoing while remaining efficient and focused on quality preservation rather than testing overhead or artificial regression complexity. Automated testing and continuous validation. Automated testing creates efficient quality assurance while building automation expertise and validation capability essential for scalable enterprise AI implementations that require consistent quality without manual overhead. Test automation includes unit testing, integration testing, system testing, and acceptance testing that ensure comprehensive quality coverage while building automation thinking and testing capability. Automation should be intelligent while remaining maintainable and focused on quality assurance rather than automation complexity or artificial testing sophistication. Continuous integration includes build validation, test execution, quality checking, and feedback provision that enable rapid development cycles while building CI thinking and integration capability. Integration should be seamless while remaining reliable and focused on development efficiency rather than CI complexity or artificial integration sophistication. Quality gates include criteria definition, validation checkpoints, approval processes, and quality enforcement that maintain system standards while building quality thinking and governance capability. Gates should be meaningful while remaining practical and focused on genuine quality rather than bureaucratic process or artificial quality complexity. Automated monitoring includes performance tracking, error detection, anomaly identification, and alert generation that enable proactive quality management while building monitoring thinking and operational capability. Monitoring should be intelligent while remaining actionable and focused on operational insight rather than monitoring complexity or artificial operational sophistication. Validation pipelines include data validation, model testing, system verification, and deployment approval that ensure quality throughout development cycles while building pipeline thinking and validation capability. Pipelines should be comprehensive while remaining efficient and focused on quality assurance rather than pipeline complexity or artificial validation sophistication. 22.3 Security and Compliance in Enterprise. AI Systems. Enterprise security architecture for AI. Comprehensive implementation AI security framework. And AI security requires specialized frameworks that address unique vulnerabilities and threats while building security expertise and protection capability essential for enterprise AI implementations that handle sensitive data and critical business processes. AI security assessment includes threat modeling, vulnerability analysis, attack surface evaluation, and risk assessment that identify security requirements while building security thinking and threat analysis capability. Assessment should be comprehensive while remaining practical and focused on genuine security rather than security theater or artificial threat complexity. Data protection includes encryption implementation, access control, data masking, and privacy preservation that protect sensitive information while building data security thinking and protection capability. Protection should be robust while remaining usable and focused on genuine privacy rather than protection complexity or artificial privacy sophistication. Model security includes adversarial defense, model extraction protection, poisoning prevention, and inference security that protect AI systems from attacks while building AI security thinking and defense capability. Security should be sophisticated while remaining practical and focused on genuine protection rather than security complexity or artificial AI defense sophistication. Control, authentication, and authorization include identity management, access privilege management, and security enforcement that controls system access while building identity. Thinking and access management capability. Authentication should be secure while remaining user-friendly and focused on legitimate access rather than access complexity or artificial security sophistication. Security monitoring includes intrusion detection, anomaly identification, threat hunting, and incident response that enable proactive security management while building security monitoring thinking and operational capability. Monitoring should be intelligent while remaining actionable and focused on genuine threats rather than security noise or artificial monitoring complexity. Zero Trust architecture and network security. Zero Trust architecture creates comprehensive security while building modern security capability and network protection expertise essential for enterprise AI implementations that require security in distributed, cloud-native environments. Zero Trust implementation includes identity verification, device validation, network segmentation, and continuous monitoring that ensure comprehensive security while building Zero Trust thinking and implementation capability. Implementation should be systematic while remaining practical and focused on genuine security rather than Zero Trust complexity or artificial security sophistication. Network segmentation includes micro-segmentation, traffic isolation, access control, and lateral movement prevention that limit security exposure while building network thinking and segmentation capability. Segmentation should be strategic while remaining manageable and focused on security effectiveness rather than network complexity or artificial segmentation sophistication. Security encryption strategy includes data-in-transit protection, data-at-rest key management, and cryptographic implementation that protect information throughout its life cycle while building encryption thinking and cryptographic capability. Strategy should be comprehensive while remaining practical and focused on genuine protection rather than encryption complexity or cryptographic sophistication. Artificial identity and access management includes user authentication, privilege management, role-based access, and identity governance that controls system access while building IAM thinking and access capability. Management should be secure while remaining user-friendly and focused on appropriate access rather than access complexity or artificial IAM sophistication. Compliance monitoring includes regulatory adherence, audit preparation, control validation, and compliance reporting that ensure regulatory compliance while building compliance thinking and governance capability. Monitoring should be systematic while remaining efficient and focused on genuine compliance rather than compliance theater or artificial regulatory complexity. Regulatory compliance and data governance. Enterprise Compliance Framework for AI Systems. Regulatory compliance requires comprehensive frameworks that address complex legal requirements while building compliance expertise and governance capability essential for enterprise AI implementations that operate in regulated industries and handle sensitive data. Compliance assessment includes regulatory analysis, requirement identification, gap assessment, and implementation planning that ensure regulatory adherence while building compliance thinking and regulatory capability. Assessment should be thorough while remaining practical and focused on genuine compliance rather than compliance complexity or artificial regulatory sophistication. GDPR implementation includes privacy rights, consent management, data protection, and breach response that ensure European compliance while building privacy thinking and data protection capability. Implementation should be comprehensive while remaining practical and focused on genuine privacy rather than GDPR complexity or artificial privacy sophistication. HIPAA compliance includes healthcare privacy, security safeguards, access controls, and audit requirements that ensure healthcare regulatory adherence while building healthcare compliance thinking and protection capability. Compliance should be rigorous while remaining practical and focused on patient protection rather than HIPAA complexity or artificial healthcare compliance sophistication. SOX compliance includes financial controls, audit requirements, documentation standards, and reporting procedures that ensure financial regulatory adherence while building financial compliance thinking and control capability. Compliance should be systematic while remaining efficient and focused on financial integrity rather than SOX complexity or artificial financial compliance sophistication. Industry-specific compliance includes sector regulations, professional standards, certification requirements, and specialized compliance that address industry-specific needs while building industry compliance thinking and specialized capability. Compliance should be tailored while remaining comprehensive and focused on industry requirements rather than compliance complexity or artificial specialized sophistication. Data governance and privacy protection. Data governance creates systematic data management while building governance expertise and privacy capability essential for enterprise AI implementations that require responsible data handling and privacy protection. Data governance framework includes data classification, ownership definition, usage policies, and lifecycle management that ensure responsible data handling while building governance thinking and data management capability. Framework should be comprehensive while remaining practical and focused on data value rather than governance complexity or artificial data sophistication. Privacy by design includes privacy integration, protection planning, risk minimization, and compliance assurance that embed privacy throughout system development while building privacy thinking and protection capability. Design should be proactive while remaining practical and focused on genuine privacy rather than privacy complexity or artificial protection sophistication. Data lineage includes data tracking, transformation monitoring, usage documentation, and provenance management that ensure data transparency while building lineage thinking and tracking capability. Lineage should be comprehensive while remaining maintainable and focused on data understanding rather than lineage complexity or artificial tracking sophistication. Consent management includes consent collection, preference management, opt-out handling, and consent documentation that respect user privacy choices while building consent thinking and management capability. Management should be respectful while remaining practical and focused on user control rather than consent complexity or artificial preference sophistication. Data retention includes retention policies, deletion procedures, archival management, and lifecycle enforcement that manage data appropriately while building retention thinking and lifecycle capability. Retention should be systematic while remaining compliant and focused on appropriate data handling rather than retention complexity or artificial lifecycle sophistication. 22.4 Performance optimization and monitoring. Advanced performance engineering and optimization. Comprehensive performance optimization framework. Performance optimization requires systematic approaches that maximize system efficiency while building optimization expertise and performance engineering capability essential for enterprise AI implementations that require consistent, reliable performance under varying conditions. Performance profiling includes bottleneck identification. Algorithm optimization includes computational efficiency, memory optimization, parallel processing, and algorithmic improvement that enhance AI model performance while building optimization thinking and algorithmic capability. Optimization should be strategic while remaining maintainable and focused on genuine performance rather than optimization complexity or algorithmic sophistication. Artificial hardware acceleration includes GPU utilization, TPU integration, specialized processors, and parallel computing that maximize computational performance while building acceleration thinking and hardware capability. Acceleration should be efficient while remaining cost-effective and focused on performance improvement rather than hardware complexity or artificial acceleration sophistication. Memory management includes memory allocation, garbage collection, caching strategy, and memory optimization that optimize system resource usage while building memory thinking and management capability. Management should be intelligent while remaining stable and focused on resource efficiency rather than memory complexity or artificial management sophistication. Database optimization includes query optimization, indexing strategy, connection pooling, and database tuning that improve data access performance while building database thinking and optimization capability. Optimization should be systematic while remaining maintainable and focused on data efficiency rather than database complexity or artificial optimization sophistication. Real-time monitoring and observability. Real-time monitoring creates comprehensive system visibility while building observability expertise and monitoring capability essential for enterprise AI implementations that require proactive performance management and issue detection. Observability architecture includes metrics collection, log aggregation, trace analysis, and monitoring integration that provide comprehensive system insight while building observability thinking and monitoring capability. Architecture should be comprehensive while remaining practical and focused on operational insight rather than monitoring complexity or artificial observability sophistication. Performance metrics include latency tracking, throughput measurement, error monitoring, and availability assessment that quantify system performance while building metrics thinking and measurement capability. Metrics should be meaningful while remaining actionable and focused on user experience rather than metric complexity or artificial measurement sophistication. Alert systems include threshold monitoring, anomaly detection, escalation procedures, and notification management that enable proactive issue response while building alerting thinking and response capability. Systems should be intelligent while remaining reliable and focused on genuine issues rather than alert noise or artificial monitoring complexity. Dashboard development includes visualization design, metric presentation, trend analysis, and operational interfaces that enable effective performance monitoring while building dashboard thinking and visualization capability. Development should be intuitive while remaining comprehensive and focused on operational insight rather than dashboard complexity or artificial visualization sophistication. Performance analysis includes trend identification, pattern recognition, capacity planning, and optimization guidance that inform performance decisions while building analysis thinking and insight capability. Analysis should be insightful while remaining actionable and focused on performance improvement rather than analysis complexity or artificial insight sophistication. Capacity planning and resource management. Strategic capacity planning and resource optimization. Capacity planning creates proactive resource management while building planning expertise and optimization capability essential for enterprise AI implementations that require cost-effective resource utilization and scalability preparation. Capacity modeling includes demand forecasting, resource projection, growth planning, and capacity simulation that predict future requirements while building modeling thinking and forecasting capability. Modeling should be accurate while remaining practical and focused on realistic planning rather than modeling sophistication. Complexity or artificial forecasting. Resource allocation includes CPU assignment, memory distribution, storage planning, and network allocation that optimize system resources while building allocation thinking and resource capability. Allocation should be dynamic while remaining efficient and focused on performance optimization rather than allocation complexity or artificial resource sophistication. Cost optimization includes resource efficiency, usage optimization, waste elimination, and financial management that control infrastructure expenses while building cost thinking and financial capability. Optimization should be strategic while remaining service-focused and focused on value maximization rather than cost-cutting or artificial financial optimization. Scaling strategy includes horizontal scaling, vertical scaling, auto-scaling policies, and elasticity planning that prepare for demand changes while building scaling thinking and elasticity capability. Strategy should be responsive while remaining cost-effective and focused on demand management rather than scaling complexity or artificial elasticity sophistication. Performance forecasting includes trend analysis, capacity projection, demand prediction, and planning guidance that inform capacity decisions while building forecasting thinking and prediction capability. Forecasting should be realistic while remaining forward-thinking and focused on preparation adequacy rather than forecasting complexity or artificial prediction sophistication. Resource efficiency and cost management. Resource efficiency creates cost-effective operations while building efficiency expertise and financial management capability essential for sustainable enterprise AI implementations that balance performance requirements with budget constraints. Efficiency analysis includes resource utilization, waste identification, optimization opportunities, and improvement planning that maximize resource value while building efficiency thinking and optimization capability. Analysis should be comprehensive while remaining practical and focused on genuine efficiency rather than efficiency complexity or artificial optimization sophistication. Cost tracking includes expense monitoring, usage analysis, budget management, and financial reporting that control infrastructure costs while building cost thinking and financial capability. Tracking should be detailed while remaining actionable and focused on cost control rather than tracking complexity or artificial financial sophistication. Budget optimization includes cost allocation, spending optimization, resource planning, and financial efficiency that maximize budget value while building budgeting thinking and financial capability. Optimization should be strategic while remaining service-focused and focused on value creation rather than budget cutting or artificial financial optimization. Usage optimization includes resource efficiency, demand management, capacity utilization, and waste elimination that optimize system usage while building usage thinking and efficiency capability. Optimization should be intelligent while remaining practical and focused on genuine efficiency rather than usage complexity or artificial optimization sophistication. Financial planning includes budget forecasting, cost projection, investment planning, and financial strategy that guide resource decisions while building financial thinking and planning capability. Planning should be realistic while remaining strategic and focused on financial sustainability rather than financial complexity or artificial planning sophistication. 22.5 Vendor management and technology. Selection. Strategic technology evaluation and selection. Comprehensive technology assessment framework. Technology selection requires systematic evaluation that balances technical capabilities with business requirements while building evaluation expertise and strategic thinking capability essential for enterprise AI implementations that require optimal technology choices and vendor relationships. Technology evaluation includes capability assessment, requirement matching, performance analysis, and strategic fit evaluation that guide technology decisions while building evaluation thinking and analysis capability. Evaluation should be rigorous while remaining practical and focused on business value rather than technical complexity or artificial evaluation sophistication. Vendor assessment includes company evaluation, financial stability, technical capability, and support quality that inform vendor selection while building vendor thinking and relationship capability. Assessment should be comprehensive while remaining practical and focused on partnership potential rather than vendor complexity or artificial assessment sophistication. Cost-benefit analysis includes total cost evaluation, benefit quantification, ROI calculation, and value assessment that inform investment decisions while building financial thinking. An analysis capability. Analysis should be thorough while remaining realistic and focused on genuine value rather than financial complexity or artificial cost-benefit sophistication. Risk assessment includes technical risk, vendor risk, implementation risk, and strategic risk that identify potential challenges while building risk thinking and mitigation capability. Assessment should be comprehensive while remaining practical and focused on risk management rather than risk complexity or artificial assessment sophistication. Integration evaluation includes compatibility assessment, integration complexity, technical requirements, and implementation planning that ensure successful technology adoption while building integration thinking and planning capability. Evaluation should be practical while remaining thorough and focused on implementation success rather than integration complexity or artificial evaluation sophistication. Multi-vendor strategy and ecosystem management. Multi-vendor strategy creates optimized technology ecosystems while building ecosystem expertise and vendor management capability essential for enterprise AI implementations that leverage multiple specialized technologies and vendor relationships. Ecosystem design includes technology integration, vendor coordination, platform strategy, and architecture planning that create coherent technology environments while building ecosystem thinking and design capability. Design should be strategic while remaining manageable and focused on technology synergy rather than ecosystem complexity or artificial design sophistication. Vendor relationship management includes partnership development, contract negotiation, performance management, and relationship maintenance that optimize vendor value while building relationship thinking and management capability. Management should be collaborative while remaining strategic and focused on mutual benefit rather than vendor complexity or artificial relationship sophistication. Integration strategy includes API management, data integration, workflow coordination, and system orchestration that enable effective multi-vendor environments while building integration thinking and coordination capability. Strategy should be comprehensive while remaining practical and focused on operational efficiency rather than integration complexity or artificial strategy sophistication. Contract management includes agreement negotiation, SLA definition, performance monitoring, and relationship governance that ensure vendor accountability while building contract thinking and management capability. Management should be professional while remaining collaborative and focused on partnership success rather than contract complexity or artificial management sophistication. Technology roadmap includes evolution planning, upgrade strategy, migration planning, and technology advancement that guide long-term technology decisions while building roadmap thinking and planning capability. Roadmap should be forward-thinking while remaining realistic and focused on business alignment rather than roadmap complexity or artificial planning sophistication. Platform strategy and architecture decisions. Enterprise platform strategy development. Platform strategy creates systematic technology foundation while building platform expertise and architectural capability essential for enterprise AI implementations that require scalable, maintainable technology platforms supporting diverse organizational needs. Platform assessment includes capability evaluation, scalability analysis, integration potential, and strategic alignment that inform platform decisions while building platform thinking and evaluation capability. Assessment should be comprehensive while remaining practical and focused on business enablement rather than platform complexity or artificial assessment sophistication. Architecture decisions include platform selection, integration design, scalability planning, and technology coordination that create robust technology foundations while building architecture thinking and design capability. Decisions should be strategic while remaining implementable and focused on long-term value rather than architecture complexity or artificial design sophistication. Migration strategy includes transition planning, risk mitigation, timeline development, and change management that enable successful platform adoption while building migration thinking and planning capability. Strategy should be systematic while remaining practical and focused on transition success rather than migration complexity or artificial strategy sophistication. Interoperability design includes standard adoption, interface specification, protocol implementation, and integration facilitation that enable technology coordination while building interoperability thinking and design capability. Design should be open while remaining practical and focused on system coordination rather than interoperability complexity or artificial design sophistication. Technology standardization includes standard definition, tool selection, practice establishment, and consistency maintenance that create coherent technology environments while building standardization thinking and management capability. Standardization should be beneficial while remaining flexible and focus standardization sophistication. On operational complexity or build versus buy decision framework. Efficiency artificial rather than consistency. Build versus buy decisions require systematic evaluation that optimizes resource allocation while building decision-making expertise and strategic thinking capability essential for enterprise AI implementations that require optimal technology investment decisions. Decision framework includes criteria definition, evaluation methodology, option analysis, and recommendation. Development that guide technology decisions while building decision thinking and analysis capability. Framework should be systematic while remaining practical and focused on optimal decisions rather than decision complexity or artificial framework sophistication. Build analysis includes development cost, resource requirements, timeline assessment, and capability evaluation that assess internal development options while building build thinking and development capability. Analysis should be realistic while remaining comprehensive and focused on development feasibility rather than build complexity or artificial development sophistication. Buy analysis includes vendor evaluation, cost assessment, integration requirements, and customization needs that assess external technology options while building buy thinking and vendor capability. Analysis should be thorough while remaining practical and focused on vendor value rather than buy complexity or artificial evaluation sophistication. Hybrid approaches include partial development, vendor partnership, custom integration, and blended solutions that optimize technology decisions while building hybrid thinking and solution capability. Approaches should be creative while remaining practical and focused on optimal solutions rather than hybrid complexity or artificial solution sophistication. Long-term considerations include technology evolution, maintenance requirements, upgrade paths, and strategic alignment that inform technology decisions while building long-term thinking and strategic capability. Consideration should be forward-thinking while remaining realistic and focused on sustainable technology rather than long-term complexity or artificial strategic sophistication. 22.6 Technical Leadership Development and Team Management. Advanced technical leadership and team building. Technical leadership excellence and team development. Technical leadership requires sophisticated people management while building leadership expertise and team development capability essential for enterprise AI implementations that require effective technical teams and organizational technology capability. Technical leadership includes vision development, team inspiration, technical guidance, and organizational impact that create effective technology leadership while building leadership thinking and influence capability. Leadership should be authentic while remaining effective and focused on team success rather than leadership complexity or artificial authority sophistication. Team building includes talent acquisition, skill development, collaboration facilitation, and culture creation that build effective technical teams while building team thinking and development capability. Building should be systematic while remaining organic and focused on team effectiveness rather than team complexity or artificial development sophistication. Mentoring and coaching includes individual development, skill guidance, career support, and knowledge transfer that develop team members while building mentoring thinking and development capability. Mentoring should be generous while remaining practical and focused on individual growth rather than mentoring complexity development sophistication. Or artificial. Performance management includes goal setting, progress tracking, feedback provision, and development planning that optimize team performance while building management thinking and performance capability. Management should be supportive while remaining accountable and focused on team success rather than management complexity or artificial performance sophistication. Technical communication includes knowledge sharing, documentation creation, presentation development, and stakeholder engagement that enable effective technical communication while building communication thinking and influence capability. Communication should be clear while remaining comprehensive and focused on understanding rather than communication complexity or artificial presentation sophistication. Cross-functional collaboration, stakeholder management and cross-functional collaboration creates effective organizational integration while building collaboration expertise and stakeholder management capability essential for enterprise AI. Implementations that require coordination across diverse organizational functions and expertise areas. Stakeholder management includes relationship building, expectation management, communication coordination, and value delivery that create effective stakeholder relationships while building stakeholder thinking and relationship capability. Management should be professional while remaining authentic and focused on mutual benefit rather than stakeholder complexity or artificial relationship sophistication. Cross-functional coordination includes team coordination, project alignment, resource coordination, and delivery synchronization that enable effective organizational collaboration while building coordination thinking and management capability. Coordination should be efficient while remaining inclusive and focused on collective success rather than coordination complexity or artificial collaboration sophistication. Technical communication includes concept explanation, requirement clarification, solution presentation, and progress reporting that enable effective technical business communication while building communication thinking and translation capability. Communication should be accessible while remaining accurate and focused on understanding rather than communication complexity or artificial translation sophistication. Conflict resolution includes disagreement management, compromise development, solution creation, and relationship repair that address organizational conflicts while building resolution thinking and mediation capability. Resolution should be fair while remaining effective and focused on team success rather than conflict complexity or artificial resolution sophistication. Change leadership includes transformation guidance, adaptation facilitation, resistance management, and culture development that enable organizational change while building change thinking and leadership capability. Leadership should be supportive while remaining decisive and focused on change success rather than change complexity or artificial leadership sophistication. Innovation management and technical strategy. Innovation leadership and technology advancement. Innovation management creates systematic advancement while building innovation expertise and technology strategy capability essential for enterprise AI implementations that require ongoing technological advancement and competitive capability development. Innovation strategy includes opportunity identification, resource allocation, timeline development, and impact planning that guide innovation efforts while building innovation thinking and strategy capability. Strategy should be strategic while remaining practical and focused on meaningful innovation rather than innovation complexity or artificial strategy sophistication. Technology scouting includes emerging technology monitoring, capability assessment, potential evaluation, and adoption planning that identify innovation opportunities while building scouting thinking and evaluation capability. Scouting should be systematic while remaining practical and focused on actionable opportunities rather than scouting complexity or artificial evaluation sophistication. Research and development includes experimental projects, proof of concept development, technology validation, and advancement planning that enable innovation while building R&D thinking and development capability. Development should be systematic while remaining creative and focused on genuine advancement rather than R&D complexity or artificial innovation sophistication. Intellectual property includes patent development, trade secret protection, knowledge management, and IP strategy that protect innovation while building IP thinking and protection capability. Property should be valuable while remaining practical and focused on genuine protection rather than IP complexity or artificial property sophistication. Innovation culture includes creativity encouragement, experimentation support, failure tolerance, and learning facilitation that foster innovation while building culture thinking and development capability. Culture should be authentic while remaining productive and focused on genuine innovation rather than culture complexity or artificial innovation sophistication. Technical vision and strategic planning. Technical vision creates strategic technology direction while building vision expertise and planning capability essential for enterprise AI implementations that require long-term technology strategy and organizational technology capability development. Vision development includes future state articulation, technology roadmap creation, capability planning, and strategic alignment that create technical direction while building vision thinking and strategy capability. Development should be inspiring while remaining achievable and focused on practical vision rather than vision complexity or artificial strategy sophistication. Technology roadmap includes capability evolution, upgrade planning, integration strategy, and timeline development that guide technology advancement while building roadmap thinking and planning capability. Roadmap should be comprehensive while remaining flexible and focused on business alignment rather than roadmap complexity or artificial planning sophistication. Strategic planning includes goal setting, resource allocation, timeline development, and success measurement that guide technical initiatives while building planning thinking and strategy capability. Planning should be systematic while remaining adaptable and focused on strategic success rather than planning complexity or artificial strategy sophistication. Risk management includes threat identification, mitigation planning, contingency development, and risk monitoring that address technical risks while building risk thinking and management capability. Management should be prudent while remaining innovative and focused on risk balance rather than risk complexity or artificial management sophistication. Organizational alignment includes business integration, stakeholder coordination, communication strategy, and value demonstration that ensure technical strategy serves organizational needs while building alignment thinking and integration capability. Alignment should be comprehensive while remaining practical and focused on business value rather than alignment sophistication. Complexity or artificial integration. Chapter 22 Conclusion: Technical Integration Specialists as Enterprise AI Architecture Leaders. Chapter 22 establishes the comprehensive framework for developing technical integration specialists who can design, implement, and maintain enterprise-grade AI systems that operate reliably at scale while building the technical expertise, system architecture, and engineering leadership capabilities essential for senior technical roles. The Advanced AI Architecture and Systems Integration Framework provides sophisticated methodologies for enterprise AI implementation while building architectural thinking and integration capabilities that enable specialists to design robust, scalable systems that integrate seamlessly with existing enterprise infrastructure. The Production Engineering Excellence and Scalability Development creates operational expertise and reliability capabilities essential for maintaining AI systems in production environments while building site reliability engineering and quality assurance skills that ensure consistent system performance and availability. The security and compliance framework builds comprehensive protection capability while creating regulatory expertise and governance skills that ensure AI systems meet enterprise security standards and regulatory requirements, building trust and enabling adoption in regulated environments. The performance optimization and monitoring components develop efficiency expertise while creating observability capabilities that ensure AI systems operate at optimal performance levels with proactive issue detection and resolution, building skills essential for enterprise-grade system management. The vendor management and technology selection frameworks build strategic thinking while creating evaluation capabilities that enable optimal technology choices and vendor relationships, ensuring AI implementations leverage the best technologies while maintaining architectural available coherence. The technical leadership development components create people management capability while building innovation expertise and strategic planning skills that enable technical integration specialists to lead technical teams and guide organizational technology strategy for sustained competitive advantage. The comprehensive 6-month specialization track established in Chapter 22 transforms foundational AI fluent professionals into technical architecture leaders capable of designing and implementing enterprise-grade AI systems that create lasting technical capability while building careers as senior technical leaders and AI engineering executives. This specialization track represents recognition that successful enterprise AI adoption requires not just technically competent professionals but technical leaders who can architect, implement, and maintain robust AI systems that meet enterprise requirements for reliability, security, scalability, and performance while leading technical teams and advancing organizational technology capability. Introduction of Chapter 23. Human-centered transformation leadership advanced change management, comprehensive frameworks for leading large-scale AI adoption with focus on human psychology and sustainable behavior change organizational psychology, deep understanding of individual and group behavior patterns, resistance management, and culture transformation strategies. Stakeholder coalition building, systematic approaches to building authentic support networks and managing complex organizational dynamics. Cultural evolution, organic culture change methodologies that embed AI adoption into organizational DNA through value alignment and norm development. User experience and accessibility excellence. AI-specific UX design, specialized interface design principles addressing unique challenges of human-AI interaction, trust building, and transparency. Inclusive design, universal design frameworks ensuring AI systems serve diverse user populations with varying abilities, backgrounds, and technical expertise. Trust and explainability, systematic approaches to building user confidence through transparent AI decision-making and appropriate explanation levels. Adaptive interfaces, personalization frameworks that evolve AI experiences based on individual user needs, preferences, and skill development. Training and knowledge development ADL. T-learning frameworks, evidence-based educational methodologies specifically designed for AI skill development across diverse organizational roles. Curriculum design, systematic instructional development including learning objectives, content organization, and competency-based assessment. Knowledge transfer, organizational learning systems that preserve expertise, facilitate mentoring, and build sustainable internal capability. Training effectiveness, comprehensive measurement frameworks for evaluating learning impact and organizational capability enhancement. Community building and network development. Professional learning communities, strategic development of supportive networks that accelerate AI adoption through peer learning and mutual support. Innovation networks, collaborative frameworks that leverage collective creativity and shared experimentation for breakthrough development. Leadership pipeline, systematic champion identification and development programs that create sustainable organizational AI leadership. Knowledge preservation, institutional memory systems that capture tacit knowledge and enable continuous organizational learning. Human-AI collaboration optimization. Partnership design, systematic frameworks for optimizing complementary human-AI capabilities through strategic task allocation and workflow integration. Communication systems, effective human-AI interaction patterns including feedback loops, error handling, and mutual adaptation mechanisms. Agency preservation, ethical frameworks ensuring AI enhances rather than diminishes human autonomy, decision-making authority, and meaningful work. Responsibility management, clear accountability systems that maintain human oversight while leveraging AI capabilities effectively. Sustainable adoption and empowerment. Behavior change psychology, scientific approaches to motivation, habit formation, and sustained behavior modification for lasting AI adoption. Resistance transformation, constructive strategies for converting skepticism into support through concern validation and trust building. Social influence, ethical leverage of peer pressure, social proof, and network effects to accelerate positive adoption patterns. Continuous evolution, adaptive frameworks that enable ongoing improvement and evolution of human-AI collaboration over time. Chapter Innovation. Chapter 23 establishes human-centered design specialists as the empathy architects of AI transformation who prioritize human flourishing, design AI implementations that enhance rather than replace human capabilities while maintaining dignity and agency. Bridge psychology and technology, apply sophisticated understanding of human behavior to create AI adoption strategies that work with natural psychological patterns. Create sustainable change, build organizational cultures and learning systems that support long-term AI evolution through human empowerment. Ensure ethical implementation, maintain human oversight and meaningful work while leveraging AI capabilities for genuine organizational benefit. The comprehensive human-centered framework addresses the critical gap between technical AI capability and human adoption success by developing professionals who understand that technology adoption is fundamentally human, success depends more on human factors than technical sophistication. Resistance is information, skepticism often reveals legitimate concerns that can be addressed through thoughtful design and communication. Community accelerates change, peer support and collaborative learning create more sustainable adoption than individual training. Empowerment enables excellence. AI implementations succeed when people feel more capable and valuable, not threatened or diminished. This specialization transforms foundational AI-fluent professionals into organizational transformation leaders who ensure AI adoption creates positive human impact while achieving business objectives through sustainable, empowerment-focused approaches that build lasting organizational capability and competitive advantage. The human-centered approach recognizes that in our increasingly AI-driven world, the organizations that succeed will be those that best integrate human creativity, empathy, and judgment with AI capabilities, making human-centered design specialists essential for sustainable competitive advantage. Chapter 23. Human-centered design specialist track design. Chapter Introduction, Advanced Human-AI Collaboration Leadership for Organizational Transformation. Chapter 23 establishes the comprehensive framework for the Human-Centered Design Specialist Track, a 6-month advanced professional development program that builds upon the foundational 90-day AI-Fluent Professional competencies to create organizational transformation leaders capable of designing and implementing AI adoption initiatives that prioritize human experience, enhance rather than replace human capabilities, and create sustainable organizational cultures that embrace AI as a tool for human empowerment and capability enhancement. The Human-Centered Design Specialist Track recognizes that while foundational AI fluency creates competent professionals who can contribute to AI initiatives, organizations also need human-centered leaders who can design AI implementations that succeed through human adoption rather than technical deployment, ensuring that AI technologies enhance human work satisfaction, capability, and organizational effectiveness rather than creating resistance, displacement, or operational disruption. This advanced specialization operates on the principle that successful enterprise AI adoption requires professionals who combine deep understanding of human psychology and organizational behavior with sophisticated knowledge of AI capabilities, user experience design methodologies, and change management frameworks that ensure AI implementations serve human needs while achieving business objectives through sustainable adoption and engagement. The 6-month intensive development framework provides systematic progression from foundational AI fluency through advanced human-centered design competency while building the organizational psychology, user experience design, and change leadership capabilities essential for senior organizational development roles and human-centered transformation consulting opportunities. The curriculum integrates cutting-edge organizational psychology research with practical AI adoption experience while building the empathy, design thinking, and leadership presence required to guide organizations through complex human-centered AI implementations that create lasting positive impact on both individual work experience and organizational capability. The specialization track prepares participants for roles such as Chief People Officer, VP of Organizational Development, Director of User Experience, and senior consulting positions where they will be responsible for designing and implementing AI adoption strategies that prioritize human flourishing while achieving business objectives through sustainable, human-centered transformation approaches. 23.1 Advanced Change Management. Leading large-scale AI adoption initiatives. Comprehensive organizational change framework. Strategic change leadership and transformation management. Advanced change management requires sophisticated frameworks that address complex human dynamics while building change leadership expertise and organizational transformation capability essential for successful large-scale AI adoption initiatives that require sustained human behavior change and cultural evolution. Change readiness assessment includes organizational culture evaluation, stakeholder analysis, resistance pattern identification, and change capacity determination that provide foundation for transformation planning while building change thinking and assessment capability. Assessment should be honest while remaining constructive and focused on practical change preparation rather than academic analysis or superficial readiness evaluation. Transformation strategy development includes vision creation, stakeholder engagement, communication planning, and implementation roadmap that guide comprehensive change initiatives while building strategic thinking and transformation capability. Development should be inspiring while remaining achievable and focused on sustainable change rather than temporary compliance or artificial transformation claims. Stakeholder identification, coalition alliance building formation, includes influence champion network development and resistance management that create organizational support while building political acumen and relationship capability. Building should be authentic while remaining strategic and focused on mutual benefit rather than manipulation or artificial coalition construction. Change communication includes message crafting, channel selection, timing optimization, and feedback integration that enable effective transformation communication while building communication thinking and influence capability. Communication should be transparent while remaining motivating and focused on genuine engagement rather than promotional messaging sophistication or artificial communication. Cultural transformation includes belief system evolution, behavior pattern modification, norm establishment, and value alignment that creates sustainable organizational change while building culture thinking and development capability. Transformation should be organic while remaining intentional and focused on authentic culture change rather than superficial cultural manipulation or artificial culture sophistication. Large-scale implementation and change orchestration. Large-scale change orchestration creates systematic transformation while building implementation expertise and coordination capability essential for enterprise AI adoption initiatives that require simultaneous change across multiple organizational levels and functional areas. Implementation Planning includes phase sequencing, milestone definition, resource allocation, and timeline coordination that creates systematic transformation approach while building planning thinking and implementation capability. Planning should be comprehensive while remaining flexible and focused on successful execution rather than planning complexity or artificial implementation sophistication. Multi-level change coordination includes executive alignment, middle management engagement, frontline adoption, and cross-functional integration that ensure comprehensive organizational change while building coordination thinking and management capability. Coordination should be systematic while remaining organic and focused on collective success rather than coordination complexity or artificial management sophistication. Resistance management includes objection understanding, concern addressing, skepticism conversion, and opposition transformation that address change barriers while building resistance thinking and resolution capability. Management should be respectful while remaining persistent and focused on genuine concern resolution rather than resistant suppression or artificial opposition management. Change momentum building includes early wins creation, success celebration, progress communication, and energy sustaining that maintain transformation energy while building momentum thinking and motivation capability. Building should be authentic while remaining strategic and focused on genuine progress rather than artificial momentum or superficial celebration claims. Sustainability assurance includes habit formation, system integration, reinforcement mechanism, and culture embedding that ensure lasting change while building sustainability thinking and maintenance capability. Assurance should be systematic while remaining natural and focused on permanent adoption, rather than temporary compliance or artificial sustainability claims. Psychology of technology adoption and human behavior. Human psychology of AI acceptance and resistance. Understanding human psychology creates effective adoption strategies while building psychological expertise and behavior change capability essential for AI implementations that succeed through genuine human acceptance rather than mandate compliance or technological force. Adoption psychology includes motivation understanding, fear addressing, benefit recognition, and acceptance facilitation that guide human-centered implementation while building psychology thinking and behavior capability. Psychology should be empathetic while remaining practical and focused on genuine understanding rather than psychological manipulation or artificial behavior modification. Cognitive bias management includes bias recognition, decision-making understanding, perception influence, and thinking pattern awareness that address human decision-making in AI adoption while building cognitive thinking and bias capability. Management should be respectful while remaining educational and focused on improved decision-making rather than bias exploitation or artificial cognitive manipulation. Emotional intelligence includes emotion recognition, feeling validation, anxiety management, and confidence building that address emotional aspects of AI adoption while building emotional thinking and relationship capability. Intelligence should be genuine while remaining professional and focused on emotional support rather than emotional manipulation or artificial emotional sophistication. Social influence includes peer pressure understanding, social proof utilization, group dynamics management, and community building that leverage social factors in AI adoption while building social thinking and influence capability. Influence should be ethical while remaining effective and focused on positive social dynamics rather than social manipulation or artificial influence tactics. Behavior modification includes habit formation, routine integration, skill development, and practice facilitation that enable lasting behavior change while building behavior thinking and modification capability. Modification should be supportive while remaining systematic and focused on sustainable behavior change rather than temporary compliance or artificial behavior control. Organizational psychology and culture development. Organizational psychology creates systematic culture change while building organizational expertise and development capability essential for AI adoption initiatives that require fundamental shifts in organizational culture and collective behavior patterns. Culture assessment includes belief identification, value analysis, norm recognition, and behavior pattern evaluation that reveal organizational culture dynamics while building culture. Thinking and assessment capability. Assessment should be comprehensive while remaining practical and focused on culture understanding rather than culture complexity or artificial assessment sophistication. Psychological safety includes trust building, openness encouragement, vulnerability acceptance, and learning facilitation that create environment supporting AI experimentation while building safety thinking and trust capability. Safety should be authentic while remaining productive and focused on genuine psychological safety rather than superficial comfort or artificial safety claims. Learning organization development includes continuous learning, adaptation capability, knowledge sharing, and improvement culture that create organizations capable of AI evolution while building learning thinking and development capability. Development should be systematic while remaining organic and focused on genuine learning rather than learning complexity or artificial development sophistication. Identity and meaning includes purpose alignment, role redefinition, value creation, and significance building that help individuals find meaning in AI-enhanced work while building meaning thinking and purpose capability. Identity should be authentic while remaining practical and focused on genuine purpose rather than artificial meaning or superficial identity manipulation. Collective efficacy includes group confidence, shared capability, collaborative success, and team empowerment that build organizational confidence in AI adoption while building efficacy thinking and empowerment capability. Efficacy should be earned while remaining encouraging and focused on genuine capability rather than empowerment claims. False confidence or artificial. 23.2 User experience design for AI. Creating intuitive and empowering AI. Interfaces. Human-computer interaction for AI systems. AI-specific user experience design principles. AI user experience requires specialized design principles that address unique challenges of human-AI interaction while building UX expertise and design capability essential for AI implementations that feel natural, trustworthy, and empowering to users across diverse organizational contexts. AI UX principles include transparency design, control preservation, feedback provision, and trust building that create positive human-AI interaction while building UX thinking and design capability. Principles should be user-centered while remaining practical and focused on genuine user benefit rather than design complexity or artificial UX sophistication. Interface design includes conversation design, visualization creation, interaction patterns, and workflow integration that enable effective AI system usage while building interface thinking and design capability. Design should be intuitive while remaining powerful and focused on user effectiveness rather than interface complexity or artificial design sophistication. Information architecture includes data organization, content structure, navigation design, and cognitive load management that create comprehensible AI systems while building architecture thinking and organization capability. Architecture should be logical while remaining accessible and focused on user understanding rather than architecture complexity or artificial organization sophistication. Interaction design includes gesture definition, response patterns, feedback systems, and control mechanisms that enable effective human-AI collaboration while building interaction thinking and design capability. Design should be natural while remaining efficient and focused on user comfort rather than interaction complexity or artificial design sophistication. Accessibility design includes inclusive design, disability accommodation, diverse needs consideration, and universal access that ensure AI systems serve all users while building accessibility thinking and inclusive capability. Design should be comprehensive while remaining practical and focused on genuine accessibility rather than compliance theater or artificial inclusion claims. Trust, transparency, and explainability in AI interfaces. Trust building creates reliable human-AI relationships while building trust expertise and transparency capability essential for AI implementations that require user confidence and understanding for successful adoption and effective utilization. Trust design includes credibility building, reliability demonstration, competence communication, and benevolent signaling that create user confidence in AI systems while building trust thinking and design capability. Design should be authentic while remaining systematic and focused on genuine trustworthiness rather than trust manipulation or artificial credibility claims. Transparency implementation includes decision explanation, process visibility, limitation disclosure, and capability communication that enable user understanding of AI systems while building transparency thinking and explanation capability. Implementation should be clear while remaining appropriate and focused on useful understanding rather than transparency complexity or artificial explanation sophistication. Explainability design includes explanation generation, rationale communication, alternative presentation, and user-appropriate disclosure that make AI decision-making understandable while building explainability thinking and communication capability. Design should be comprehensible while remaining accurate and focused on user comprehension rather than explanation complexity or artificial explainability sophistication. Error communication includes mistake acknowledgement, limitation disclosure, uncertainty expression, and recovery guidance that handle AI system limitations gracefully while building error thinking and communication capability. Communication should be honest while remaining constructive and focused on user guidance rather than system criticism or artificial error sophistication. Confidence indication includes certainty communication, probability expression, reliability signaling, and quality indication that help users understand AI system confidence levels while building confidence thinking and indication capability. Indication should be accurate while remaining usable and focused on user decision-making rather than confidence complexity or artificial indication sophistication. Inclusive design and accessibility. Universal design for AI systems. Universal design creates accessible AI systems while building inclusive design expertise and accessibility capability essential for AI implementations that serve diverse user populations with varying abilities, backgrounds, and technological experience levels. Inclusive design principles include diversity consideration, barrier removal, flexible usage, and equitable access that create AI systems serving all users while building inclusive thinking and design capability. Principles should be comprehensive while remaining practical and focused on genuine inclusion rather than design complexity or artificial accessibility sophistication. Accessibility implementation includes screen reader compatibility, keyboard navigation, visual accommodation, and motor accessibility that enable diverse ability usage while building accessibility thinking and implementation capability. Implementation should be thorough while remaining usable and focused on functional accessibility rather than compliance theater or artificial accommodation sophistication. Cultural sensitivity includes cultural awareness, language accommodation, context consideration, and value respect that create culturally appropriate AI systems while building cultural thinking and sensitivity capability. Sensitivity should be genuine while remaining practical and focused on cultural respect rather than cultural complexity or artificial sensitivity sophistication. Digital literacy accommodation includes skill level consideration, learning support, guidance provision, and progressive disclosure that accommodate varying technical expertise while building literacy thinking and accommodation capability. Accommodation should be supportive while remaining empowering and focused on user capability building rather than patronizing accommodation claims. Personalization and simplification. Adaptation accommodation usage pattern includes or learning, artificial, preference interface customization, and individual optimization that create personally relevant personalization AI experiences while building thinking and customization capability. Personalization should be respectful while remaining valuable and focused on user preference rather than personalization complexity or artificial customization sophistication. Adaptive interfaces and personalization. Adaptive interfaces create personalized AI experiences while building adaptation expertise and customization capability essential for AI implementations that evolve to meet individual user needs and preferences while maintaining consistency and reliability. Adaptive design includes learning algorithms, preference detection, behavior analysis, and interface evolution that create personalized experiences while building adaptive thinking and design capability. Design should be intelligent while remaining predictable and focused on user benefit rather than adaptation complexity or artificial personalization sophistication. User modeling includes preference learning, skill assessment, context understanding, and behavior prediction that enable effective personalization while building modeling thinking and user capability. Modeling should be accurate while remaining respectful and focused on user service rather than user analysis or artificial modeling sophistication. Customization frameworks include preference settings, interface modification, workflow adaptation, and personal configuration that enable user control over AI experiences while building customization thinking and control capability. Frameworks should be flexible while remaining manageable and focused on user empowerment rather than customization complexity or artificial control sophistication. Progressive disclosure includes information layering, complexity management, skill-appropriate presentation, and gradual revelation that accommodate diverse user expertise. While building disclosure thinking and presentation capability. Disclosure should be appropriate while remaining comprehensive and focused on user understanding rather than disclosure complexity or artificial presentation sophistication. Context awareness includes situation understanding, environment adaptation, task recognition, and contextual optimization that create relevant AI experiences while building context thinking and awareness capability. Awareness should be intelligent while remaining non-intrusive and focused on user relevance rather than context complexity or artificial awareness sophistication. 23.3 Training Program Development. Designing effective AI education for diverse audiences. Adult learning principles for AI education. Comprehensive adult learning framework for AI training. Adult learning principles create effective AI education while building educational expertise and instructional capability essential for AI training programs that succeed through genuine skill development rather than information transfer, ensuring learners can apply AI knowledge effectively in their professional contexts. Adult learning theory includes motivation understanding, experience integration, relevance emphasis, and self-direction facilitation that guide effective AI education while building learning thinking and educational capability. Theory should be practical while remaining evidence-based and focused on genuine learning rather than educational complexity or artificial pedagogical sophistication. Experiential learning includes hands-on practice, real-world application, project-based learning, and practical experience that enable effective skill development while building experiential thinking and application capability. Learning should be engaging while remaining practical and focused on skill transfer rather than activity complexity or artificial experiential sophistication. Motivation and engagement includes intrinsic motivation, goal alignment, interest cultivation, and engagement maintenance that sustain learning commitment while building motivation thinking and engagement capability. Motivation should be authentic while remaining systematic and focused on genuine interest rather than motivation manipulation or artificial engagement tactics. Learning style accommodation includes visual learning, auditory processing, kinesthetic engagement, and style diversity that serve diverse learning preferences while building accommodation thinking and diversity capability. Accommodation should be inclusive while remaining practical and focused on learning effectiveness rather than style complexity or artificial accommodation sophistication. Assessment and feedback includes competency measurement, progress tracking, feedback provision, and improvement. Guidance that support learning development while building assessment thinking and feedback capability. Assessment should be meaningful while remaining supportive and focused on learning improvement rather than assessment complexity or artificial evaluation sophistication. Curriculum design and instructional development. Curriculum design creates systematic AI education while building instructional expertise and program development capability essential for AI training that builds genuine competency through well-structured learning experiences and progressive skill development. Learning definition and objectives include skill specification, outcome competency targets, performance expectations that guide curriculum development while building objective thinking and design capability. Objectives should be clear while remaining achievable and focused on practical competency rather than objective complexity or artificial specification sophistication. Content organization includes logical sequencing, skill progression, knowledge building, and concept integration that create effective learning pathways while building organization thinking and structure capability. Organization should be intuitive while remaining comprehensive and focused on learning effectiveness rather than content complexity or artificial organization sophistication. Instructional strategies include teaching methods, delivery approaches, engagement techniques, and learning facilitation that enable effective knowledge transfer while building instructional thinking and delivery capability. Strategies should be varied while remaining effective and focused on learning success rather than strategy complexity or artificial instructional sophistication. Learning activities include exercises, projects, simulations, and practice opportunities that enable skill development while building activity thinking and design capability. Activities should be meaningful while remaining practical and focused on skill building rather than activity complexity or artificial engagement sophistication. Assessment design includes evaluation methods, competency measurement, progress tracking, and certification criteria that validate learning achievement while building assessment thinking and evaluation capability. Design should be rigorous while remaining fair and focused on genuine competency rather than assessment sophistication. Complexity or artificial evaluation. Organizational learning and knowledge management. Knowledge transfer capability building and organizational. Knowledge transfer creates organizational learning while building transfer expertise and capability development essential for AI implementations that require widespread organizational knowledge and sustained competency development across diverse roles and functions. Knowledge management includes information organization, expertise capture, knowledge sharing, and institutional memory that preserve and distribute AI knowledge while building knowledge thinking and management capability. Management should be systematic while remaining accessible and focused on knowledge utility rather than management complexity or artificial knowledge sophistication. Expert knowledge extraction includes tacit knowledge capture, experience documentation, wisdom preservation, and expertise transfer that enable organizational learning while building extraction thinking and documentation capability. Extraction should be comprehensive while remaining practical and focused on knowledge preservation rather than extraction complexity or artificial documentation sophistication. Learning community development includes peer learning, knowledge sharing, collaborative learning, and community building that create organizational learning networks while building community thinking and development capability. Development should be organic while remaining structured and focused on genuine learning rather than community complexity or artificial collaboration sophistication. Mentoring programs include mentor development, relationship facilitation, knowledge transfer, and guidance provision that enable individual learning while building mentoring thinking and program capability. Programs should be supportive while remaining systematic and focused on individual development rather than program complexity or artificial mentoring sophistication. Organizational memory includes knowledge retention, institutional learning, experience preservation, and wisdom accumulation that create learning organizations while building memory thinking and institutional capability. Memory should be valuable while remaining accessible and focused on organizational benefit rather than memory complexity or artificial institutional sophistication. Training effectiveness and impact measurement. Training effectiveness creates measurable learning impact while building evaluation expertise and assessment capability essential for AI training programs that demonstrate genuine skill development and organizational capability enhancement through systematic measurement and improvement. Impact measurement includes learning assessment, behavior change, performance improvement, and organizational benefit that evaluate training effectiveness while building measurement thinking and evaluation capability. Measurement should be comprehensive while remaining practical and focused on genuine impact rather than measurement complexity or artificial evaluation sophistication. Learning analytics includes data collection, pattern analysis, insight generation, and improvement guidance that optimize training effectiveness while building analytics thinking and optimization capability. Analytics should be meaningful while remaining actionable and focused on learning improvement rather than analytics complexity or artificial data sophistication. Competency validation includes skill assessment, knowledge verification, application demonstration, and capability confirmation that ensure learning achievement while building validation thinking and assessment capability. Validation should be rigorous while remaining fair and focused on genuine competency rather than validation complexity or artificial assessment sophistication. Performance tracking includes behavior monitoring, application measurement, skill development, and improvement tracking that demonstrate training impact while building tracking thinking and measurement capability. Tracking should be systematic while remaining supportive and focused on development encouragement rather than tracking complexity or artificial monitoring sophistication. Continuous improvement includes feedback integration, program refinement, content updating, and effectiveness enhancement that improve training quality while building improvement thinking and optimization capability. Improvement should be ongoing while remaining strategic and focused on training enhancement rather than improvement complexity or artificial optimization sophistication. 23 point for organizational psychology. Understanding and influencing AI adoption. Behavior. Behavioral psychology and change dynamics. Individual and group behavior in technology adoption. Behavioral psychology creates effective adoption strategies while building psychology expertise and behavior change capability essential for AI implementations that succeed through understanding and working with natural human behavior patterns rather than against them. Individual psychology includes personality factors, cognitive patterns, emotional responses, and behavioral tendencies that influence AI adoption while building psychology thinking and individual capability. Psychology should be respectful while remaining practical and focused on individual understanding rather than psychological manipulation or artificial behavior modification. Group dynamics include social influence, peer pressure, team norms, and collective behavior that shape AI adoption patterns while building group thinking and social capability. Dynamics should be positive while remaining authentic and focused on beneficial group influence rather than social manipulation or artificial group control. Motivation theory includes intrinsic motivation, external incentives, goal setting, and drive understanding that guide behavior change strategies while building motivation thinking and influence capability. Theory should be evidence-based, while remaining practical and focused on genuine motivation rather than motivational manipulation or artificial incentive sophistication. Decision-making psychology includes cognitive biases, choice architecture, decision support, and judgment improvement that influence AI adoption decisions while building decision thinking and choice capability. Psychology should be educational while remaining ethical and focused on better decisions rather than decision manipulation or artificial choice sophistication. Habit formation includes routine development, behavior automation, practice integration, and habit sustainability that create lasting AI adoption while building habit thinking and behavior capability. Formation should be supportive while remaining systematic and focused on positive habits rather than habit manipulation or artificial behavior control. Resistance patterns and overcome strategies. Resistance understanding creates effective adoption strategies while building resistance expertise and resolution capability essential for AI implementations that address human concerns constructively while building support for beneficial change. Resistance psychology includes fear sources, concern origins, skepticism patterns, and opposition drivers that explain adoption resistance while building resistance thinking and understanding capability. Psychology should be empathetic while remaining constructive and focused on concern. understanding rather than resistance criticism or artificial opposition analysis. Fear management includes anxiety addressing, uncertainty reduction, confidence building, and reassurance provision that address emotional barriers to AI adoption while building fear thinking and management capability. Management should be supportive while remaining honest and focused on legitimate reassurance rather than fear minimization or artificial confidence manipulation. Concern validation includes worry acknowledgement, issue recognition, problem addressing, and solution development that respect individual concerns while building validation thinking and resolution capability. Validation should be genuine while remaining constructive and focused on problem solving rather than concern dismissal or artificial validation claims. Trust building includes credibility development, reliability demonstration, competence showing, and integrity maintenance that create confidence in AI adoption while building trust thinking and relationship capability. Building should be earned while remaining systematic and focused on genuine trustworthiness rather than trust manipulation or artificial credibility claims. Conversion strategies include persuasion techniques, influence methods, change facilitation, and adoption support that transform resistance into acceptance while building conversion thinking and influence capability. Strategies should be ethical while remaining effective and focused on mutual benefit rather than conversion manipulation or artificial persuasion sophistication. Social psychology and influence. Social influence and network effects in AI adoption. Social influence creates adoption momentum while building influence expertise and network capability essential for AI implementations that leverage natural social dynamics to accelerate adoption and build organizational support through peer influence and community engagement. Social proof includes peer behavior, success modeling, testimonial sharing, and adoption demonstration that encourage AI adoption while building social thinking and influence capability. Proof should be authentic while remaining compelling and focused on genuine examples rather than social manipulation or artificial proof creation. Opinion leadership includes influencer identification, champion development, advocate training, and leadership leverage that create adoption influence while building leadership thinking and influence capability. Leadership should be organic while remaining strategic and focused on authentic influence rather than artificial leadership or superficial advocacy claims. Network analysis includes relationship mapping, influence identification, connection understanding, and network leverage that optimize social influence while building network thinking and analysis capability. Analysis should be respectful while remaining strategic and focused on positive influence rather than network manipulation or artificial relationship exploitation. Peer pressure includes positive pressure, social expectation, group norm, and collective influence that encourage beneficial adoption while building pressure thinking and influence capability. Pressure should be constructive while remaining voluntary and focused on positive peer influence rather than coercive pressure or artificial social manipulation. Community building includes group formation, shared purpose, collective identity, and mutual support that create adoption communities while building community thinking and development capability. Building should be organic while remaining intentional and focused on genuine community rather than artificial group creation or superficial community claims. Cultural change and norm development. Cultural change creates sustainable adoption while building culture expertise and development capability essential for AI implementations that create lasting organizational change through systematic culture evolution and norm establishment. Culture assessment includes current state analysis, belief identification, value recognition, and norm understanding that provide cultural foundation while building culture thinking and assessment capability. Assessment should be comprehensive while remaining practical and focused on culture understanding rather than cultural analysis complexity or artificial assessment sophistication. Norm development includes standard creation, expectation establishment, behavior modeling, and norm reinforcement that create new cultural patterns while building norm thinking and development capability. Development should be organic while remaining intentional and focused on beneficial norms rather than norm manipulation or artificial standard creation. Value alignment includes principle identification, belief integration, purpose connection, and meaning creation that connect AI adoption with organizational values while building value thinking and alignment capability. Alignment should be authentic while remaining strategic and focused on genuine value connection rather than value manipulation or artificial alignment claims. Ritual and symbol include ceremony creation, symbol development, tradition establishment, and meaning reinforcement that embed AI adoption in organizational culture while building ritual thinking and symbol capability. Ritual should be meaningful while remaining practical and focused on genuine significance rather than ritual complexity or artificial symbol sophistication. Cultural evolution includes gradual change, adaptation facilitation, evolution guidance, and culture development that enable sustainable cultural transformation while building evolution thinking and development capability. Evolution should be natural while remaining directed and focused on positive culture change rather than evolution manipulation or artificial development claims. 23.5 Community building, creating networks that support AI adoption and innovation. Professional learning communities and networks. AI adoption community development and management. Community development creates supportive adoption networks while building community expertise and network capability essential for AI implementations that succeed through collective learning, mutual support, and shared experience rather than individual effort alone. Community strategy includes purpose definition, member identification, value proposition, and engagement planning that create meaningful communities while building community thinking and strategy capability. Strategy should be inclusive while remaining focused and oriented toward genuine community value rather than community complexity or artificial engagement sophistication. Member engagement includes participation facilitation, contribution encouragement, interaction support, and value delivery that maintain community vitality while building engagement thinking and facilitation capability. Engagement should be authentic while remaining systematic and focused on member value rather than engagement manipulation or artificial participation tactics. Knowledge sharing includes expertise exchange, experience documentation, wisdom transfer, and learning facilitation that enable community learning while building sharing thinking and knowledge capability. Sharing should be generous while remaining organized and focused on community benefit rather than sharing complexity or artificial knowledge sophistication. Peer support includes mutual assistance, problem-solving collaboration, encouragement provision, and help facilitation that creates supportive environments while building support thinking and assistance capability. Support should be genuine while remaining sustainable and focused on mutual benefit rather than support dependency or artificial assistance claims. Community governance includes leadership development, decision-making processes, conflict resolution, and community management that maintain healthy communities while building governance thinking and management capability. Governance should be fair while remaining efficient and focused on community health rather than governance complexity or artificial management sophistication. Innovation networks and collaborative learning. Innovation networks create collaborative advancement while building innovation expertise and collaboration capability essential for AI implementations that leverage collective creativity and shared experimentation to accelerate learning and breakthrough development. Innovation facilitation includes creativity encouragement, experimentation support, collaboration coordination, and breakthrough celebration that foster innovation while building innovation thinking and facilitation capability. Facilitation should be supportive while remaining productive and focused on genuine innovation rather than innovation theater or artificial creativity claims. Collaborative learning includes group learning, shared experimentation, collective problem solving, and mutual development that enable network learning while building collaboration thinking and learning capability. Learning should be inclusive while remaining productive and focused on collective advancement rather than collaboration complexity or artificial learning sophistication. Cross-functional networking includes discipline integration, expertise combination, perspective sharing, and knowledge synthesis that create comprehensive innovation while building networking thinking and integration capability. Networking should be strategic while remaining organic and focused on genuine collaboration rather than networking manipulation or artificial integration claims. External partnership includes industry connection, academic collaboration, vendor relationship, and ecosystem participation that extend innovation networks while building partnership thinking and relationship capability. Partnership should be mutually beneficial while remaining strategic and focused on innovation advancement rather than partnership complexity or artificial collaboration sophistication. Innovation diffusion includes idea spreading, practice adoption, knowledge transfer, and innovation scaling that distribute innovation throughout networks while building diffusion. Thinking and scaling capability. Diffusion should be organic while remaining systematic and focused on beneficial innovation rather than diffusion manipulation or artificial scaling claims. Leadership development and succession planning. AI champion development and leadership pipeline. Leadership development creates sustainable adoption capability while building leadership expertise and succession planning essential for AI implementations that require ongoing leadership and sustained organizational capability development through systematic leader cultivation. Champion identification includes potential recognition, leader selection, influence assessment, and development opportunity that identify adoption leaders while building identification thinking and talent capability. Identification should be merit-based while remaining inclusive and focused on leadership potential rather than identification complexity or artificial selection sophistication. Leadership development includes skill building, capability enhancement, experience provision, and authority development that create effective leaders while building development thinking and leadership capability. Development should be comprehensive while remaining practical and focused on genuine leadership rather than development complexity or artificial leadership sophistication. Mentoring programs include mentor training, relationship facilitation, guidance provision, and development support that enable leadership growth while building mentoring thinking and program capability. Programs should be supportive while remaining structured and focused on individual development rather than program complexity or artificial mentoring sophistication. Succession planning includes pipeline development, knowledge transfer, capability building, and leadership continuity that ensure sustained leadership while building succession thinking and planning capability. Planning should be forward-thinking while remaining practical and focused on organizational continuity rather than succession complexity or artificial planning sophistication. Authority delegation includes responsibility sharing, decision-making distribution, empowerment creation, and leadership expansion that develop organizational leadership capacity while building delegation thinking and empowerment capability. Delegation should be strategic while remaining supportive and focused on capability development rather than delegation complexity or artificial empowerment claims. Knowledge preservation and transfer. Knowledge preservation creates organizational memory while building preservation expertise and transfer capability essential for AI implementations that require sustained knowledge and continuous capability development through systematic knowledge management and transfer. Knowledge capture includes tacit knowledge extraction, experience documentation, wisdom preservation, and expertise recording that preserve organizational knowledge while building capture thinking and documentation capability. Capture should be comprehensive while remaining practical and focused on knowledge utility rather than capture complexity or artificial documentation sophistication. Documentation systems include knowledge organization, information structure, content management, and access facilitation that enable knowledge preservation while building documentation thinking and system capability. Systems should be usable while remaining comprehensive and focused on knowledge accessibility rather than system complexity or artificial documentation sophistication. Transfer mechanisms include training programs, mentoring relationships, knowledge sharing, and experience transfer that enable knowledge distribution while building transfer thinking and mechanism capability. Mechanisms should be effective while remaining sustainable and focused on genuine transfer rather than mechanism complexity or artificial transfer sophistication. Institutional memory includes organizational learning, collective knowledge, shared experience, and cultural wisdom that create learning organizations while building memory thinking and institutional capability. Memory should be valuable while remaining accessible and focused on organizational benefit rather than memory complexity or artificial institutional sophistication. Continuous learning includes ongoing education, skill development, knowledge updating, and capability enhancement that maintain organizational competency while building learning thinking and development capability. Learning should be systematic while remaining engaging and focused on competency advancement rather than learning complexity or artificial development sophistication. 23.6 Human-AI Collaboration Framework. Optimizing partnerships between people and technology. Collaborative workflows and task allocation. Human-AI partnership design and optimization. Human-AI collaboration requires systematic design that optimizes complementary capabilities while building collaboration expertise and partnership capability essential for AI implementations that enhance human performance through effective human-AI teamwork rather than human replacement. Collaboration design includes task allocation, responsibility division, capability matching, and workflow integration that optimize human-AI partnerships while building collaboration thinking and design capability. Design should be strategic while remaining practical and focused on mutual enhancement rather than collaboration complexity or artificial partnership sophistication. Task allocation includes strength assessment, capability analysis, efficiency optimization, and responsibility assignment that leverage complementary abilities while building allocation thinking and optimization capability. Allocation should be logical while remaining flexible and focused on optimal performance rather than allocation complexity or artificial optimization sophistication. Human augmentation includes capability enhancement, skill amplification, performance improvement, and competency extension that enhance human capability through AI support while building augmentation thinking and enhancement capability. Augmentation should be empowering while remaining natural and focused on human enhancement rather than artificial capability or superficial augmentation claims. AI assistance includes intelligent support, automated processing, recommendation provision, and decision support that enable effective human work while building assistance thinking and support capability. Assistance should be helpful while remaining unobtrusive and focused on human effectiveness rather than assistance complexity or artificial support sophistication. Workflow integration includes process design, system coordination, handoff management, and collaboration facilitation that enable seamless human-AI collaboration while building integration thinking and coordination capability. Integration should be smooth while remaining efficient and focused on workflow effectiveness rather than integration complexity or artificial coordination sophistication. Communication and feedback loops. Communication creates effective collaboration while building communication expertise and feedback capability essential for human-AI partnerships that require clear communication, mutual understanding, and continuous improvement through feedback and adaptation. Human-AI communication includes interface design, interaction patterns, feedback mechanisms, and understanding facilitation that enable effective human-AI interaction while building communication thinking and interface capability. Communication should be intuitive while remaining comprehensive and focused on mutual understanding rather than communication complexity or artificial interface sophistication. Feedback systems include performance monitoring, correction mechanisms, improvement guidance, and adaptation facilitation that enable collaborative learning while building feedback thinking and system capability. Systems should be constructive while remaining efficient and focused on improvement rather than feedback complexity or artificial system sophistication. Learning loops include experience integration, knowledge updating, capability enhancement, and adaptation facilitation that enable collaborative improvement while building learning thinking and adaptation capability. Loops should be continuous while remaining practical and focused on genuine improvement, rather than learning complexity or artificial adaptation sophistication. Error handling includes mistake recognition, correction procedures, recovery mechanisms, and improvement integration that manage collaboration failures while building error thinking and recovery capability. Handling should be graceful while remaining effective and focused on error recovery rather than error complexity or artificial handling sophistication. Mutual adaptation includes human learning, AI adjustment, partnership evolution, and collaboration optimization that improve human-AI partnerships over time while building adaptation thinking and evolution capability. Adaptation should be natural while remaining beneficial and focused on partnership improvement rather than adaptation complexity or artificial evolution claims. Ethical considerations and human agency. Preserving authority, human agency, and decision-making. Human agency preservation ensures ethical AI collaboration while building ethics expertise and agency protection capability essential for AI implementations that enhance rather than diminish human autonomy, decision-making authority, and meaningful work engagement. Agency protection includes autonomy preservation, control maintenance, choice provision, and authority respect that protect human decision-making while building agency thinking and protection capability. Protection should be comprehensive while remaining practical and focused on genuine autonomy rather than agency complexity or artificial protection claims. Human oversight includes monitoring capability, intervention authority, decision review, and control preservation that maintain human authority over AI systems while building oversight thinking and authority capability. Oversight should be meaningful while remaining efficient and focused on appropriate human control rather than oversight complexity or artificial authority claims. Decision transparency includes process visibility, rationale explanation, option presentation, and choice clarification that enable informed human decision-making while building transparency thinking and explanation capability. Transparency should be clear while remaining appropriate and focused on human understanding rather than transparency complexity or artificial explanation sophistication. Meaningful work includes purpose preservation, skill utilization, challenge provision, and satisfaction maintenance that ensure AI enhances rather than diminishes work meaning while building meaning thinking and work capability. Work should be fulfilling while remaining productive and focused on human flourishing rather than work complexity or artificial meaning claims. Value alignment includes principle integration, ethics consideration, purpose connection, and meaning preservation that ensure AI collaboration supports human values while building alignment thinking and value capability. Alignment should be authentic while remaining practical and focused on genuine value support rather than alignment complexity or artificial value claims. Responsibility and accountability in human AI systems. Responsibility frameworks create ethical collaboration while building accountability expertise and responsibility capability essential for human AI partnerships that maintain clear accountability and ethical standards while leveraging AI capabilities effectively. Accountability design includes responsibility assignment, authority definition, oversight establishment, and accountability maintenance that ensure clear accountability in human AI systems while building accountability thinking and responsibility capability. Design should be clear while remaining practical and focused on genuine accountability rather than accountability complexity or artificial responsibility sophistication. Human responsibility includes decision authority, oversight duty, control maintenance, and accountability acceptance that preserve human responsibility in AI collaboration while building responsibility thinking and authority capability. Responsibility should be meaningful while remaining manageable and focused on appropriate human authority rather than responsibility complexity or artificial authority claims. AI limitations includes capability boundaries, error acknowledgement, uncertainty communication, and limitation. Disclosure that maintain realistic expectations while building limitation thinking and communication capability. Limitation should be honest while remaining constructive and focused on realistic expectations rather than limitation complexity or artificial communication sophistication. Error attribution includes mistake identification, responsibility assignment, correction procedures, and learning integration that handle errors appropriately while building attribution thinking and correction capability. Attribution should be fair while remaining constructive and focused on error learning rather than attribution sophistication. Complexity or artificial correction. Continuous monitoring includes performance tracking, behavior assessment, impact evaluation, and improvement integration that ensure ongoing ethical collaboration while building monitoring thinking and assessment capability. Monitoring should be systematic while remaining practical and focused on ethical assurance rather than monitoring complexity or artificial assessment sophistication. Chapter 23 Conclusion: Human-Centered Design Specialists as Organizational Transformation Leaders. Chapter 23 establishes the comprehensive framework for developing human-centered design specialists who can design and implement AI adoption initiatives that prioritize human experience and create sustainable organizational cultures that embrace AI as a tool for human empowerment while building the organizational psychology, user experience, design, and change leadership capabilities essential for senior organizational development roles. The Advanced Change Management Framework provides sophisticated methodologies for leading large-scale transformation while building change leadership capabilities that enable specialists to guide organizations through complex human-centered AI implementations requiring sustained behavior change and cultural evolution. The user experience design and human-computer interaction development creates interface expertise and accessibility capabilities essential for designing AI systems that feel natural and empowering to users while building UX design and inclusive design skills that ensure AI implementations serve diverse user populations effectively. The training program development and organizational learning components build educational expertise while creating knowledge transfer capabilities that enable human-centered design specialists to design and implement effective AI education programs that build genuine competency through adult learning principles and organizational capability development. The organizational psychology and behavior change frameworks build deep understanding of human dynamics while creating influence capabilities that enable effective adoption strategies working with rather than against natural human behavior patterns, building skills essential for managing resistance and building sustainable adoption. The community building and network development components create collaboration expertise while building leadership capabilities that enable human-centered design specialists to create supportive adoption networks and develop leadership pipelines that sustain organizational AI capability over time. The human-AI collaboration frameworks build ethical partnership capability while creating responsibility systems that ensure AI implementations enhance rather than diminish human agency, decision-making authority, and meaningful work engagement, building skills essential for ethical AI adoption. The comprehensive 6-month specialization track established in Chapter 23 transforms foundational AI fluent professionals into human-centered transformation leaders capable of designing and implementing AI adoption that creates lasting positive impact on both individual work experience and organizational capability while building careers as senior organizational development leaders and human-centered transformation executives. This specialization track represents recognition that successful enterprise AI adoption requires not just technically competent professionals but human-centered leaders who can design AI implementations that succeed through genuine human acceptance and empowerment rather than technological force, ensuring AI technologies enhance human flourishing while achieving business objectives. Human-centered approaches through sustainable. Introduction of Chapter 24. Advanced Bias Detection and Fairness. Multidimensional bias analysis, comprehensive frameworks for identifying statistical, cognitive, social, and systemic bias across complex AI systems and organizational contexts. Mathematical fairness models, statistical fairness metrics, algorithmic optimization, and quantitative bias measurement for precise fairness assessment and correction. Technical mitigation strategies, pre-processing, in-processing, and post-processing techniques for systematic bias prevention and algorithmic fairness enhancement. Organizational bias prevention, governance frameworks, team diversity strategies, and process-based approaches for institutional fairness and cultural bias mitigation. Regulatory compliance mastery. Global regulatory navigation, comprehensive understanding of GDPR, CCPA, industry-specific regulations, and international AI governance frameworks. Risk assessment and legal planning, systematic compliance gap analysis, legal risk identification, and proactive mitigation strategy development. Industry-specific expertise, specialized knowledge of healthcare FDA regulations, financial services compliance, and sector-specific AI governance requirements. Compliance monitoring systems, automated tracking, audit procedures, and enforcement mechanisms for ongoing regulatory adherence and accountability. Governance architecture excellence SYST. Ematic oversight design, comprehensive governance frameworks with ethics committees, risk management systems, and clear accountability structures poly. SI development and implementation, evidence-based policy creation, stakeholder consultation, and effective organizational policy integration and enforcement DESI. SION-making frameworks, clear authority structures, approval processes, and conflict resolution mechanisms for ethical AI development and deployment. Continuous improvement systems, monitoring mechanisms, performance measurement, and adaptive governance structures that evolve with technology and regulation. Risk management and crisis response. Business comprehensive risk classification, technical, ethical, legal, and risk identification with sophisticated quantification and impact assessment methodologies. Proactive mitigation strategies, system redundancy, error handling, security implementation, and organizational risk management for comprehensive risk coverage. Crisis management excellence, incident response procedures, stakeholder communication strategies, and organizational learning integration for effective crisis resolution. Business continuity planning, disaster recovery procedures, operational continuity assurance, and resilience building for sustained organizational capability. Stakeholder trust and transparency MULT. Stakeholder engagement, comprehensive stakeholder mapping, authentic relationship building, and sustained trust development across diverse constituency groups PUBL. IC communication excellence, transparent reporting, media engagement, community consultation, and social impact communication for public trust and acceptance. Institutional credibility, reliability demonstration, accountability mechanisms, and ethical leadership that build lasting institutional credibility and social license. Participatory governance, community involvement, collaborative decision-making, and democratic participation in AI development and deployment decisions. Policy development and industry leadership, organizational policy excellence, comprehensive policy architecture, stakeholder consultation, and effective implementation strategies for organizational AI governance. Chapter 24. Ethics and Governance. Specialist Track Design. 24.1 Advanced Bias Detection and Mitigation, Systematic Approaches to AI Fairness Comprehensive Bias Analysis Framework. Multidimensional bias identification and assessment. Advanced bias detection requires sophisticated frameworks that identify subtle forms of discrimination while building bias expertise and fairness capability essential for AI implementations that serve diverse populations equitably and maintain ethical standards across complex organizational and societal contexts. And bias taxonomy includes statistical bias, cognitive bias, social bias, systemic bias identification that provide comprehensive understanding of bias sources while building bias thinking and classification capability. Taxonomy should be thorough while remaining practical and focused on actionable bias recognition rather than academic complexity or artificial bias sophistication. Intersectionality analysis includes multiple identity consideration, compound discrimination recognition, complex bias patterns, and layered impact assessment that address sophisticated bias dynamics while building intersectional thinking and analysis capability. Analysis should be comprehensive while remaining respectful and focused on genuine fairness rather than intersectional complexity or artificial discrimination analysis. Historical bias examination includes legacy discrimination patterns, inherited unfairness, traditional inequality, and past injustice recognition that understand bias context while building historical thinking and context capability. Examination should be thorough while remaining forward-focused and oriented toward bias correction rather than historical complexity or artificial context sophistication. Algorithmic bias assessment includes model discrimination, data bias, design unfairness, and output inequality that identify technical bias sources while building algorithmic thinking and technical capability. Assessment should be rigorous while remaining practical and focused on bias correction rather than technical complexity or artificial algorithmic sophistication. Impact measurement includes harm quantification, disparity assessment, fairness evaluation, and inequality measurement that demonstrate bias effects while building impact thinking and measurement capability. Measurement should be accurate while remaining meaningful and focused on genuine impact rather than measurement complexity or artificial evaluation sophistication. Statistical fairness and mathematical frameworks. Statistical fairness creates quantitative bias assessment while building mathematical expertise and fairness capability essential for AI implementations that require precise fairness measurement and systematic bias correction through evidence-based methodologies. Fairness metrics include demographic parity, equalized odds, calibration measures, and individual fairness that quantify AI system fairness while building metrics thinking and measurement capability. Metrics should be appropriate while remaining interpretable and focused on meaningful fairness rather than metric complexity or artificial measurement sophistication. Mathematical modeling includes statistical analysis, probability assessment, disparity calculation, and fairness computation that enable precise bias measurement while building mathematical thinking and analytical capability. Modeling should be rigorous while remaining accessible and focused on practical fairness rather than mathematical complexity or artificial analytical sophistication. Threshold optimization includes decision boundary adjustment, cutoff modification, fairness constraint, and optimization balancing that improve AI system fairness while building optimization thinking and adjustment capability. Optimization should be systematic while remaining contextual and focused on appropriate fairness rather than optimization complexity or artificial adjustment sophistication. Trade-off analysis includes fairness versus accuracy, equity versus efficiency, individual versus group fairness, and competing objective evaluation that navigate fairness tensions while building trade-off thinking and balancing capability. Analysis should be thoughtful while remaining practical and focused on ethical balance rather than trade-off complexity or artificial balancing sophistication. Validation methodology includes fairness testing, bias verification, disparity confirmation, and inequality validation that ensure bias detection accuracy while building validation thinking and testing capability. Methodology should be reliable while remaining efficient and focused on accurate detection rather than validation complexity or artificial testing sophistication. Bias mitigation strategies and implementation. Technical mitigation approaches and algorithm design. Technical mitigation creates for AI systems while building technical expertise and implementation capability essential for AI systems that actively prevent discrimination through sophisticated algorithmic design and systematic bias correction methodologies. Pre-processing techniques include data cleaning, representation balancing, sampling adjustment, and bias removal that address training data bias while building pre-processing thinking and data capability. Techniques should be effective while remaining data preserving and focused on bias reduction rather than pre-processing complexity or artificial data sophistication. In-processing methods include fairness constraints, regularization techniques, adversarial training, and bias-aware learning that embed fairness in model training while building processing thinking and training capability. Methods should be sophisticated while remaining trainable and focused on fair learning rather than processing complexity or artificial training sophistication. Post-processing adjustments include output modification, threshold adjustment, prediction calibration, and result correction that improve trained model fairness while building adjustment thinking and correction capability. Adjustment should be principled while remaining effective and focused on fairness improvement rather than adjustment complexity or artificial correction sophistication. Ensemble approaches include diverse model combination, bias complementarity, fairness aggregation, and collective decision making that leverage multiple perspectives for fairness while building ensemble thinking and combination capability. Approaches should be systematic while remaining manageable and focused on fairness enhancement rather than ensemble complexity or artificial combination sophistication. Continuous monitoring includes bias tracking, fairness assessment, drift detection, and performance monitoring that maintains system fairness over time while building monitoring thinking and maintenance capability. Monitoring should be ongoing while remaining efficient and focused on fairness preservation rather than monitoring complexity or artificial maintenance sophistication. Organizational and process-based mitigation. Organizational mitigation creates systematic fairness while building process expertise and institutional capability essential for AI implementations that prevent bias through comprehensive organizational approaches and cultural change rather than technical solutions alone. Governance frameworks include bias policy, fairness standards, ethical guidelines, and accountability structures that institutionalize fairness while building governance thinking and framework capability. Frameworks should be comprehensive while remaining practical and focused on effective governance rather than framework complexity or artificial governance sophistication. Review processes include bias assessment, fairness evaluation, discrimination checking, and ethical review that systematically prevent biased AI deployment while building review thinking and evaluation capability. Processes should be thorough while remaining efficient and focused on bias prevention rather than process complexity or artificial evaluation sophistication. Team diversity includes perspective diversity, background variety, experience breadth, and demographic representation that bring diverse viewpoints to AI development while building diversity thinking and inclusion capability. Diversity should be meaningful while remaining merit-based and focused on perspective enhancement rather than diversity quotas or artificial inclusion claims. Training programs include bias education, fairness awareness, discrimination recognition, and sensitivity training that build organizational bias capability while building training thinking and education capability. Programs should be educational while remaining engaging and focused on genuine awareness rather than training complexity or artificial education sophistication. Stakeholder engagement includes community involvement, affected group consultation, feedback integration, and participatory design that incorporate diverse perspectives in AI development while building engagement thinking and participation capability. Engagement should be authentic while remaining productive and focused on genuine inclusion rather than engagement theater or artificial participation claims. 24.2 Regulatory compliance expertise. Navigating complex legal frameworks for AI implementation. Global regulatory landscape and legal requirements. International AI regulation and standards compliance. Regulatory expertise requires comprehensive understanding of evolving legal frameworks while building compliance capability and legal expertise essential for AI implementations that operate within complex regulatory environments across multiple jurisdictions and industry sectors. Regulatory landscape analysis includes law identification, requirement assessment, compliance obligation, and regulatory mapping comprehensive that provide legal understanding while building regulatory thinking and analysis capability. Analysis should be current while remaining practical and focused on compliance guidance rather than legal complexity or artificial regulatory sophistication. GDPR compliance includes privacy rights, data protection, consent management, and breach notification that ensure European regulatory adherence while building privacy thinking and protection capability. Compliance should be comprehensive while remaining practical and focused on genuine privacy protection rather than GDPR complexity or artificial privacy sophistication. CCPA implementation includes consumer rights, data transparency, opt-out mechanisms, and privacy protection that ensure California regulatory compliance while building consumer thinking and rights capability. Implementation should be thorough while remaining user-friendly and focused on consumer protection rather than CCPA complexity or artificial rights sophistication. Industry-specific regulations include healthcare HIPAA, financial SOX, education FERPA, and sector-specific compliance that address specialized regulatory requirements while building industry thinking and sector capability. Regulation should be tailored while remaining comprehensive and focused on sector-appropriate compliance rather than regulatory complexity or artificial sector sophistication. International coordination includes cross-border compliance, jurisdictional navigation, treaty consideration, and global regulatory alignment that manage international AI deployment while building international thinking and coordination capability. Coordination should be strategic while remaining practical and focused on global compliance rather than international complexity sophistication. Or artificial. Coordination. Coordination. Risk assessment creates systematic compliance while building risk expertise and planning capability essential for AI implementations that proactively address regulatory requirements and potential legal challenges through comprehensive risk management and mitigation planning. Legal risk identification includes compliance gaps, regulatory violations, liability exposure, and legal vulnerability that reveal potential legal challenges while building risk thinking and identification capability. Identification should be comprehensive while remaining manageable and focused on risk mitigation rather than risk complexity or artificial identification sophistication. Compliance gap analysis includes requirement comparison, obligation assessment, standard evaluation, and gap identification that reveal compliance deficiencies while building gap thinking and analysis capability. Analysis should be systematic while remaining actionable and focused on gap closure rather than analysis complexity or artificial gap sophistication. Mitigation strategy development includes risk reduction, compliance enhancement, legal protection, and vulnerability addressing that address identified risks while building mitigation thinking and strategy capability. Development should be effective while remaining proportionate and focused on risk management rather than mitigation complexity or artificial strategy sophistication. Compliance monitoring includes tracking, requirement monitoring, regulatory obligation assessment, and compliance measurement that ensure ongoing regulatory adherence while building monitoring thinking and compliance capability. Monitoring should be systematic while remaining efficient and focused on compliance assurance rather than monitoring complexity or artificial compliance sophistication. Legal documentation includes policy creation, procedure documentation, compliance evidence, and legal record keeping that demonstrate regulatory adherence while building documentation thinking and legal capability. Documentation should be thorough while remaining accessible and focused on compliance demonstration rather than documentation complexity or artificial legal sophistication. Industry-specific compliance and standards. Healthcare AI regulation and medical device compliance. Healthcare compliance requires specialized understanding of medical regulations while building healthcare expertise and medical capability essential for AI implementations in healthcare contexts that require patient safety, clinical efficacy, and regulatory specialized approval medical frameworks. Through FDA regulation includes medical device classification, clinical validation, safety demonstration, and regulatory approval that ensure healthcare AI compliance while building FDA thinking and medical capability. Regulation should be rigorous while remaining innovative and focused on patient safety rather than regulatory complexity or artificial medical sophistication. HIPAA compliance includes patient privacy, health information protection, security safeguards, and breach prevention that protect healthcare data while building healthcare thinking and privacy capability. Compliance should be comprehensive while remaining practical and focused on patient protection rather than HIPAA complexity or artificial healthcare sophistication. Clinical evidence includes efficacy demonstration, safety validation, outcomes measurement, and evidence generation that support healthcare AI deployment while building clinical thinking and evidence capability. Evidence should be rigorous while remaining practical and focused on clinical value rather than evidence complexity or artificial clinical sophistication. Quality management includes ISO 13485, quality systems, risk management, and regulatory compliance that ensure medical device quality while building quality thinking and management capability. Management should be systematic while remaining practical and focused on quality assurance rather than quality complexity or artificial management sophistication. Post-market surveillance includes safety monitoring, adverse event reporting, performance tracking, and continuous safety assessment that maintain healthcare AI safety while building surveillance thinking and safety capability. Surveillance should be ongoing while remaining proportionate and focused on patient safety rather than surveillance complexity or artificial safety sophistication. Financial services AI regulation and compliance. Financial compliance requires sophisticated understanding of financial regulations while building finance expertise and regulatory capability essential for AI implementations in financial contexts that require consumer protection, market integrity, and financial stability through specialized financial frameworks. SEC regulation includes investment advisor rules, algorithmic trading oversight, disclosure requirements, and fiduciary compliance that ensure financial AI compliance while building SEC thinking and financial capability. Regulation should be comprehensive while remaining practical and focused on investor protection rather than regulatory complexity or artificial financial sophistication. Fair lending includes equal credit opportunity, fair housing compliance, disparate impact prevention, and lending discrimination avoidance that ensure equitable financial services while building lending thinking and fairness capability. Lending should be equitable while remaining profitable and focused on fair access rather than lending complexity or artificial fairness sophistication. Market integrity includes manipulation prevention, insider trading avoidance, market abuse prevention, and trading compliance that protect financial markets while building integrity thinking and market capability. Integrity should be maintained while remaining competitive and focused on market protection rather than integrity complexity or artificial market sophistication. Consumer protection includes truth in lending, fair debt collection, consumer privacy, and financial protection that safeguard financial consumers while building protection thinking and consumer capability. Protection should be comprehensive while remaining business viable and focused on consumer welfare rather than protection complexity or artificial consumer sophistication. Systemic risk management includes financial stability, risk assessment, stress testing, and prudential regulation that maintain financial system stability while building systemic thinking and stability capability. Management should be prudent while remaining innovative and focused on system stability rather than risk complexity or artificial stability sophistication. 24.3 Governance System Architecture. Creating organizational oversight for AI. Development. Comprehensive AI governance framework design. Governance structure and organizational design. Governance architecture creates systematic oversight while building governance expertise and organizational capability essential for AI implementations that require comprehensive oversight, clear accountability, and ethical decision-making through well-designed governance structures and processes. Governance framework includes oversight structure, decision hierarchy, accountability assignment, and responsibility. Distribution that creates systematic AI governance while building governance thinking and structure capability. Framework should be comprehensive while remaining efficient and focused on effective oversight rather than governance complexity or artificial structure sophistication. Ethics committee includes diverse representation, expertise integration, stakeholder inclusion, and decision authority that provide ethical oversight while building committee thinking and ethical capability. Committee should be representative while remaining functional and focused on ethical guidance rather than committee complexity or artificial ethical sophistication. Risk management includes risk identification, assessment procedures, mitigation planning, and monitoring systems that manage AI-related risks while building risk thinking and management capability. Management should be proactive while remaining proportionate and focused on risk control rather than management complexity or artificial risk sophistication. Policy development includes standard creation, guideline establishment, procedure documentation, and policy enforcement that guide AI development while building policy thinking and development capability. Development should be practical while remaining comprehensive and focused on policy effectiveness rather than policy complexity or artificial development sophistication. Stakeholder engagement includes constituency representation, feedback integration, consultation processes, and collaborative decision-making that ensures stakeholder involvement while building engagement thinking and participation capability. Engagement should be meaningful while remaining manageable and focused on genuine participation rather than engagement complexity or participation sophistication. Artificial decision-making processes and authority structures. Decision-making governance creates systematic while building process expertise and authority capability essential for AI governance that requires clear decision processes, appropriate authority distribution, and accountable leadership through well-designed organizational structures. Decision hierarchy includes authority levels, escalation procedures, approval processes, and accountability chains that create clear decision-making while building hierarchy thinking and authority capability. Hierarchy should be logical while remaining accessible and focused on effective decisions rather than hierarchy complexity or artificial authority sophistication. Approval processes include review stages, evaluation criteria, decision points, and authorization procedures that ensure appropriate AI development approval while building approval thinking and process capability. Processes should be thorough while remaining efficient and focused on quality approval rather than process complexity or artificial approval sophistication. Conflict resolution includes disagreement management, dispute resolution, mediation procedures, and consensus building that address governance conflicts while building resolution thinking and mediation capability. Resolution should be fair while remaining efficient and focused on productive resolution rather than conflict complexity or artificial resolution sophistication. Transparency mechanisms include disclosure procedures, public reporting, stakeholder communication, and openness practices that ensure governance transparency while building transparency thinking and disclosure capability. Mechanisms should be comprehensive while remaining practical and focused on genuine transparency rather than disclosure complexity or artificial transparency sophistication. Accountability enforcement includes responsibility assignment, performance monitoring, consequence management, and improvement requirements that ensure governance accountability while building accountability thinking and enforcement capability. Enforcement should be fair while remaining effective and focused on responsibility assurance rather than enforcement complexity or artificial accountability sophistication. Policy development and implementation. AI ethics policy creation and standards development. Policy development creates systematic guidance while building policy expertise and standard capability essential for AI governance that requires clear policies, practical standards, and effective implementation guidance through comprehensive policy frameworks and development processes. Policy framework includes principle establishment, standard definition, guideline creation, and implementation guidance that provide comprehensive AI policy while building policy thinking and framework capability. Framework should be principled while remaining practical and focused on policy effectiveness rather than framework complexity or artificial policy sophistication. Standard development includes requirement specification, compliance criteria, measurement metrics, and evaluation procedures that create clear AI standards while building standard thinking and development capability. Development should be rigorous while remaining achievable and focused on standard effectiveness rather than development complexity or artificial standard sophistication. Implementation guidance includes procedure documentation, training materials, support resources, and compliance assistance that enable policy implementation while building implementation thinking and guidance capability. Guidance should be practical while remaining comprehensive and focused on implementation success rather than guidance complexity or artificial implementation sophistication. Policy integration includes organizational alignment, process coordination, system integration, and culture incorporation that embed policies in organizational practice while building integration thinking and embedding capability. Integration should be systematic while remaining organic and focused on policy adoption rather than integration complexity or artificial embedding sophistication. Continuous improvement includes policy review, standard updating, guidance refinement, and framework evolution that maintain policy relevance while building improvement thinking and evolution capability. Improvement should be ongoing while remaining stable and focused on policy enhancement rather than improvement complexity or artificial evolution sophistication. Compliance monitoring and enforcement. Compliance monitoring creates systematic oversight while building monitoring expertise and enforcement capability essential for AI governance that requires ongoing compliance assessment, violation detection, and corrective action through comprehensive monitoring and enforcement systems. Monitoring systems include compliance tracking, violation detection, performance assessment, and reporting mechanisms that ensure policy adherence while building monitoring thinking and system capability. Systems should be comprehensive while remaining efficient and focused on compliance assurance rather than monitoring complexity or artificial system sophistication. Audit procedures include compliance assessment, review processes, evaluation methods, and verification procedures that validate policy adherence while building audit thinking and assessment capability. Procedures should be rigorous while remaining fair and focused on compliance validation rather than audit complexity or artificial assessment sophistication. Violation response includes infraction handling, corrective action, penalty application, and improvement requirements that address policy violations while building response thinking and correction capability. Response should be proportionate while remaining effective and focused on compliance restoration rather than response complexity or artificial correction sophistication. Performance measurement includes compliance metrics, adherence tracking, effectiveness evaluation, and improvement measurement that assess governance performance while building measurement thinking and evaluation capability. Measurement should be meaningful while remaining practical and focused on governance effectiveness rather than measurement complexity or artificial evaluation sophistication. Reporting mechanisms include compliance reporting, performance communication, stakeholder updates, and transparency disclosure that ensure governance transparency while building reporting thinking and communication capability. Mechanisms should be comprehensive while remaining accessible and focused on effective communication rather than reporting complexity or artificial transparency sophistication. 24-point for risk assessment and management. Identifying and mitigating AI-related risks. Comprehensive AI risk framework. Risk identification and classification systems. Risk assessment requires systematic identification while building risk expertise and classification capability essential for AI implementations that require comprehensive risk understanding, appropriate classification, and effective management through sophisticated risk frameworks and assessment methodologies. Risk taxonomy includes technical risks, ethical risks, legal risks, and business risks that provide comprehensive risk understanding while building risk thinking and classification capability. Taxonomy should be comprehensive while remaining practical and focused on risk management rather than classification complexity or artificial risk sophistication. Technical risk assessment includes system failure, performance degradation, security vulnerability, and reliability issues that identify technical challenges while building technical thinking and assessment capability. Assessment should be thorough while remaining actionable and focused on technical risk management rather than assessment complexity or artificial technical sophistication. Ethical risk evaluation includes bias potential, fairness concerns, discrimination possibility, and social harm that identify ethical challenges while building ethical thinking and evaluation capability. Evaluation should be sensitive while remaining practical and focused on ethical risk prevention rather than evaluation complexity or artificial ethical sophistication. Legal risk analysis includes compliance violation, regulatory breach, liability exposure, and legal vulnerability that identify legal challenges while building legal thinking and analysis capability. Analysis should be comprehensive while remaining practical and focused on legal risk mitigation rather than analysis complexity or artificial legal sophistication. Business risk identification includes reputation damage, financial loss, operational disruption, and strategic failure that identify business challenges while building business thinking and identification capability. Identification should be strategic while remaining practical and focused on business risk management rather than identification complexity or artificial business sophistication. Risk quantification and impact assessment. Risk quantification creates measurable risk understanding while building quantification expertise and impact capability essential for AI risk management that requires precise risk measurement, impact assessment, and priority setting through systematic quantification methodologies. Impact measurement includes severity assessment, probability evaluation, frequency analysis, and consequent quantification that measure risk impact while building measurement thinking and quantification capability. Measurement should be accurate while remaining practical and focused on meaningful impact assessment rather than measurement complexity or artificial. Probability. Quantification sophistication. Estimation includes likelihood assessment, frequency evaluation, occurrence prediction, and statistical analysis that estimate risk probability while building estimation thinking and probability capability. Estimation should be realistic while remaining useful and focused on accurate probability assessment rather than estimation complexity or artificial probability sophistication. Risk scoring includes severity weighting, probability integration, impact combination, and priority calculation that create risk prioritization while building scoring thinking and prioritization capability. Scoring should be logical while remaining practical and focused on effective prioritization rather than scoring complexity or artificial prioritization sophistication. Cost-benefit analysis includes mitigation cost, risk impact, benefit evaluation, and value assessment that guide risk management decisions while building analysis thinking and decision capability. Analysis should be thorough while remaining actionable and focused on optimal risk management rather than analysis complexity or artificial decision sophistication. Scenario modeling includes worst-case analysis, best-case projection, likely outcomes, and alternative scenarios that explore risk implications while building modeling thinking and scenario capability. Modeling should be realistic while remaining comprehensive and focused on scenario planning rather than modeling complexity or artificial scenario sophistication. Risk mitigation and management strategies. Technical risk mitigation and system resilience. Technical mitigation creates resilient AI systems while building technical expertise and resilience capability essential for AI implementations that require robust technical risk management, system reliability, and operational continuity through comprehensive technical mitigation strategies. System redundancy includes backup systems, failover mechanisms, alternative pathways, and continuity assurance that prevent system failures while building redundancy thinking and resilience capability. Redundancy should be sufficient while remaining cost-effective and focused on system reliability rather than redundancy complexity or artificial resilience sophistication. Error handling includes exception management, graceful degradation, recovery procedures, and fault tolerance that manage system errors while building error thinking and handling capability. Handling should be comprehensive while remaining efficient and focused on error management rather than handling complexity or artificial error sophistication. Security implementation includes access control, data protection, threat prevention, and vulnerability management that protect AI systems while building security thinking and protection capability. Implementation should be robust while remaining usable and focused on genuine security rather than security complexity or artificial protection sophistication. Performance monitoring includes system tracking, anomaly detection, performance assessment, and quality assurance that maintains system performance while building monitoring thinking and quality capability. Monitoring should be continuous while remaining efficient and focused on performance assurance rather than monitoring complexity or artificial quality sophistication. Disaster recovery includes backup procedures, restoration processes, business continuity, and emergency response that ensure operational continuity while building recovery thinking and continuity capability. Recovery should be comprehensive while remaining practical and focused on business continuity rather than recovery complexity or artificial continuity sophistication. Organizational risk management and crisis response. Organizational management creates systematic risk response while building management expertise and crisis capability essential for AI risk management that requires organizational preparedness, effective crisis response, and sustained risk management through approaches. Comprehensive organizational crisis management includes incident response, emergency procedures, stakeholder communication, and recovery. Coordination that manage AI-related crises while building crisis thinking and management capability. Management should be systematic while remaining flexible and focused on crisis resolution rather than management complexity or artificial crisis sophistication. Communication strategy includes stakeholder notification, public relations, media management, and transparency communication that manage crisis communication while building communication thinking and strategy capability. Strategy should be transparent while remaining strategic and focused on stakeholder trust rather than communication complexity or artificial strategy sophistication. Stakeholder management includes relationship maintenance, trust preservation, confidence restoration, and partnership protection that maintain stakeholder relationships during crises while building stakeholder thinking and relationship capability. Management should be proactive while remaining authentic and focused on relationship preservation rather than management complexity sophistication. Or artificial relationship? Learning integration includes incident analysis, lesson extraction, improvement implementation, and knowledge application that enable organizational learning from risk events while building learning thinking and integration capability. Integration should be systematic while remaining practical and focused on organizational improvement rather than learning complexity or artificial integration sophistication. Continuous improvement includes risk reassessment, strategy refinement, process enhancement, and capability strengthening that improve risk management over time while building improvement thinking and enhancement capability. Improvement should be ongoing while remaining stable and focused on risk management enhancement rather than improvement complexity sophistication. Or artificial enhancement. 24.5 Stakeholder engagement, building trust and transparency in AI systems. Multi-stakeholder communication relationship management and comprehensive stakeholder mapping and engagement strategy. Stakeholder engagement creates trust and transparency while building relationship expertise and communication capability essential for AI implementations that require broad stakeholder support, transparent communication, and sustained trust through systematic engagement and relationship management. Stakeholder analysis includes stakeholder identification, interest assessment, influence evaluation, and relationship mapping that provide comprehensive stakeholder understanding while building stakeholder thinking and analysis capability. Analysis should be thorough while remaining practical and focused on effective engagement rather than analysis complexity or artificial stakeholder sophistication. Engagement strategy includes communication planning, relationship building, trust development, and collaboration facilitation that create effective stakeholder relationships while building engagement thinking and strategy capability. Strategy should be authentic while remaining systematic and focused on genuine relationship building rather than engagement complexity or artificial strategy sophistication. Communication frameworks include message development, channel selection, timing optimization, and feedback integration that enable effective stakeholder communication while building communication thinking and framework capability. Frameworks should be clear while remaining comprehensive and focused on effective communication rather than framework complexity or artificial communication sophistication. Trust building includes credibility development, reliability demonstration, transparency provision, and integrity maintenance that create stakeholder trust while building trust thinking and relationship capability. Building should be earned while remaining systematic and focused on genuine trustworthiness rather than trust manipulation or artificial credibility claims. Relationship maintenance includes ongoing engagement, value delivery, support provision, and partnership development that sustain stakeholder relationships while building relationship thinking and maintenance capability. Maintenance should be continuous while remaining authentic and focused on mutual benefit rather than relationship complexity or artificial maintenance sophistication. Public communication and transparency initiatives. Public communication creates transparency while building communication expertise and transparency capability essential for AI implementations that require public trust, social acceptance, and transparent operation through effective public communication and transparency initiatives. Public education includes AI literacy, technology explanation, benefit communication, and concern addressing that build public understanding while building education thinking and communication capability. Education should be accessible while remaining accurate and focused on genuine understanding rather than education complexity or artificial communication sophistication. Credibility establishment includes expertise demonstration, competence communication, authority building, and reputation development that create institutional credibility while building credibility thinking and establishment capability. Establishment should be earned while remaining systematic and focused on genuine credibility rather than credibility manipulation or artificial authority claims. Reliability demonstration includes consistency showing, dependability proving, trustworthiness evidencing, and stability maintaining that demonstrate institutional reliability while building reliability thinking and demonstration capability. Demonstration should be authentic while remaining systematic and focused on genuine reliability rather than reliability theater or artificial dependability claims. Transparency practices include openness maintenance, disclosure provision, clarity communication, and accessibility ensuring that create institutional transparency while building transparency thinking and practice capability. Practices should be comprehensive while remaining practical and focused on genuine transparency rather than transparency complexity or artificial openness claims. Accountability mechanisms include responsibility acceptance, oversight provision, consequence management, and improvement commitment that demonstrate institutional accountability while building accountability thinking and mechanism capability. Mechanisms should be meaningful while remaining practical and focused on genuine accountability rather than accountability theater or artificial responsibility claims. Ethical leadership includes moral guidance, principled decision-making, value demonstration, and integrity modeling that provide ethical leadership while building leadership thinking and ethical capability. Leadership should be authentic while remaining effective and focused on genuine moral guidance rather than ethical posturing or artificial moral claims. Community engagement and participatory governance. Community engagement creates participatory governance while building engagement expertise and participation capability essential for AI implementations that require community involvement, democratic participation, and collaborative decision-making through meaningful community engagement and participatory processes. Participatory design includes community input, collaborative planning, shared decision-making, and inclusive development that involve communities in AI design while building participatory thinking and design capability. Design should be meaningful while remaining practical and focused on genuine participation rather than participatory complexity or artificial inclusion claims. Community advisory includes local input, resident consultation, neighborhood involvement, and citizen participation that provide community guidance while building advisory thinking and consultation capability. Advisory should be influential while remaining practical and focused on genuine community input rather than advisory theater or artificial consultation claims. Collaborative governance includes shared authority, joint decision-making, partnership development, and cooperative management that create collaborative governance while building collaboration thinking and governance capability. Governance should be genuine while remaining efficient and focused on effective collaboration rather than governance complexity or artificial partnership claims. Feedback integration includes input collection, suggestion incorporation, concern addressing, and improvement implementation that respond to community feedback while building integration thinking and responsiveness capability. Integration should be meaningful while remaining practical and focused on genuine responsiveness rather than feedback theater or artificial integration claims. Capacity building includes skill development, knowledge sharing, empowerment facilitation, and capability enhancement that build community capacity while building capacity thinking and development capability. Building should be empowering while remaining sustainable and focused on genuine capacity development rather than capacity complexity or artificial empowerment claims. 24.6 Policy Development and Advocacy. Influencing AI Governance. Organizational and industry levels. AI Policy Framework Development. Organizational policy creation and implementation. Policy development creates systematic governance while building policy expertise and development capability essential for AI implementations that require clear policies, effective implementation, and organizational alignment through comprehensive policy frameworks and implementation strategies. Policy architecture includes principle establishment, framework design, structure creation, and system development that provide comprehensive AI policy while building policy thinking and architecture capability. Architecture should be principled while remaining practical and focused on policy effectiveness rather than architecture complexity or artificial policy sophistication. Stakeholder consultation includes input collection, feedback integration, consultation facilitation, and collaborative development that involves stakeholders in policy creation while building consultation thinking and collaborative capability. Consultation should be meaningful while remaining efficient and focused on genuine stakeholder involvement rather than consultation complexity sophistication or artificial collaborative. Policy implementation includes procedure development, training provision, support creation, and compliance facilitation that enable effective policy adoption while building implementation thinking and facilitation capability. Implementation should be systematic while remaining practical and focused on policy adoption rather than implementation complexity or artificial facilitation sophistication. Change management includes adaptation planning, transition management, resistance addressing, and culture integration that facilitate policy adoption while building change thinking and management capability. Management should be supportive while remaining systematic and focused on successful change rather than management complexity or artificial change sophistication. Effectiveness evaluation includes impact assessment, performance measurement, outcome evaluation, and improvement identification that assess policy effectiveness while building evaluation thinking and assessment capability. Evaluation should be rigorous while remaining practical and focused on policy improvement rather than evaluation complexity or artificial assessment sophistication. Industry standards and best practice development. Industry development creates sector standards while building industry expertise and standard capability essential for AI governance that requires industry leadership, best practice development, and sector coordination through collaborative industry initiatives and standard development. Standard development includes requirement specification, criteria establishment, benchmark creation, and measure development that create industry standards while building standard thinking and development capability. Development should be rigorous while remaining achievable and focused on industry improvement rather than standard complexity or artificial development sophistication. Best practice identification includes excellence recognition, success analysis, pattern identification, and wisdom extraction that identify industry best practices while building practice thinking and identification capability. Identification should be evidence-based while remaining practical and focused on practice sharing rather than identification complexity or artificial practice sophistication. Industry collaboration includes partnership development, cooperation facilitation, coordination enabling, and alliance building that create industry cooperation while building collaboration thinking and partnership capability. Collaboration should be productive while remaining competitive and focused on industry benefit rather than collaboration complexity or artificial partnership sophistication. Knowledge sharing includes expertise exchange, experience communication, learning facilitation, and wisdom distribution that enable industry learning while building sharing thinking and knowledge capability. Sharing should be generous while remaining strategic and focused on industry advancement rather than sharing complexity or artificial knowledge sophistication. Leadership development includes thought leadership, influence building, authority establishment, and standard setting that create industry leadership while building leadership thinking and influence capability. Development should be earned while remaining collaborative and focused on industry benefit rather than leadership complexity or artificial influence sophistication. Regulatory advocacy and public policy. Regulatory engagement and policy influence. Regulatory advocacy creates policy influence while building advocacy expertise and influence capability essential for AI governance that requires regulatory engagement, policy shaping, and public influence through systematic advocacy and policy development initiatives. Regulatory strategy includes policy analysis, influence planning, engagement strategy, and advocacy coordination that guide regulatory engagement while building strategy thinking and advocacy capability. Strategy should be principled while remaining practical and focused on beneficial policy rather than strategy complexity or artificial advocacy sophistication. Policy analysis includes legislation review, regulation assessment, impact evaluation, and implication analysis that understand policy landscape while building analysis thinking and policy capability. Analysis should be comprehensive while remaining actionable and focused on policy understanding rather than analysis complexity or artificial policy sophistication. Stakeholder coalition includes alliance building, partnership development, coalition formation, and collaborative advocacy that create advocacy coalitions while building coalition thinking and alliance capability. Coalition should be principled while remaining strategic and focused on policy advancement rather than coalition complexity or artificial alliance sophistication. Public testimony includes evidence presentation, expert witness, testimony delivery, and advocacy communication that influence policy development while building testimony thinking and advocacy capability. Testimony should be compelling while remaining factual and focused on policy influence rather than testimony complexity or artificial advocacy sophistication. Policy recommendation includes proposal development, solution creation, improvement suggestion, and advancement planning that contribute to policy development while building recommendation thinking and proposal capability. Recommendation should be practical while remaining ambitious and focused on policy improvement rather than recommendation complexity sophistication. Or artificial. Thought leadership and industry influence. Proposal. Thought leadership creates industry influence while building leadership expertise and influence capability essential for AI governance that requires intellectual leadership, industry guidance, and professional influence through thought leadership and industry contribution. Expertise development includes knowledge building, skill enhancement, authority establishment, and credibility development that create professional expertise while building expertise thinking and authority capability. Development should be genuine while remaining systematic and focused on authentic expertise rather than expertise complexity or artificial authority claims. Content creation includes writing development, research publication, insight sharing, and knowledge contribution that establish thought leadership while building content thinking and creation capability. Creation should be valuable while remaining accessible and focused on industry contribution rather than content complexity or artificial knowledge claims. Speaking engagement includes presentation delivery, conference participation, panel discussion, and keynote speaking that provide thought leadership platforms while building speaking thinking and presentation capability. Engagement should be influential while remaining authentic and focused on value delivery rather than speaking complexity or artificial influence claims. Professional networking includes relationship building, community participation, collaboration development, and influence expansion that create professional networks while building networking thinking and relationship capability. Networking should be genuine while remaining strategic and focused on mutual benefit rather than networking complexity or artificial relationship claims. Industry contribution includes standard development, practice advancement, knowledge sharing, and field improvement that contribute to industry progress while building contribution thinking and advancement capability. Contribution should be meaningful while remaining collaborative and focused on industry benefit rather than contribution complexity or artificial advancement claims. Chapter 24 Conclusion: Ethics and Governance Specialists as Guardians of Responsible AI. Chapter 24 establishes the comprehensive framework for developing ethics and governance specialists who can design, implement, and oversee comprehensive governance frameworks that ensure AI systems remain fair, transparent, accountable, and aligned with organizational values while building the ethical expertise, regulatory knowledge, and governance leadership capabilities essential for senior compliance and ethics roles. The Advanced Bias Detection and Mitigation Framework provides sophisticated methodologies for ensuring AI fairness while building bias expertise and mitigation capabilities that enable specialists to identify and address subtle forms of discrimination through technical and organizational approaches that create genuinely equitable AI systems. The regulatory compliance and legal framework development creates comprehensive understanding of complex regulatory environments while building compliance expertise and legal capabilities that enable ethics and governance specialists to navigate evolving regulatory requirements across multiple jurisdictions and industry sectors with confidence and competence. The governance system architecture and policy development components build institutional expertise while creating oversight capabilities that enable comprehensive AI governance through well-designed organizational structures, clear decision processes, and effective policy frameworks that balance innovation with responsibility. The risk assessment and management frameworks build systematic risk capability while creating mitigation expertise that enables proactive identification and management of AI-related risks technical through comprehensive and organizational risk management approaches that protect both organizations and stakeholders. The stakeholder engagement and trust-building components create relationship expertise while building communication capabilities that enable effective engagement with diverse stakeholder groups through transparent communication, authentic relationship building, and sustained trust development that supports responsible AI adoption. The policy development and advocacy frameworks build influence capability while creating leadership expertise that enables ethics and governance specialists to shape AI governance at organizational and industry levels through effective policy development, regulatory engagement, and thought leadership that advances responsible AI practices. The comprehensive 6-month specialization track established in Chapter 24 transforms foundational AI-fluent professionals into ethical governance leaders capable of ensuring AI implementations create positive societal while achieving business objectives impact through responsible development practices that build lasting trust and competitive advantage. This specialization track represents recognition that successful enterprise AI adoption requires not just technically competent professionals but ethical leaders who can navigate the complex moral landscape of AI implementation, ensuring technological advancement serves human welfare and societal good while maintaining compliance with evolving regulatory requirements and stakeholder expectations in an increasingly AI-driven world. Part 8. Implementation Resources and Tools. Introduction of Chapter 25. Learning Management System Excellence Enterprise LMS Evaluation, Comprehensive Assessment Frameworks for Platform Selection including educational methodology support, technical architecture, and integration capabilities AI-enhanced learning, adaptive learning systems, intelligent tutoring, content recommendation, and personalized learning pathways for optimized individual development competency-based architecture, portfolio management, skill badging, peer review systems, and professional networking platforms for comprehensive skill development and validation. Advanced Analytics, Learning Analytics, performance prediction, engagement measurement, and outcome evaluation for continuous improvement and optimization. AI tool access and platform management. Multi-vendor coordination, systematic management of OpenAI, Anthropic, Google, and specialized AI platforms with enterprise-grade reliability and cost optimization. License management, comprehensive compliance tracking, user provisioning, cost allocation, and audit preparation for legal and efficient AI tool usage. Custom development, requirements analysis, integration architecture, and maintenance frameworks for specialized learning tools and platform customizations. Service reliability, uptime monitoring, performance tracking, backup planning, and continuity assurance for consistent educational service delivery. Cloud infrastructure and development environments. Enterprise cloud architecture, platform selection, infrastructure provisioning, auto-scaling configuration, and security implementation for scalable learning environments. Professional development workflows, IDE configuration, version control integration, CI/CD pipelines, and collaboration tools that mirror enterprise development practices. API management, gateway configuration, authentication management, rate limiting, and monitoring for reliable service integration and resource optimization. Production-ready environments, development and production setup, monitoring systems, and testing frameworks that prepare participants for real-world implementation assessment and portfolio infrastructure. Multimodal assessment, automated grading, competency tracking, portfolio integration, and peer assessment for comprehensive skill evaluation and validation. Professional portfolio development, portfolio architecture, content curation, multimedia integration, and career advancement support for professional showcase creation. Showcase platforms, presentation infrastructure, public galleries, interactive demonstrations, and professional recognition systems for competency demonstration. Quality assurance, assessment reliability, validity verification, bias prevention, and certification pathways for credible competency validation. Communication and collaboration excellence. Unified communication ecosystem, platform integration, real-time collaboration, asynchronous communication, and mobile accessibility for seamless learning experiences. Virtual learning environments, interactive classrooms, engagement gamification, workshop facilitation, and mentoring systems for dynamic online education. Global accessibility, multilanguage support, cultural adaptation, accessibility compliance, and coordination for inclusive international education time zone. Adaptive technology, learning style accommodation, assistive technology integration, and personalized optimization for diverse learning needs and preferences, security and privacy protection. Enterprise security architecture, comprehensive threat protection, access control, data encryption, network security, and incident response for robust system protection. Privacy compliance, GDPR compliance, data minimization, consent management, and audit preparation for regulatory adherence and ethical data handling. Intellectual property protection, content security, license management. Chapter 25. Technology infrastructure and platform requirements. 25.1 Learning Management System Selection and Configuration. Enterprise Learning Platform Assessment and Selection. Comprehensive LMS Evaluation Framework. Learning Management System Selection requires systematic evaluation that balances educational effectiveness with organizational requirements while building platform expertise and selection capability essential for AI training programs that require sophisticated learning environments supporting diverse learning styles and complex skill development. Platform assessment includes feature evaluation, scalability analysis, integration capability, and user experience assessment that guide LMS selection while building assessment thinking and evaluation capability. Assessment should be comprehensive while remaining practical and focused on educational effectiveness rather than feature complexity or artificial platform sophistication. Educational methodology support includes competency-based learning, portfolio assessment, collaborative projects, and practical application that align with AI training requirements while building methodology thinking and support capability. Support should be robust while remaining flexible and focused on learning effectiveness rather than methodology complexity or artificial educational sophistication. Technical architecture includes cloud deployment, API integration, mobile accessibility, and performance optimization that provide reliable platform operation while building architecture thinking and technical capability. Architecture should be scalable while remaining maintainable and focused on platform reliability rather than technical complexity or artificial architecture sophistication. User experience design includes interface usability, navigation simplicity, content accessibility, and engagement facilitation that create positive learning experiences while building UX thinking and design capability. Design should be intuitive while remaining comprehensive and focused on learner success rather than interface complexity or artificial design sophistication. Integration ecosystem includes third-party tools, assessment platforms, communication development environments that learning environments. Systems, and create comprehensive while building integration thinking and ecosystem capability. Ecosystem should be seamless while remaining manageable and focused on learning enhancement rather than integration complexity or artificial ecosystem sophistication. Platform configuration and customization. Platform configuration creates optimized learning environments while building configuration expertise and customization capability essential for AI training programs that require tailored learning experiences supporting diverse organizational contexts and participant requirements. Learning pathway design includes course structure, progression logic, prerequisite management, and competency tracking that creates systematic learning experiences while building pathway thinking and design capability. Design should be logical while remaining flexible and focused on learning progression rather than pathway complexity or artificial design sophistication. Content organization includes module structure, resource management, multimedia integration, and knowledge architecture that facilitate effective content delivery while building organization thinking and management capability. Organization should be intuitive while remaining comprehensive and focused on content accessibility rather than complexity or artificial management organization sophistication. Assessment integration includes quiz creation, project submission, portfolio development, and competency evaluation that enable comprehensive skill assessment while building assessment thinking and integration capability. Integration should be seamless while remaining rigorous and focused on genuine competency measurement rather than assessment complexity or artificial evaluation sophistication. Collaboration features include team formation, project management, peer review, and knowledge sharing that facilitate collaborative learning while building collaboration thinking and feature capability. Features should be engaging while remaining productive and focused on collaborative learning artificial collaboration sophistication rather than feature. Analytics and reporting. Complexity includes progress tracking, performance analysis, engagement measurement, and outcome evaluation that provide learning insights while building analytics thinking and reporting capability. Analytics should be meaningful while remaining actionable and focused on learning improvement rather than analytics complexity or artificial reporting sophistication. Advanced learning features and functionality. AI-enhanced learning platform capabilities. AI-enhanced platforms create personalized learning while building AI expertise and enhancement capability essential for AI training programs that leverage artificial intelligence to optimize learning experiences, adapt to individual needs, and accelerate skill development through intelligent tutoring and adaptive learning systems. Adaptive learning includes difficulty adjustment, pace modification, content personalization, and pathway optimization that create individualized learning experiences while building an adaptive thinking personalization capability. Learning should be responsive while remaining structured and focused on individual optimization rather than adaptive complexity, artificial personalization, sophistication. Or intelligent tutoring includes automated guidance, hint provision, error correction, and learning support that provide personalized assistance while building tutoring thinking and guidance capability. Tutoring should be helpful while remaining appropriate and focused on learning support rather than tutoring complexity or artificial guidance sophistication. Content recommendation includes resource suggestion, skill development, knowledge gap identification, and learning optimization that guide learning progression while building recommendation thinking and optimization capability. Recommendation should be relevant while remaining unobtrusive and focused on learning enhancement rather than recommendation complexity or artificial optimization sophistication. Performance prediction includes progress forecasting, outcome modeling, risk identification, and intervention planning that enable proactive learning support while building prediction thinking and modeling capability. Prediction should be accurate while remaining supportive and focused on learning success rather than prediction complexity or artificial modeling sophistication. Learning analytics includes pattern recognition, insight generation, improvement identification, and optimization guidance that enhance learning effectiveness while building analytics thinking and insight capability. Analytics should be actionable while remaining privacy-respecting and focused on learning improvement rather than analytics complexity or artificial insight sophistication. Competency-based learning creates skill-focused education while building competency expertise and portfolio capability essential for AI training programs that emphasize practical skill development, evidence-based assessment, and professional portfolio creation through systematic competency frameworks and portfolio management systems. Development rather than networking complexity or artificial community sophistication. 25.2 AI Tool Access and Licensing, OpenAI. Anthropic, Google, and Specialized Platform. Anthropic, Google, and Specialized Platform. Management. Enterprise AI Platform Integration. Multi-vendor AI Service Management. AI platform management requires comprehensive coordination across multiple vendors while building platform expertise and management capability essential for AI training programs that require diverse AI tools, consistent access, and enterprise-grade reliability through systematic vendor management and platform integration. Vendor portfolio management includes provider selection, contract negotiation, relationship management, and performance monitoring that optimize AI tool access while building vendor thinking and management capability. Management should be strategic while remaining cost-effective and focused on educational value rather than vendor complexity or artificial management sophistication. API integration includes service connection, authentication management, rate limiting, and error handling that enable reliable AI tool access while building integration thinking and technical capability. Integration should be robust while remaining maintainable and focused on service reliability rather. Integration complexity or artificial technical and sophistication. Cost optimization includes usage monitoring, budget management, resource allocation, and efficiency improvement that control AI platform costs while building cost thinking and optimization capability. Optimization should be strategic while remaining service-focused and focused on value maximization rather than cost-cutting or artificial optimization sophistication. Service reliability includes uptime monitoring, performance tracking, backup planning, and continuity assurance that ensure consistent AI tool availability while building reliability thinking and service capability. Reliability should be comprehensive while remaining practical and focused on service consistency rather than reliability complexity or artificial service sophistication. Usage analytics includes consumption tracking, pattern analysis, optimization identification, and efficiency improvement that optimize AI tool utilization while building analytics thinking and usage capability. Analytics should be insightful while remaining actionable and focused on usage optimization rather than analytics complexity or artificial usage sophistication. License management and compliance. License management creates compliant AI tool usage while building licensing expertise and compliance capability essential for AI training programs that require legal AI tool usage. Cost. Control and license optimization through systematic license management and compliance monitoring. License tracking includes usage monitoring, compliance verification, limit management, and violation prevention that ensure legal AI tool usage while building tracking thinking and compliance capability. Tracking should be systematic while remaining efficient and focused on compliance assurance rather than tracking sophistication. User complexity or artificial compliance. Provisioning includes account creation, access management, permission setting, and deprovisioning that control AI tool access while building provisioning thinking and access capability. Provisioning should be systematic while remaining secure and focused on appropriate access rather than provisioning complexity or artificial access sophistication. Compliance monitoring includes license adherence, usage verification, violation detection, and correction procedures that maintain license compliance while building monitoring thinking and compliance capability. Monitoring should be comprehensive while remaining efficient and focused on compliance maintenance rather than monitoring complexity or artificial compliance sophistication. Cost allocation includes expense distribution, budget assignment, usage attribution, and financial management that control license costs while building allocation thinking and financial capability. Allocation should be fair while remaining transparent and focused on cost control rather than allocation complexity or artificial financial sophistication. Audit preparation includes documentation maintenance, compliance evidence, usage reporting, and audit readiness that ensure license audit success while building audit thinking and preparation capability. Preparation should be systematic while remaining current and focused on audit readiness rather than preparation complexity or artificial audit sophistication. Specialized AI platform configuration. Development and production environment setup. Environment configuration creates professional AI development while building environment expertise and setup capability essential for AI training programs that require realistic development environments, production-ready deployments, and enterprise-grade infrastructure through systematic environment management and configuration. Development environment includes tool installation, configuration management, resource allocation, and workspace setup that create effective development environments while building environment thinking and setup capability. Environment should be comprehensive while remaining manageable and focused on development effectiveness rather than environment complexity or artificial setup sophistication. Production deployment includes infrastructure setup, scaling configuration, monitoring integration, and maintenance procedures that enable production-ready AI implementations while building deployment thinking and production capability. Deployment should be reliable while remaining efficient and focused on production readiness rather than deployment complexity or artificial production sophistication. Version control includes code management, collaboration facilitation, change tracking, and release management that enable effective development collaboration while building version thinking and control capability. Control should be systematic while remaining accessible and focused on collaboration effectiveness rather than version complexity or artificial control sophistication. Testing frameworks include unit testing, integration testing, performance testing, and quality assurance that ensure AI implementation quality while building testing thinking and quality capability. Frameworks should be comprehensive while remaining maintainable and focused on quality assurance rather than testing complexity or artificial quality sophistication. Monitoring and logging includes performance tracking, error detection, usage monitoring, and diagnostic capability that enable proactive system management while building monitoring thinking and diagnostic capability. Monitoring should be comprehensive while remaining actionable and focused on system health rather than monitoring complexity or artificial diagnostic sophistication. Custom tool development and integration. Custom development creates specialized learning tools while building development expertise and integration capability essential for AI training programs that require customized solutions, specialized integrations, and unique learning experiences through systematic custom development and tool integration. Requirements analysis includes need identification, specification development, solution design, and implementation planning that guide custom development while building analysis thinking and development capability. Analysis should be thorough while remaining practical and focused on genuine needs rather than analysis complexity or artificial development sophistication. Development methodology includes agile practices, iterative development, testing integration, and quality assurance that ensure effective custom building methodology development while thinking and development capability. Methodology should be systematic while remaining flexible and focused on development effectiveness rather than methodology complexity artificial development sophistication. Integration architecture includes API design, data flow management, security implementation, and system coordination that enable effective tool integration while building architecture thinking and integration capability. Architecture should be robust while remaining maintainable and focused on integration effectiveness rather than architecture complexity or artificial integration sophistication. User experience design includes interface creation, interaction design, usability optimization, and accessibility assurance that create effective custom tools while building UX thinking and design capability. Design should be intuitive while remaining functional and focused on user effectiveness rather than design complexity or artificial UX sophistication. Maintenance and support includes bug fixing, feature enhancement, performance optimization, and user support that sustain custom tools while building maintenance thinking and support capability. Maintenance should be responsive while remaining sustainable and focused on tool effectiveness rather than maintenance complexity support sophistication. 25.3 or artificial development environment setup. Cloud platforms, APIs, and collaboration. Tools. Cloud infrastructure architecture. Enterprise cloud platform configuration. Cloud platform setup creates scalable infrastructure while building cloud expertise and configuration capability essential for AI training programs that require reliable computing. Resources, flexible scaling, and enterprise-grade security through systematic cloud platform management and optimization. Platform selection includes provider evaluation, service comparison, cost analysis, and capability assessment that guide cloud platform choice while building selection thinking and evaluation capability. Selection should be strategic while remaining practical and focused on educational requirements rather than platform complexity or artificial selection sophistication. Infrastructure provisioning includes resource allocation, network configuration, security setup, and service deployment that create functional cloud environments while building provisioning thinking and infrastructure capability. Provisioning should be systematic while remaining efficient and focused on infrastructure effectiveness rather than provisioning complexity sophistication. Or artificial infrastructure. Auto-scaling configuration includes demand monitoring, resource adjustment, cost optimization, and performance maintenance that provide responsive infrastructure while building scaling thinking and optimization capability. Configuration should be intelligent while remaining cost-effective and focused on resource optimization rather than scaling complexity or artificial optimization sophistication. Security implementation includes access control, data protection, network security, and compliance assurance that protect cloud infrastructure while building security thinking and protection capability. Implementation should be comprehensive while remaining usable and focused on genuine security rather than security complexity or artificial protection sophistication. Monitoring and optimization includes performance tracking, cost analysis, resource utilization, and efficiency improvement that optimize cloud infrastructure while building monitoring thinking and optimization capability. Monitoring should be continuous while remaining actionable and focused on infrastructure optimization rather than monitoring complexity or artificial optimization sophistication. Development tool integration and workflow. Development integration creates efficient workflows while building integration expertise and workflow capability essential for AI training programs that require seamless development experiences, collaborative coding, and professional development practices through systematic tool integration and workflow optimization. IDE configuration includes editor setup, plugin installation, environment customization, and workflow optimization that create effective development environments while building IDE thinking and configuration capability. Configuration should be comprehensive while remaining user-friendly and focused on development effectiveness rather than configuration complexity or artificial IDE sophistication. Version control integration includes Git setup, repository management, collaboration workflows, and change tracking that enable effective code collaboration while building version thinking and collaboration capability. Integration should be systematic while remaining accessible and focused on collaboration effectiveness rather than version complexity or artificial collaboration sophistication. CI/CD pipeline includes automated testing, build processes, deployment automation, and quality gates that enable professional development practices while building pipeline thinking and automation capability. Pipeline should be reliable while remaining efficient and focused on development quality rather than pipeline complexity or artificial automation sophistication. Collaboration tools include code review, pair programming, knowledge sharing, and team coordination that facilitate effective development collaboration while building collaboration thinking and team capability. Tools should be intuitive while remaining powerful and focused on team effectiveness rather than tool complexity or artificial collaboration sophistication. Documentation systems include code documentation, knowledge management, tutorial creation, and information sharing that support development learning while building documentation thinking and knowledge capability. Systems should be comprehensive while remaining accessible and focused on knowledge sharing rather than documentation complexity or artificial knowledge sophistication. API management and integration framework. Enterprise API gateway and management. API management creates systematic service integration while building API expertise and integration capability essential for AI training programs that require reliable service access, secure authentication, and efficient resource utilization through comprehensive API management and gateway configuration. Gateway configuration includes API routing, load balancing, rate limiting, and traffic management that optimize API access while building gateway thinking and configuration capability. Configuration should be robust while remaining maintainable and focused on service reliability rather than gateway complexity or artificial configuration sophistication. Authentication management includes security protocols, token management, access control, and identity verification that protect API access while building authentication thinking and security capability. Management should be secure while remaining user-friendly and focused on appropriate access rather than authentication complexity or artificial security sophistication. Rate limiting includes usage control, quota management, throttling implementation, and fair use enforcement that optimize API usage while building limiting thinking and control capability. Limiting should be fair while remaining protective and focused on resource optimization rather than limiting complexity or artificial control sophistication. Monitoring and analytics includes usage tracking, performance measurement, error monitoring, and optimization guidance that optimize API utilization while building monitoring thinking and analytics capability. Monitoring should be comprehensive while remaining actionable and focused on API optimization rather than monitoring complexity or artificial analytics sophistication. Error handling includes exception management, retry logic, fallback procedures, and graceful degradation that ensure API reliability while building error thinking and handling capability. Handling should be robust while remaining efficient and focused on service reliability rather than error complexity or artificial handling sophistication. Third-party service integration. Service integration creates comprehensive functionality while building integration expertise and service capability essential for AI training programs that require diverse external services, reliable integrations, and seamless user experiences through systematic third-party service management and integration. Service evaluation includes provider assessment, capability analysis, reliability verification, and cost evaluation that guide service selection while building evaluation thinking and assessment capability. Evaluation should be thorough while remaining practical and focused on service value rather than evaluation complexity or artificial assessment sophistication. Integration architecture includes connection design, data flow management, error handling, and security implementation that enable reliable service integration while building architecture thinking and integration capability. Architecture should be robust while remaining maintainable and focused on integration reliability rather than architecture complexity or artificial integration sophistication. Data synchronization includes information consistency, update propagation, conflict resolution, and integrity maintenance that ensure data coherence across services while building synchronization thinking and data capability. Synchronization should be reliable while remaining efficient and focused on data consistency rather than synchronization complexity or artificial data sophistication. Service redundancy includes backup services, failover mechanisms, alternative providers, and continuity assurance that ensure service reliability while building redundancy thinking and resilience capability. Redundancy should be sufficient while remaining cost-effective and focused on service continuity rather than redundancy complexity or artificial resilience sophistication. Performance optimization includes latency reduction, throughput improvement, caching implementation, and efficiency enhancement that optimize service performance while building optimization thinking and performance capability. Optimization should be systematic while remaining practical and focused on service effectiveness rather than optimization complexity sophistication or artificial performance. 25 point for assessment platform integration. Automated testing, management systems, and comprehensive assessment infrastructure. Portfolio, multimodal assessment platform architecture. Assessment platform design creates comprehensive evaluation while building assessment expertise and platform capability essential for AI training programs that require diverse assessment methods, automated grading, and sophisticated competency measurement through systematic assessment platform integration and management. Assessment methodology includes competency evaluation, skill measurement, knowledge testing, and performance assessment that provide comprehensive skill evaluation while building assessment thinking and methodology capability. Methodology should be rigorous while remaining fair and focused on genuine competency measurement rather than assessment complexity or artificial methodology sophistication. Automated grading includes algorithm development, rubric implementation, consistency assurance, and quality control that enable efficient assessment while building grading thinking and automation capability. Grading should be accurate while remaining fair and focused on consistent evaluation rather than grading complexity or artificial automation sophistication. Portfolio integration includes project collection, artifact organization, reflection capture, and showcase creation that demonstrate learning achievement while building portfolio thinking and integration capability. Integration should be seamless while remaining comprehensive and focused on competency demonstration rather than portfolio complexity or artificial integration sophistication. Peer assessment includes collaborative evaluation, feedback provision, quality assurance, and learning enhancement that leverage peer learning while building peer thinking and collaboration capability. Assessment should be structured while remaining authentic and focused on learning improvement rather than peer complexity or artificial collaboration sophistication. Real-time feedback includes immediate response, improvement guidance, learning support, and progress tracking that enhance learning effectiveness while building feedback thinking and responsiveness capability. Feedback should be timely while remaining constructive and focused on learning improvement rather than feedback complexity or artificial responsiveness sophistication. Competency tracking and skill validation. Competency tracking creates systematic skill measurement while building tracking expertise and validation capability essential for AI training programs that require precise skill assessment, progress monitoring, and competency certification through comprehensive tracking systems and validation frameworks. Skill mapping includes competency definition, proficiency levels, assessment criteria, and progression pathways that create structured skill development while building mapping thinking and competency capability. Mapping should be comprehensive while remaining practical and focused on skill development rather than mapping complexity or artificial competency sophistication. Progress analytics development includes competency learning growth, tracking, and skill achievement measurement that monitor learning progress while building analytics thinking and tracking capability. Analytics should be meaningful while remaining actionable and focused on learning improvement rather than analytics complexity or artificial tracking sophistication. Badge systems include achievement recognition, skill certification, competency validation, and accomplishment showcasing that recognize learning progress while building badge thinking and recognition capability. Systems should be meaningful while remaining achievable and focused on genuine accomplishment rather than badge complexity or artificial recognition sophistication. Certification pathways include credential development, validation processes, external recognition, and professional certification that establish professional credentials while building certification thinking and pathway capability. Pathways should be rigorous while remaining accessible and focused on professional competency rather than certification complexity or artificial pathway sophistication. Quality assurance includes assessment reliability, validity verification, bias prevention, and fairness assurance that ensure assessment quality while building quality thinking and assurance capability. Assurance should be systematic while remaining practical and focused on assessment integrity rather than quality complexity or artificial assurance sophistication. Portfolio management and showcase systems. Professional portfolio development platform. Portfolio development creates professional showcases while building portfolio expertise and development capability essential for AI training programs that require professional portfolio creation, career advancement support, and competency demonstration through sophisticated portfolio management and showcase systems. Portfolio architecture includes structure design, content organization, presentation optimization, and accessibility assurance that create effective portfolios while building architecture thinking and design capability. Architecture should be professional while remaining personal and focused on competency demonstration rather than architecture complexity or artificial design sophistication. Content curation includes project selection, artifact refinement, reflection integration, and narrative development that create compelling portfolios while building curation thinking and content capability. Curation should be strategic while remaining authentic and focused on professional presentation rather than curation complexity or artificial content sophistication. Multimedia integration includes video production, interactive demonstrations, visual presentations, and multimedia showcases that enhance portfolio impact while building multimedia thinking and production capability. Integration should be engaging while remaining professional and focused on competency demonstration rather than multimedia complexity or artificial production sophistication. Professional networking includes portfolio sharing, peer review, mentor feedback, and industry connection that leverage portfolios for career development while building networking thinking and connection capability. Networking should be strategic while remaining authentic and focused on professional development rather than networking complexity or artificial connection sophistication. Career integration includes job application support, interview preparation, professional branding, and career advancement that leverage portfolios for career success while building career thinking and advancement capability. Integration should be practical while remaining strategic and focused on career success rather than integration complexity or artificial advancement sophistication. Showcase and presentation infrastructure. Showcase infrastructure creates professional presentation while building presentation expertise and showcase capability essential for AI training programs that require professional portfolio presentation, public demonstration, and competency showcasing through sophisticated presentation platforms and showcase systems. Presentation platforms include showcase creation, audience engagement, interactive demonstrations, and professional presentation that enable effective competency demonstration while building presentation thinking and platform capability. Platforms should be professional while remaining accessible and focused on competency showcase rather than platform complexity or artificial presentation sophistication. Public galleries include community showcases, peer learning, inspiration sharing, and achievement celebration that create learning communities while building gallery thinking and community capability. Galleries should be engaging while remaining professional and focused on learning community rather than gallery complexity or artificial community sophistication. Interactive demonstrations include hands-on experiences, user engagement, practical application, and skill demonstration that showcase practical competency while building demonstration thinking and interaction capability. Demonstration should be engaging while remaining substantive and focused on competency demonstration rather than demonstration complexity or artificial interaction sophistication. Feedback systems include peer review, expert evaluation, mentor guidance, and improvement suggestions that enhance portfolio quality while building feedback thinking and improvement capability. Systems should be constructive while remaining honest and focused on improvement rather than feedback complexity or artificial improvement sophistication. Professional recognition includes industry acknowledgement, employer attention, peer recognition, and career advancement that leverage showcases for professional benefit while building recognition thinking and professional capability. Recognition should be earned while remaining valuable and focused on professional advancement rather than recognition complexity or artificial professional sophistication. 25.5 Communication and collaboration. Infrastructure, supporting remote and hybrid learning. Advanced communication platform integration. Unified communication and collaboration ecosystem. Communication infrastructure creates seamless collaboration while building communication expertise and collaboration capability essential for AI training programs that require effective remote learning, team collaboration, and knowledge sharing through comprehensive communication platforms and collaboration tools. Platform integration includes unified messaging, video conferencing, document collaboration, and project management that create cohesive communication environments while building integration thinking and platform capability. Integration should be seamless while remaining user-friendly and focused on collaboration effectiveness rather than complexity or artificial integration platform sophistication. Real-time collaboration includes synchronous learning, live workshops, interactive sessions, and immediate feedback that enable dynamic learning experiences while building collaboration thinking and real-time capability. Collaboration should be engaging while remaining productive and focused on learning effectiveness rather than collaboration complexity or artificial real-time sophistication. Asynchronous communication includes discussion forums, message boards, knowledge sharing, and flexible interaction that accommodate diverse schedules while building asynchronous thinking and flexible capability. Communication should be accessible while remaining engaging and focused on learning continuity rather than asynchronous complexity or artificial flexibility sophistication. Mobile accessibility includes responsive design, mobile optimization, offline capability, and cross-device synchronization that enable ubiquitous learning access while building accessibility thinking and mobile capability. Accessibility should be comprehensive while remaining performant and focused on learning accessibility rather than mobile complexity or artificial accessibility sophistication. Knowledge management includes information organization, content curation, expertise capture, and institutional memory that preserve and share learning knowledge while building knowledge thinking and management capability. Management should be systematic while remaining accessible and focused on knowledge sharing rather than management complexity or artificial knowledge sophistication. Virtual learning environment and engagement tools. Virtual environments create immersive learning while building virtual expertise and engagement capability essential for AI training programs that require engaging online learning, interactive experiences, and sustained participant motivation through sophisticated virtual learning platforms and engagement tools. Virtual classroom includes interactive whiteboards, breakout rooms, screen sharing, and collaborative workspaces that create engaging learning environments while building virtual thinking and classroom capability. Classrooms should be interactive while remaining manageable and focused on learning engagement rather than virtual complexity or artificial classroom sophistication. Engagement gamification includes learning games, achievement systems, progress tracking, and motivation enhancement that increase learning engagement while building gamification thinking and motivation capability. Gamification should be meaningful while remaining educational and focused on learning motivation rather than gamification complexity or artificial motivation sophistication. Interactive workshops include hands-on exercises, collaborative projects, peer learning, and practical application that create active learning experiences while building workshop thinking and interaction capability. Workshops should be engaging while remaining substantive and focused on skill development rather than workshop complexity or artificial interaction sophistication. Mentoring systems include mentor matching, guidance provision, relationship facilitation, and development support that enable effective mentoring while building mentoring thinking and support capability. Systems should be supportive while remaining structured and focused on individual development rather than mentoring complexity or artificial support sophistication. Community building includes peer connection, network formation, collaboration facilitation, and relationship development that create learning communities while building community thinking and relationship capability. Building should be organic while remaining intentional and focused on learning community rather than community complexity or artificial relationship sophistication. Global accessibility and inclusion infrastructure. Multilanguage and cultural adaptation systems. Accessibility infrastructure creates inclusive learning while building inclusion expertise and accessibility capability essential for AI training programs that serve diverse global populations with varying languages, cultures, and accessibility needs through comprehensive inclusion frameworks and adaptation systems. Internationalization includes language support, cultural adaptation, content localization, and regional customization that enable global learning access while building internationalization thinking and adaptation capability. Internationalization should be comprehensive while remaining authentic and focused on cultural respect rather than internationalization complexity or artificial adaptation sophistication. Accessibility compliance includes disability accommodation, assistive technology, universal design, and inclusive access that ensure learning accessibility for all participants while building accessibility thinking and compliance capability. Compliance should be comprehensive while remaining user-friendly and focused on genuine accessibility rather than compliance complexity or artificial accessibility sophistication. Cultural sensitivity includes cultural awareness, respectful communication, inclusive content, and diverse representation that create culturally appropriate learning while building sensitivity thinking and inclusion capability. Sensitivity should be authentic while remaining educational and focused on cultural respect rather than sensitivity complexity or artificial inclusion sophistication. Language processing includes translation services, multilingual support, content adaptation, and communication facilitation that enable cross-language learning while building language thinking and processing capability. Processing should be accurate while remaining natural and focused on communication effectiveness rather than language complexity or artificial processing sophistication. Time zone coordination includes scheduling optimization, global coordination, flexible timing, and asynchronous options that accommodate global participation while building coordination thinking and scheduling capability. Coordination should be inclusive while remaining practical and focused on global accessibility rather than coordination complexity or artificial scheduling sophistication. Adaptive learning technology and personalization. Adaptive technology creates personalized learning while building adaptation expertise and personalization capability essential for AI training programs that require individualized learning experiences, diverse learning styles, and optimized learning outcomes through sophisticated adaptive learning systems and personalization frameworks. Learning adaptation includes difficulty adjustment, pace modification, content customization, and pathway optimization that create personalized learning while building adaptation thinking and personalization capability. Adaptation should be intelligent while remaining respectful and focused on individual optimization rather than adaptation complexity or artificial personalization sophistication. Learning style accommodation includes visual learning, auditory processing, kinesthetic engagement, and style diversity that serve different learning preferences while building accommodation thinking and style capability. Accommodation should be comprehensive while remaining balanced and focused on learning effectiveness rather than accommodation complexity or artificial style sophistication. Assistive technology includes screen readers, voice recognition, alternative input, and accessibility tools that enable diverse ability learning while building assistive thinking and technology capability. Technology should be comprehensive while remaining integrated and focused on learning enablement rather than technology complexity or artificial assistive sophistication. Performance optimization includes learning analytics, progress tracking, optimization guidance, and improvement suggestions that enhance individual learning while building optimization thinking and performance capability. Optimization should be supportive while remaining unobtrusive and focused on learning improvement rather than optimization complexity or artificial performance sophistication. Inclusive design includes universal access, diverse representation, barrier removal, and equitable experience that create inclusive learning for all participants while building inclusive thinking and design capability. Design should be comprehensive while remaining natural and focused on genuine inclusion rather than design complexity or artificial inclusive sophistication. 25.6 Security and privacy considerations. Protecting participant data and intellectual property. Comprehensive security architecture. Enterprise-grade security framework implementation. Security architecture creates comprehensive protection while building security expertise and protection capability essential for AI training programs that require robust data protection, intellectual property security, and privacy compliance through sophisticated security frameworks and protection systems. Security assessment includes threat modeling, vulnerability analysis, risk evaluation, and protection planning that identify security requirements while building security thinking and assessment capability. Assessment should be comprehensive while remaining practical and focused on genuine security rather than assessment complexity or artificial security sophistication. Access control includes authentication systems, authorization frameworks, privilege management, and identity verification that control system access while building access thinking and control capability. Control should be secure while remaining user-friendly and focused on appropriate access rather than control complexity or artificial access sophistication. Data encryption includes data at rest protection, data in transit security, key management, and cryptographic implementation that protect sensitive information while building encryption thinking and protection capability. Encryption should be robust while remaining performant and focused on data protection rather than encryption complexity or artificial cryptographic sophistication. Network security includes firewall configuration, intrusion detection, traffic monitoring, and threat prevention that protect network infrastructure while building network thinking and security capability. Security should be comprehensive while remaining accessible and focused on network protection rather than security complexity or artificial network sophistication. Incident response includes threat detection, response procedures, recovery planning, and security maintenance that handle security events while building response thinking and incident capability. Response should be systematic while remaining rapid and focused on security restoration rather than response complexity or artificial incident sophistication. Data privacy and compliance management. Privacy management creates comprehensive protection while building privacy expertise and compliance capability essential for AI training programs that require personal data protection, regulatory compliance, and ethical data handling through systematic privacy frameworks and compliance systems. Privacy framework includes data classification, protection requirements, handling procedures, and compliance assurance that protect personal information while building privacy thinking and framework capability. Framework should be comprehensive while remaining practical and focused on privacy protection rather than framework complexity or artificial privacy sophistication. GDPR compliance includes data rights, consent management, breach notification, and privacy protection that ensure European regulatory compliance while building GDPR thinking and compliance capability. Compliance should be comprehensive while remaining practical and focused on genuine privacy protection rather than GDPR complexity or artificial compliance sophistication. Data minimization includes collection limitation, usage restriction, retention management, and disposal procedures that minimize privacy exposure while building minimization thinking and data capability. Minimization should be systematic while remaining functional and focused on privacy protection rather than minimization complexity or artificial data sophistication. Consent preference management includes permission collection, tracking, opt-out handling, and consent documentation that respect user privacy choices while building consent thinking and management capability. Management should be respectful while remaining practical and focused on user control rather than consent complexity or artificial management sophistication. Audit preparation includes documentation maintenance, compliance evidence, privacy records, and audit readiness that ensure privacy audit success while building audit thinking and preparation capability. Preparation should be systematic while remaining current and focused on audit readiness rather than preparation complexity or artificial audit sophistication. Intellectual property protection and digital rights management. Comprehensive IP protection framework. IP protection creates comprehensive security while building protection expertise and rights capability essential for AI training programs that require intellectual property protection, content security, and digital rights management through sophisticated protection frameworks and rights management systems. IP classification includes content categorization, protection levels, access controls, and usage restrictions that protect intellectual property while building classification thinking and protection capability. Classification should be systematic while remaining practical and focused on IP protection rather than classification complexity or artificial protection sophistication. Content protection includes digital watermarking, copy prevention, unauthorized access prevention, and usage monitoring that protect training content while building content thinking and protection capability. Protection should be effective while remaining user-friendly and focused on content. Security rather than protection complexity or artificial content sophistication. License management includes usage permissions, distribution rights, access controls, and compliance monitoring that manage content licenses while building license thinking and management capability. Management should be systematic while remaining compliant and focused on license adherence rather than management complexity or artificial license sophistication. Usage monitoring includes access tracking, distribution monitoring, compliance verification, and violation detection that monitor content usage while building monitoring thinking and usage capability. Monitoring should be comprehensive while remaining privacy-respecting and focused on compliance assurance rather than monitoring complexity or artificial usage sophistication. Rights enforcement includes violation response, enforcement procedures, legal protection, and remedy provision that protect intellectual property rights while building enforcement thinking and rights capability. Enforcement should be fair while remaining effective and focused on rights protection rather than enforcement complexity or artificial rights sophistication. Participant data protection and academic integrity. Data protection creates comprehensive security while building protection expertise and integrity capability essential for AI training programs that require participant data protection, academic integrity maintenance, and ethical data handling. Through systematic protection frameworks and integrity systems. Student privacy includes personal information protection, academic record security, communication privacy, and identity protection that protect participant privacy while building privacy thinking and student capability. Privacy should be comprehensive while remaining functional and focused on participant protection rather than privacy complexity or artificial student sophistication. Academic integrity includes plagiarism detection, original work verification, collaboration monitoring, and integrity assurance that maintain academic standards while building integrity thinking and academic capability. Integrity should be fair while remaining rigorous and focused on genuine learning rather than integrity complexity or artificial academic sophistication. Assessment security includes test security, answer protection, cheating prevention, and evaluation integrity that protect assessment validity while building security thinking and assessment capability. Security should be robust while remaining fair and focused on assessment integrity rather than security complexity or artificial assessment sophistication. Portfolio protection includes work ownership, attribution maintenance, unauthorized use prevention, and intellectual property protection that protect participant work while building portfolio thinking and protection capability. Protection should be comprehensive while remaining accessible and focused on work protection rather than portfolio complexity or artificial protection sophistication. Data retention includes storage limitation, disposal procedures, archive management, and lifecycle control that manage participant data appropriately while building retention thinking and lifecycle capability. Retention should be compliant while remaining practical and focused on appropriate data handling rather than retention complexity or artificial lifecycle sophistication. Chapter 25 Conclusion: Technology Infrastructure as the Foundation for AI Education Excellence. Chapter 25 establishes the comprehensive technology infrastructure framework required to support world-class AI-fluent professional development programs, from foundational training through advanced specialization tracks. This infrastructure foundation enables educational excellence through sophisticated technology platforms, robust security, and seamless user experiences that mirror enterprise environments while supporting diverse learning needs. The Learning Management System Selection and Configuration Framework provides systematic guidance for choosing and implementing educational platforms that support competency-based learning, portfolio development, and collaborative education while building organizational capability for ongoing platform optimization and educational technology advancement. The AI tool access and licensing management creates comprehensive multi-vendor coordination while ensuring legal compliance, cost optimization, and reliable service access that enables hands-on learning with enterprise-grade AI tools and platforms essential for practical skill development and real-world application experience. The development environment setup and collaboration infrastructure builds professional development capabilities while creating enterprise-ready environments that prepare participants for real-world AI implementation while supporting effective remote and hybrid learning through sophisticated communication and collaboration platforms. The assessment platform integration and portfolio management systems create comprehensive competency measurement while building professional showcase capabilities that demonstrate learning achievement and support career advancement through sophisticated assessment automation and portfolio development platforms. The communication and collaboration infrastructure enables global accessibility while supporting diverse learning needs through inclusive design, cultural adaptation, and accessibility compliance that ensures AI education serves diverse populations effectively regardless of location, language, or accessibility requirements. The security and privacy frameworks provide comprehensive protection while ensuring regulatory compliance and intellectual property protection through enterprise-grade security, privacy management, and digital rights protection that build trust and enable safe learning environments. The technology infrastructure established in Chapter 25 creates the technical foundation for delivering AI education that combines theoretical learning with practical application in secure, scalable, and accessible environments that prepare participants for successful AI implementation in their professional contexts while building organizational capability for sustained educational excellence. This comprehensive infrastructure approach recognizes that successful AI education depends not just on curriculum quality but on technology platforms that enable immersive learning, practical application, and professional development in environments that mirror real-world enterprise conditions while supporting diverse global participants through inclusive, secure, and scalable technology solutions. Introduction of Chapter 26. Comprehensive AI Instructor Competency. Deep technical expertise, current AI knowledge including machine learning, practical implementation experience, industry applications, and emerging technology awareness. Business integration mastery, understanding of organizational dynamics, strategic value creation, change management, and ROI measurement for practical AI education. Educational methodology excellence, adult learning theory application, technical concept translation, progressive complexity management, and interactive demonstration capabilities. Assessment and evaluation expertise, multimodal assessment design, competency measurement, constructive feedback systems, and continuous improvement methodologies. Advanced adult learning and motivation. Andragogy application, self-directed learning support, prior experience integration, problem-centered learning, and intrinsic motivation cultivation for professional development. Experiential learning frameworks, hands-on practice, real-world projects, reflection integration, and workplace knowledge transfer for practical skill development. Engagement and persistence, attention management, challenge progression, social learning integration, and obstacle management for sustained learning commitment. Professional development alignment, career relevance, goal theory application, flow state creation, and community belonging for meaningful professional growth. Workshop facilitation and group dynamics int. Reactive workshop design, session architecture, facilitation techniques, participation management, and energy optimization for dynamic learning experiences tech. Nickel business integration, bridging methodology, case study development, problem-solving workshops, and cross-functional collaboration for comprehensive understanding dive. RSE group management, inclusive facilitation, diversity management, conflict resolution, and cultural sensitivity for equitable learning environments call. Laborative learning optimization, peer learning facilitation, knowledge sharing systems, mentoring integration, and community building for enhanced learning outcomes ARS. SMENT excellence and feedback systems. Comprehensive assessment strategy, multimodal evaluation, competency measurement, portfolio assessment, and real-world application testing for authentic skill validation. Constructive feedback frameworks, timely, specific, actionable feedback systems with formative assessment integration and growth mindset development. Performance evaluation, teaching effectiveness measurement, feedback collection systems, and professional development planning for instructor improvement. Continuous learning analytics, data-driven improvement, evidence-based practice, and innovation integration for educational excellence advancement. Technology proficiency and platform management. LMS mastery, platform administration, content management, assessment integration, and analytics utilization for effective digital learning environments. AI tool expertise, practical proficiency, demonstration capabilities, troubleshooting skills, and integration knowledge across diverse AI platforms. Infrastructure management, environment configuration, monitoring systems, technical support, and security management for reliable learning technology. Innovation integration, technology tracking, pilot programs, change management, and professional development for current instruction delivery. Professional development and career excellence. Learning community leadership, professional network engagement, thought leadership development, research. Chapter 26. Facilitator training and development. Chapter Introduction, Building World-Class AI Education Faculty and Instruction Excellence. Chapter 26 establishes the comprehensive framework for developing exceptional facilitators and instructors capable of delivering the Building AI-Fluent Professionals program with excellence, expertise, and impact. This chapter provides systematic guidance for selecting, training, and developing the educational professionals who will transform the curriculum, technology infrastructure, and assessment frameworks into transformative learning experiences that create genuine AI-fluent professionals. The Facilitator Development Framework recognizes that educational excellence depends fundamentally on instructor quality, requiring professionals who combine deep AI expertise with sophisticated pedagogical skills, adult learning mastery, and the ability to bridge technical complexity with practical business application across diverse organizational contexts and learner backgrounds. This comprehensive instructor development approach operates on the principle that successful AI education requires facilitators who can navigate the unique challenges of teaching. Rapidly evolving technology while maintaining educational rigor, practical relevance, and inclusive accessibility for learners with varying technical backgrounds and professional contexts. The facilitator competency requirements span AI technical expertise, educational methodology mastery, workshop facilitation excellence, assessment and feedback proficiency, and ongoing professional development that creates sustainable instructor excellence capable of adapting to evolving AI technology and changing organizational needs. The Instructor Training and Certification Framework integrates current best practices in adult education with AI-specific teaching challenges while building organizational capability for ongoing faculty development, quality assurance, and instructional innovation that maintains program excellence over time. This chapter prepares organizations to develop and maintain exceptional AI education faculty who can deliver transformative learning experiences that create lasting professional impact while building careers as recognized experts in AI education and professional development in rapidly evolving technological and organizational environments. 26.1 AI Fluency Instructor Competency. Requirements. AI Technical Expertise and Knowledge Framework. Comprehensive AI Domain Knowledge Requirements. AI instructor competency requires sophisticated technical understanding while building teaching expertise and knowledge capability essential for AI education that requires credible technical knowledge, practical application experience, and the ability to translate complex concepts into accessible learning experiences across diverse professional contexts. AI technical foundation includes machine learning principles, deep learning architectures, natural language processing, and computer vision fundamentals that provide comprehensive AI knowledge while building technical thinking and expertise capability. Foundation should be current while remaining teachable and focused on practical understanding rather than academic complexity or artificial technical sophistication. Practical implementation experience includes hands-on AI development, production system deployment, business application creation, and real-world problem-solving that provide credible teaching authority while building implementation thinking and practical capability. Experience should be substantial while remaining relevant and focused on genuine expertise rather than implementation complexity or artificial practical sophistication. Industry application knowledge includes sector-specific AI use cases, business value creation, organizational implementation, and strategic application that provide business context while building application thinking and industry capability. Knowledge should be comprehensive while remaining practical. and focused on business relevance rather than industry complexity or artificial application sophistication. Technology ecosystem understanding includes AI tools, platforms, frameworks, and vendor landscape that provide comprehensive ecosystem knowledge while building ecosystem thinking and technology capability. Understanding should be current while remaining useful and focused on practical selection rather than ecosystem complexity or artificial technology sophistication. Emerging technology awareness includes AI advancement trends, breakthrough developments, research directions, and future implications that provide forward-looking perspective while building awareness thinking and trend capability. Awareness should be informed while remaining grounded and focused on practical implications rather than trend complexity or artificial awareness sophistication. Business integration and strategic application knowledge. Business integration knowledge creates practical AI education while building business expertise and integration capability essential for AI instruction that requires understanding of business context, organizational dynamics, and strategic value creation through AI implementation and adoption. Business process understanding includes organizational workflows, efficiency opportunities, value creation potential, and improvement identification that provide business context while building process thinking and business capability. Understanding should be comprehensive while remaining practical and focused on genuine improvement rather than process complexity or artificial business sophistication. Strategic thinking includes competitive advantage, market positioning, business model innovation, and strategic value creation that provide strategic context while building strategy thinking and positioning capability. Thinking should be sophisticated while remaining actionable and focused on genuine strategy rather than strategic complexity or artificial positioning sophistication. Organizational change includes culture transformation, adoption psychology, resistance management, and change leadership that provide change context while building change thinking and transformation capability. Change should be systematic while remaining human-centered and focused on genuine transformation rather than change complexity or artificial transformation sophistication. Return on investment includes value measurement, cost-benefit analysis, business case development, and impact quantification that provide financial context while building ROI thinking and measurement capability. Investment should be realistic while remaining compelling and focused on genuine value rather than ROI complexity or artificial measurement sophistication. Risk management includes implementation risks, ethical considerations, compliance requirements, and mitigation strategies that provide risk context while building risk thinking and management capability. Management should be prudent while remaining innovative and focused on appropriate risk, rather than management complexity or artificial risk sophistication. Educational methodology and pedagogical excellence. Adult learning theory and application mastery. Adult learning mastery creates effective AI education while building pedagogical expertise and teaching capability essential for AI instruction that requires sophisticated understanding of how adults learn technical concepts, develop practical skills, and apply knowledge in professional contexts. Adult learning principles include motivation factors, experience integration, relevance emphasis, and self-direction facilitation that guide effective instruction while building learning thinking and educational capability. Principles should be evidence-based while remaining practical and focused on learning effectiveness rather than pedagogical complexity or artificial educational sophistication. Experiential learning includes hands-on practice, real-world application, project-based learning, and practical experience that enable effective skill development while building experiential thinking and application capability. Learning should be engaging while remaining substantive and focused on skill transfer rather than activity complexity or artificial experiential sophistication. Cognitive load management includes information processing, complexity sequencing, attention optimization, and learning efficiency that optimize learning effectiveness while building cognitive thinking and management capability. Management should be systematic while remaining natural and focused on learning optimization rather than cognitive complexity or artificial management sophistication. Learning style accommodation includes visual learning, auditory processing, kinesthetic engagement, and preference diversity that serve different learning approaches while building accommodation thinking and inclusion capability. Accommodation should be comprehensive while remaining practical and focused on learning effectiveness rather than style complexity or artificial accommodation sophistication. Motivation and engagement includes intrinsic motivation, goal alignment, interest cultivation, and sustained engagement that maintain learning commitment while building motivation thinking and engagement capability. Motivation should be authentic while remaining systematic and focused on genuine interest rather than motivation manipulation or artificial engagement tactics. Technical concept communication excellence translation and technical communication creates accessible learning while building translation expertise and communication capability essential for AI instruction that requires converting complex technical concepts relevant into understandable and applicable knowledge for diverse professional audiences. Concept simplification includes complexity reduction, analogical explanation, metaphor utilization, and accessible presentation that make technical concepts understandable while building simplification thinking and communication capability. Simplification should be accurate while remaining comprehensible and focused on genuine understanding rather than oversimplification or artificial accessibility claims. Progressive complexity includes scaffolded learning, incremental difficulty, skill building, and knowledge progression that enable systematic skill development while building progression thinking and development capability. Complexity should be logical while remaining achievable and focused on competency building rather than progression complexity or artificial development sophistication. Business relevance includes practical application, value demonstration, use case illustration, and context provision that connect technical concepts to business value while building relevance thinking and application capability. Relevance should be authentic while remaining compelling and focused on genuine application rather than relevance complexity or artificial business sophistication. Interactive demonstration includes live coding, real-time examples, hands-on exploration, and practical illustration that enable engaging technical instruction while building demonstration thinking and interaction capability. Demonstration should be dynamic while remaining educational and focused on learning engagement rather than demonstration complexity or artificial interaction sophistication. Assessment integration includes concept checking, understanding verification, skill validation, and knowledge confirmation that ensure learning achievement while building assessment thinking and validation capability. Integration should be seamless while remaining rigorous and focused on genuine understanding rather than assessment complexity or artificial validation sophistication. (26.2) Adult Learning Principles for AI. Education. Comprehensive adult learning framework for technical education. Andragogy professionals and self-directed learning for AI. Adult learning principles create effective AI education while building educational expertise and learning capability essential for AI instruction that serves adult professionals with diverse backgrounds, varying experience levels, and specific professional development goals through evidence-based adult education methodologies. Self-directed learning includes autonomy support, goal setting, learning planning, and self-regulation that enable adult learner independence while building autonomy thinking and direction capability. Learning should be empowering while remaining guided and focused on learner empowerment rather than direction complexity or artificial autonomy sophistication. Prior experience integration includes knowledge building, experience validation, expertise leverage, and wisdom application that utilize adult learner backgrounds while building integration thinking and experience capability. Integration should be respectful while remaining educational and focused on experience value rather than integration complexity or artificial experience sophistication. Problem-centered learning includes real-world challenges, practical problems, immediate application, and relevant solutions that engage adult learners through meaningful challenges while building problem thinking and solution capability. Learning should be applicable while remaining educational and focused on genuine problems rather than problem complexity or artificial solution sophistication. Readiness to learn includes timing optimization, need alignment, goal connection, and motivation enhancement that align learning with adult readiness while building readiness thinking and timing capability. Readiness should be authentic while remaining systematic and focused on learner preparedness rather than readiness complexity or artificial timing sophistication. Internal motivation includes intrinsic drive, personal goal alignment, value connection, and meaningful engagement that sustain adult learning commitment while building motivation thinking and engagement capability. Motivation should be genuine while remaining purposeful and focused on authentic drive rather than motivation manipulation or artificial engagement tactics. Experiential learning and practical application. Experiential learning creates meaningful AI education while building experience expertise and application capability essential for AI instruction that requires hands-on practice, real-world application, and immediate relevance to professional contexts and organizational challenges. Learning cycle includes concrete experience, reflective observation, abstract conceptualization, and active experimentation that create comprehensive learning while building cycle thinking and learning capability. Cycle should be complete while remaining natural and focused on learning effectiveness rather than cycle complexity or artificial learning sophistication. Hands-on practice includes tool usage, project development, skill application, and practical experience that enable skill development while building practice thinking and application capability. Practice should be substantial while remaining guided and focused on skill development rather than practice complexity or artificial application sophistication. Real-world projects include authentic challenges, business problems, organizational needs, and practical solutions that provide meaningful application while building project thinking and solution capability. Projects should be relevant while remaining educational and focused on genuine application. Rather than project complexity or artificial solution sophistication. Reflection integration includes experience analysis, learning extraction, insight development, and wisdom creation that deepen learning understanding while building reflection thinking and insight capability. Integration should be thoughtful while remaining practical and focused on learning enhancement rather than reflection complexity or artificial insight sophistication. Knowledge transfer includes workplace application, skill deployment, concept utilization, and value creation that enable professional application while building transfer thinking and application capability. Transfer should be seamless while remaining effective and focused on workplace value rather than transfer complexity or artificial application sophistication. Motivation theory and engagement strategies. Intrinsic motivation and professional development alignment. Motivation theory creates sustained engagement while building motivation expertise and engagement capability essential for AI instruction that requires understanding of what drives adult professional learning and how to maintain engagement throughout intensive skill development programs. Self-determination theory includes autonomy support, competence building, relatedness fostering, and intrinsic motivation cultivation that creates sustainable engagement while building determination, thinking, and motivation capability. Theory should be applied while remaining authentic and focused on genuine motivation rather than theory complexity or artificial motivation sophistication. Goal theory includes objective setting, achievement planning, progress tracking, and accomplishment recognition that guide learning motivation while building goal thinking and achievement capability. Theory should be practical while remaining motivating and focused on genuine achievement rather than goal complexity or artificial accomplishment sophistication. Flow state creation includes challenge balancing, skill matching, focus facilitation, and engagement optimization that create optimal learning experiences while building flow thinking and experience capability. Creation should be natural while remaining intentional and focused on learning optimization rather than flow complexity or artificial experience sophistication. Professional relevance includes career connection, advancement opportunity, skill development, and value creation that align learning with professional goals while building relevance thinking and career capability. Relevance should be authentic while remaining compelling and focused on genuine career value rather than relevance complexity or artificial career sophistication. Community belonging includes peer connection, network building, collaboration facilitation, and relationship development that create learning communities while building community thinking and belonging capability. Belonging should be organic while remaining inclusive and focused on genuine community rather than belonging complexity or artificial community sophistication. Engagement maintenance and learning persistence. Engagement maintenance creates sustained learning while building engagement expertise and persistence capability essential for AI instruction that requires maintaining learner motivation, overcoming learning challenges, and ensuring successful program completion across diverse participant backgrounds and circumstances. Attention management includes focus optimization, distraction reduction, engagement enhancement, and concentration facilitation that maintain learning attention while building attention thinking and management capability. Management should be systematic while remaining natural and focused on genuine attention rather than management complexity or artificial attention sophistication. Challenge progression includes difficulty optimization, skill building, confidence development, and achievement progression that maintain optimal challenge levels while building progression thinking and development capability. Progression should be systematic while remaining encouraging and focused on learner success rather than progression complexity development sophistication or artificial. Feedback systems include progress communication, improvement guidance, recognition provision, and support delivery that maintain learning motivation while building feedback thinking and support capability. Systems should be responsive while remaining constructive and focused on learner improvement rather than feedback complexity or artificial support sophistication. Social learning includes peer interaction, collaborative projects, knowledge sharing, and community engagement that enhance learning through social connection while building social thinking and collaboration capability. Learning should be natural while remaining structured and focused on learning enhancement rather than social complexity or artificial collaboration sophistication. Obstacle management includes challenge identification, barrier removal, difficulty addressing, and problem solving that maintain learning progress while building obstacle thinking and solution capability. Management should be proactive while remaining supportive and focused on learner success rather than obstacle complexity or artificial solution sophistication. 26.3 Workshop Facilitation Techniques for Technical and Business Content Integration. Advanced facilitation methodology for AI education. Interactive workshop design and delivery excellence. Workshop facilitation creates engaging learning while building facilitation expertise and delivery capability essential for AI. Instruction that requires dynamic interaction, practical application, and seamless integration of technical concepts with business applications through sophisticated workshop design and facilitation methodologies. Workshop architecture includes session design, content organization, activity sequencing, and engagement planning that create effective workshops while building architecture thinking and design capability. Architecture should be logical while remaining flexible and focused on learning effectiveness rather than design complexity or artificial workshop sophistication. Facilitation techniques include group management, discussion leadership, activity coordination, and engagement facilitation that enable effective workshop delivery while building facilitation thinking and leadership capability. Techniques should be natural while remaining purposeful and focused on group effectiveness rather than facilitation complexity or artificial leadership sophistication. Interactive learning includes hands-on activities, group exercises, collaborative projects, and practical application that engage participants actively while building interaction thinking and activity capability. Learning should be engaging while remaining substantive and focused on skill development rather than interaction complexity or artificial activity sophistication. Participation management includes engagement encouragement, contribution facilitation, inclusion assurance, and collaboration optimization that ensure effective group participation while building participation thinking and inclusion capability. Management should be inclusive while remaining productive and focused on group contribution rather than participation complexity or artificial inclusion sophistication. Energy management includes momentum maintenance, attention optimization, engagement sustaining, and vitality preservation that maintain workshop effectiveness while building energy thinking and sustainability capability. Management should be dynamic while remaining authentic and focused on group energy rather than management complexity or artificial sustainability sophistication. Technical concept integration with business applications. Concept integration creates practical learning while building integration expertise and application capability essential for AI instruction that requires seamless connection between technical AI concepts and business applications, ensuring learners understand both technical implementation and business value. Bridging methodology includes concept connection, application demonstration, value illustration, and relevance establishment that connect technical and business domains while building bridging thinking and connection capability. Methodology should be systematic while remaining natural and focused on genuine connection rather than bridging complexity or artificial connection sophistication. Case study development includes real-world examples, business scenarios, implementation stories, and success illustrations that provide practical context while building case thinking and development capability. Development should be authentic while remaining educational and focused on learning value rather than case complexity or artificial development sophistication. Problem-solving workshops include challenge identification, solution development, implementation planning, and value demonstration that integrate technical and business thinking while building problem thinking and solution capability. Workshops should be practical while remaining educational and focused on genuine solutions rather than workshop complexity or artificial solution sophistication. Business value demonstration includes ROI calculation, benefit identification, impact measurement, and value articulation that connect technical implementation to business outcomes while building value thinking and demonstration capability. Demonstration should be compelling while remaining accurate and focused on genuine value rather than demonstration complexity or artificial value sophistication. Cross-functional collaboration includes team formation, perspective integration, knowledge sharing, and collaborative problem-solving that bridge technical and business expertise while building collaboration thinking and integration capability. Collaboration should be productive while remaining inclusive and focused on knowledge integration rather than collaboration complexity or artificial integration sophistication. Group dynamics and collaborative learning facilitation. Diverse group management and inclusion strategies. Group management creates inclusive learning while building management expertise and inclusion capability essential for AI instruction that serves diverse participants with varying technical backgrounds, professional roles, and organizational contexts through sophisticated group dynamics understanding and inclusive facilitation approaches. Group formation includes team building, relationship development, trust creation, and collaboration establishment that create effective learning groups while building formation thinking and team capability. Formation should be intentional while remaining organic and focused on group effectiveness rather than complexity or artificial formation team sophistication. Diversity management includes background accommodation, perspective integration, experience leveraging, and inclusion facilitation that utilize group diversity effectively while building diversity thinking and management capability. Management should be respectful while remaining productive and focused on diversity value rather than management complexity or artificial inclusion sophistication. Conflict resolution includes disagreement management, tension addressing, resolution facilitation, and harmony restoration that maintain group effectiveness while building resolution thinking and mediation capability. Resolution should be fair while remaining efficient and focused on group success rather than resolution complexity or artificial mediation sophistication. Participation equity includes contribution encouragement, voice facilitation, engagement assurance, and inclusion optimization that ensure equitable participation while building equity thinking and facilitation capability. Equity should be genuine while remaining natural and focused on authentic participation rather than equity complexity or artificial facilitation sophistication. Cultural sensitivity includes awareness demonstration, respect maintenance, accommodation provision, and inclusion facilitation that serve diverse cultural backgrounds while building sensitivity thinking and cultural capability. Sensitivity should be authentic while remaining educational and focused on genuine respect rather than sensitivity complexity or artificial cultural sophistication. Collaborative learning, sharing, optimization, and knowledge. Collaborative learning creates shared knowledge while building collaboration expertise and sharing capability essential for AI instruction that leverages collective learning, peer teaching, and knowledge exchange to enhance individual learning and create learning communities. Peer learning includes knowledge exchange, experience sharing, mutual teaching, and collaborative development that enhance learning through peer interaction while building peer thinking and learning capability. Learning should be structured, while remaining natural and focused on knowledge enhancement rather than peer complexity or artificial learning sophistication. Knowledge sharing includes expertise exchange, experience documentation, wisdom preservation, and information distribution that create collective knowledge while building sharing thinking and knowledge capability. Sharing should be generous while remaining organized and focused on knowledge value rather than sharing complexity or artificial knowledge sophistication. Collaborative projects includes team formation, joint problem solving, shared creation, and collective achievement that enable collaborative learning while building project thinking and collaboration capability. Projects should be meaningful while remaining manageable and focused on learning achievement rather than project complexity or artificial collaboration sophistication. Mentoring facilitation includes relationship formation, guidance provision, knowledge transfer, and development support that enable peer mentoring while building mentoring thinking and facilitation capability. Facilitation should be supportive while remaining structured and focused on individual development rather than mentoring complexity or artificial facilitation sophistication. Community building includes network formation, relationship development, ongoing connection, and sustained engagement that create learning communities while building community thinking and relationship capability. Building should be organic while remaining intentional and focused on genuine community rather than building complexity or artificial relationship sophistication. 26 point for assessment and feedback skills 4. Continuous improvement. Comprehensive assessment design and implementation. Multimodal assessment strategy development. Assessment design creates effective evaluation while building assessment expertise and evaluation capability essential for AI instruction that requires diverse assessment methods, authentic competency measurement, and meaningful feedback that supports continued learning and professional development. Assessment strategy includes methodology selection, approach integration, validity assurance, and reliability establishment that create comprehensive evaluation while building strategy thinking and assessment capability. Strategy should be systematic while remaining fair and focused on genuine competency rather than assessment complexity or artificial evaluation sophistication. Competency measurement includes skill assessment, knowledge evaluation, application testing, and performance verification that measure learning achievement while building measurement thinking and competency capability. Measurement should be accurate while remaining practical and focused on genuine competency rather than measurement complexity or artificial competency sophistication. Portfolio assessment includes work collection, quality evaluation, reflection integration, and achievement demonstration that showcase learning progress while building portfolio thinking and evaluation capability. Assessment should be comprehensive while remaining manageable and focused on competency demonstration rather than portfolio complexity or artificial evaluation sophistication. Peer assessment includes collaborative evaluation, feedback exchange, quality assurance, and learning enhancement that leverage peer learning while building peer thinking and evaluation capability. Assessment should be structured while remaining authentic and focused on learning improvement rather than peer complexity or artificial evaluation sophistication. Real-world application includes practical testing, workplace simulation, authentic challenges, and performance evaluation that assess practical competency while building application thinking and testing capability. Application should be realistic while remaining fair and focused on genuine capability rather than application complexity or artificial testing sophistication. Constructive feedback and learning support systems. Feedback systems create learning enhancement while building feedback expertise and support capability essential for AI instruction that requires timely, specific, and actionable feedback that guides improvement while maintaining learner motivation and confidence. Feedback principles include specificity provision, timeliness assurance, actionability emphasis, and constructiveness maintenance that create effective feedback while building feedback thinking and communication capability. Principles should be evidence-based while remaining practical and focused on learning improvement rather than feedback complexity or artificial communication sophistication. Formative assessment includes ongoing evaluation, progress monitoring, adjustment guidance, and improvement support that enhance learning during instruction while building formative thinking and support capability. Assessment should be continuous while remaining unobtrusive and focused on learning optimization rather than assessment complexity or artificial support sophistication. Summative evaluation includes achievement measurement, competency verification, performance assessment, and accomplishment recognition that validate learning outcomes while building evaluation thinking and measurement capability. Evaluation should be comprehensive while remaining fair and focused on genuine achievement rather than evaluation complexity or artificial measurement sophistication. Growth mindset development includes improvement focus, challenge encouragement, effort recognition, and resilience. Building that foster continued learning while building mindset thinking and development capability. Development should be authentic while remaining supportive and focused on genuine growth rather than mindset artificial development sophistication. Complexity or learning analytics includes data collection, pattern analysis, insight generation, and improvement guidance that optimize learning effectiveness while building analytics thinking and optimization capability. Analytics should be meaningful while remaining actionable and focused on learning enhancement rather than analytics complexity or artificial optimization sophistication. Performance evaluation and professional development. Instructor performance assessment and improvement. Performance evaluation creates teaching excellence while building evaluation expertise and improvement capability essential for AI instruction quality assurance that requires systematic instructor assessment, professional development planning, and continuous improvement through evidence-based evaluation and development systems. Teaching effectiveness includes learning outcome achievement, student satisfaction, engagement measurement, and competency development that assess instructor performance while building effectiveness thinking and evaluation capability. Effectiveness should be comprehensive while remaining fair and focused on genuine teaching quality rather than effectiveness complexity or artificial evaluation sophistication. Feedback collection includes student evaluation, peer observation, supervisor assessment, and self-reflection that provide comprehensive performance insight while building collection thinking and feedback capability. Collection should be systematic while remaining supportive and focused on improvement guidance rather than collection complexity or artificial feedback sophistication. Professional development includes skill enhancement, knowledge updating, methodology improvement, and capability advancement that improve instructor performance while building development thinking and improvement capability. Development should be ongoing while remaining relevant and focused on teaching enhancement rather than development complexity sophistication or artificial improvement. Peer collaboration includes knowledge sharing, best practice exchange, collaborative improvement, and mutual support that enhance instructor effectiveness through collegial interaction while building collaboration thinking and peer capability. Collaboration should be generous while remaining professional and focused on teaching improvement rather than collaboration complexity or artificial peer sophistication. Innovation integration includes new methodology adoption, technology utilization, approach experimentation, and practice advancement that keep instruction current while building innovation thinking and integration capability. Integration should be thoughtful while remaining practical and focused on teaching effectiveness rather than innovation complexity or artificial integration sophistication. Continuous learning excellence development and teaching. Continuous development creates sustained excellence while building development expertise and excellence capability essential for AI instruction that requires ongoing instructor growth, professional advancement, and teaching innovation to maintain program quality and educational effectiveness over time. Reflective practice includes teaching analysis, outcome evaluation, approach assessment, and improvement identification that enable instructor growth while building reflection thinking and practice capability. Practice should be honest while remaining constructive and focused on teaching improvement rather than reflection complexity or artificial practice sophistication. Professional community includes educator networks, expert relationships, peer connections, and knowledge sharing that support instructor development while building community thinking and network capability. Community should be authentic while remaining professional and focused on teaching excellence rather than community complexity or artificial network sophistication. Research integration includes educational research, best practice adoption, evidence-based teaching, and methodology advancement that improve instruction quality while building. Research thinking and integration capability. Integration should be practical while remaining evidence-based and focused on teaching effectiveness rather than research complexity or artificial integration sophistication. Technology advancement includes tool adoption, platform utilization, innovation integration, and capability enhancement that keep instruction current while building technology thinking and advancement capability. Advancement should be purposeful while remaining educationally focused and oriented toward teaching improvement rather than technology complexity or artificial advancement sophistication. Leadership development includes mentoring capability, program leadership, educational innovation, and professional influence that advance instructor careers while building leadership thinking and influence capability. Development should be earned while remaining service-oriented and focused on educational advancement rather than leadership complexity or artificial influence sophistication. 26.5 Technology Proficiency Requirements for effective AI training delivery. Comprehensive technical platform mastery. Learning management administration system expertise and LMS mastery creates effective platform utilization while building technical expertise and administration capability essential for AI instruction that requires sophisticated learning. Platform management, content delivery optimization, and student experience enhancement through professional LMS administration and utilization. Platform administration includes user management, content organization, system configuration, and performance optimization that enable effective LMS utilization while building administration thinking and platform capability. Administration should be comprehensive while remaining user-focused and oriented toward learning effectiveness rather than administration complexity, platform sophistication, or artificial. Content management includes material organization, resource integration, multimedia incorporation, and delivery optimization that create effective content experiences while building content thinking and management capability. Management should be systematic while remaining learner-centered and focused on content accessibility rather than management complexity or artificial content sophistication. Assessment integration includes evaluation design, grading automation, feedback provision, and analytics utilization that enable effective assessment through platform capabilities while building assessment thinking and integration capability. Integration should be seamless while remaining educationally sound and focused on learning evaluation rather than integration complexity or artificial assessment sophistication. Student engagement includes participation facilitation, interaction enhancement, collaboration, and community building that optimize learner experience while building engagement thinking and facilitation capability. Engagement should be meaningful while remaining natural and focused on learning enhancement rather than engagement complexity or artificial facilitation sophistication. Analytics utilization includes data interpretation, insight generation, performance tracking, and improvement identification that optimize instruction through platform analytics while building analytics thinking and utilization capability. Utilization should be strategic while remaining privacy-respecting and focused on learning improvement rather than analytics complexity or artificial utilization sophistication. AI tool proficiency and demonstration capabilities. AI tool mastery creates credible instruction while building tool expertise and demonstration capability essential for AI instruction that requires practical AI tool usage, effective demonstration techniques, and troubleshooting capability across diverse AI platforms and applications. Tool proficiency includes platform navigation, feature utilization, advanced functionality, and optimization techniques that enable effective AI tool instruction while building proficiency thinking and tool capability. Proficiency should be comprehensive while remaining teachable and focused on practical usage rather than proficiency complexity or artificial tool sophistication. Demonstration techniques include live coding, real-time examples, interactive exploration, and hands-on guidance that enable effective AI tool instruction while building demonstration thinking and teaching capability. Techniques should be engaging while remaining educational and focused on learning than effectiveness rather demonstration complexity or artificial teaching sophistication. Troubleshooting skills includes problem identification, error resolution, alternative approaches, and solution development that handle AI tool challenges while building troubleshooting thinking and problem capability. Skills should be systematic while remaining practical and focused on problem resolution rather than troubleshooting complexity or artificial problem sophistication. Integration knowledge includes tool combination, workflow creation, platform coordination, and ecosystem utilization that enable comprehensive AI instruction while building integration thinking and ecosystem capability. Knowledge should be practical while remaining comprehensive and focused on effective integration rather than knowledge complexity or artificial ecosystem sophistication. Version management includes update tracking, feature evolution, compatibility maintenance, and migration planning that keep instruction current while building version thinking and management capability. Management should be proactive while remaining stable and focused on instruction continuity rather than management complexity or artificial version sophistication. Technical infrastructure management and support. Development environment setup and maintenance. Environment management creates reliable instruction while building technical expertise and maintenance capability essential for AI instruction that requires consistent development environments, reliable infrastructure, and technical support capability for diverse learning scenarios and technical challenges. Environment configuration includes tool installation, platform setup, integration coordination, and optimization implementation that create effective learning environments while building configuration thinking and technical capability. Configuration should be reliable while remaining maintainable and focused on learning effectiveness rather than configuration complexity or artificial technical sophistication. Infrastructure monitoring includes performance tracking, availability assurance, issue detection, and maintenance scheduling that ensure reliable learning environments while building monitoring thinking and infrastructure capability. Monitoring should be proactive while remaining efficient and focused on environment reliability rather than monitoring complexity or artificial infrastructure sophistication. Technical support includes problem resolution, user assistance, guidance provision, and issue escalation that support learning continuity while building support thinking and assistance capability. Support should be responsive while remaining educational and focused on learner success rather than support complexity or artificial assistance sophistication. Backup and recovery includes data protection, system restoration, continuity assurance, and disaster recovery that protect learning environments while building backup thinking and recovery capability. Backup should be comprehensive while remaining practical and focused on environment protection rather than backup complexity or artificial recovery sophistication. Security management includes access control, data protection, threat prevention, and compliance assurance that protect learning environments while building security thinking and protection capability. Management should be robust while remaining user-friendly and focused on genuine security rather than management complexity, protection sophistication, or artificial. Innovation integration and technology advancement. Innovation integration creates current instruction while building innovation expertise and advancement capability essential for AI instruction that requires staying current with rapidly evolving AI technology while maintaining instructional quality and educational effectiveness. Technology tracking includes advancement monitoring, trend identification, tool evaluation, and integration assessment that keep instruction current while building tracking thinking and evaluation capability. Tracking should be systematic while remaining focused and oriented toward educational relevance, rather than tracking complexity or artificial evaluation sophistication. Pilot programs includes experimental integration, trial implementation, effectiveness assessment, and adoption decision that enable careful technology adoption while building pilot thinking and experimentation capability. Programs should be systematic while remaining cautious and focused on educational improvement rather than pilot complexity or artificial experimentation sophistication. Change management includes transition planning, adaptation support, training provision, and adoption facilitation that enable smooth technology integration while building change thinking and management capability. Management should be supportive while remaining systematic and focused on successful adoption rather than change complexity or artificial management sophistication. Professional development includes skill updating, knowledge advancement, capability enhancement, and expertise maintenance that keep instructors current while building development thinking and advancement capability. Development should be ongoing while remaining relevant and focused on teaching effectiveness rather than development complexity or artificial advancement sophistication. Community engagement includes expert networks, professional associations, technology forums, and knowledge sharing that support instructor advancement while building community thinking and engagement capability. Engagement should be active while remaining purposeful and focused on professional growth rather than engagement complexity or artificial community sophistication. 26.6 Ongoing professional development for AI education excellence. Continuous learning and expertise advancement. Professional learning community participation and leadership. Professional community engagement creates sustained excellence while building community expertise and leadership capability essential for AI instruction that requires ongoing professional development, peer collaboration, and thought leadership in rapidly evolving educational and technological environments. Community participation includes network engagement, knowledge sharing, collaboration facilitation, and mutual support that enhance professional capability while building participation thinking and community capability. Participation should be active while remaining generous and focused on collective advancement rather than participation complexity or artificial community sophistication. Thought leadership includes expertise sharing, innovation communication, best practice development, and professional influence that advance the field while building leadership thinking and influence capability. Leadership should be earned while remaining collaborative and focused on field advancement rather than leadership complexity or artificial influence sophistication. Research contribution includes study participation, knowledge creation, finding dissemination, and evidence development that advance educational understanding while building research thinking and contribution capability. Contribution should be meaningful while remaining practical and focused on educational improvement rather than research complexity or artificial contribution sophistication. Mentoring provision includes guidance offering, experience sharing, development support, and wisdom transfer that support colleague advancement while building mentoring thinking and support capability. Provision should be generous while remaining purposeful and focused on professional development rather than mentoring complexity or artificial support sophistication. Standard development includes quality criteria, best practice definition, assessment framework, and excellence promotion that advance professional standards while building standard thinking and development capability. Development should be rigorous while remaining achievable and focused on professional excellence rather than standard complexity or artificial development sophistication. Research integration and evidence-based practice. Research integration creates evidence-based instruction while building research expertise and application capability essential for AI instruction that requires scientific understanding of learning effectiveness, evidence-based practice adoption, and continuous improvement through systematic research application and evaluation. Educational research includes study review, finding analysis, application assessment, and practice integration that inform instruction improvement while building research thinking and analysis capability. Research should be relevant while remaining practical and focused on teaching effectiveness rather than research complexity or artificial analysis sophistication. Action research includes classroom investigation, practice evaluation, improvement experimentation, and outcome measurement that enable instructor-led improvement while building action thinking and research capability. Research should be systematic while remaining practical and focused on teaching improvement rather than action complexity or artificial research sophistication. Data-driven improvement includes analytics utilization, performance measurement, outcome tracking, and evidence-based decision-making that optimize instruction through data analysis while building data thinking and improvement capability. Improvement should be systematic while remaining learner-centered and focused on educational effectiveness rather than data complexity or artificial improvement sophistication. Best practice adoption includes methodology evaluation, approach testing, effectiveness assessment, and practice integration that improve instruction through proven methods while building adoption thinking and practice capability. Adoption should be thoughtful while remaining innovative and focused on teaching enhancement rather than adoption complexity or artificial practice sophistication. Innovation experimentation includes new approach testing, methodology development, practice innovation, and effectiveness evaluation that advance instruction through systematic innovation while building experimentation thinking and innovation capability. Experimentation should be careful while remaining creative and focused on educational advancement rather than experimentation complexity or artificial innovation sophistication. Career development and professional advancement. AI education leadership and career pathways. Career development creates professional advancement while building leadership expertise and advancement capability essential for AI education professionals who seek to advance their careers, expand their influence, and contribute to the development of AI education as a professional field. Leadership development includes authority building, influence expansion, responsibility growth, and impact enhancement that advance professional careers while building leadership thinking and development capability. Development should be earned while remaining service-oriented and focused on professional contribution rather than leadership complexity or artificial development sophistication. Specialization development includes expertise deepening, niche identification, authority building, and recognition achievement that create professional distinction while building specialization thinking and expertise capability. Development should be authentic while remaining valuable and focused on genuine expertise rather than specialization complexity or artificial expertise sophistication. Network expansion includes relationship building, partnership development, collaboration facilitation, and professional connection that create career opportunities while building network thinking and relationship capability. Expansion should be authentic while remaining strategic and focused on mutual benefit rather than network complexity or artificial relationship sophistication. Industry engagement includes sector involvement, professional participation, thought contribution, and leadership provision that advance both careers and industries while building engagement thinking and contribution capability. Engagement should be meaningful while remaining professional and focused on industry advancement complexity or rather artificial sophistication. Recognition achievement includes an engagement contribution, accomplishment demonstration, expertise validation, authority establishment, and influence development that create professional recognition while building recognition thinking and achievement capability. Achievement should be earned while remaining humble and focused on professional contribution. Rather than recognition achievement sophistication. Complexity or artificial. Innovation and thought leadership in AI education. Innovation leadership creates field advancement while building innovation expertise and leadership capability essential for AI education professionals who seek to advance the field, contribute to educational innovation, and influence the future of AI education and professional development. Educational innovation includes methodology development, approach creation, practice advancement, and effectiveness demonstration that advance AI education while building innovation thinking and development capability. Innovation should be meaningful while remaining practical and focused on educational improvement rather than innovation complexity or artificial development sophistication. Content creation includes knowledge sharing, expertise communication, insight provision, and wisdom dissemination that contribute to professional knowledge while building creation thinking and communication capability. Creation should be valuable while remaining accessible and focused on knowledge contribution rather than creation complexity or artificial communication sophistication. Speaking engagement includes presentation delivery, workshop facilitation, conference participation, and thought sharing that spread professional knowledge while building speaking thinking and engagement capability. Engagement should be influential while remaining authentic and focused on knowledge sharing rather than speaking complexity or artificial engagement sophistication. Professional writing includes article creation, research publication, book development, and knowledge documentation that preserve and share professional knowledge while building writing thinking and documentation capability. Writing should be insightful while remaining accessible and focused on knowledge preservation rather than writing complexity or artificial documentation sophistication. Consulting provision includes expertise application, problem solving, guidance provision, and value creation that apply professional knowledge while building consulting thinking and application capability. Provision should be valuable while remaining ethical and focused on client benefit rather than consulting complexity or artificial application sophistication. Chapter 26 Conclusion: Facilitator Excellence as the Foundation for AI Education Impact. Chapter 26 establishes the comprehensive framework for developing exceptional facilitators and instructors who can deliver transformative AI education experiences that create genuine AI-fluent professionals through sophisticated teaching expertise, deep AI knowledge, and exceptional educational capability. The AI fluency instructor competency requirements create rigorous professional standards while building comprehensive technical and pedagogical expertise that enables credible, effective AI instruction across diverse organizational contexts. And learner backgrounds through systematic competency development and validation. The adult learning principles and motivation frameworks build sophisticated understanding of how professionals learn complex technical concepts while creating engagement strategies and learning persistence that ensure successful program completion and genuine skill development through evidence-based educational approaches. The workshop facilitation techniques and group dynamics management create dynamic learning experiences while building facilitation expertise that enables effective integration of technical concepts with business applications through interactive, collaborative methodologies and inclusive facilitation. The assessment and feedback systems build comprehensive evaluation capability while creating continuous improvement frameworks that ensure genuine competency development and sustained learning enhancement through sophisticated assessment design and constructive feedback provision. The technology proficiency requirements create professional platform management while building technical expertise that enables effective AI education delivery through reliable technology infrastructure, demonstration capability, and technical support across diverse learning environments. The ongoing professional development frameworks create sustained instructor excellence while building career advancement capability that ensures AI education quality. Improvement over time through continuous learning, research integration, and professional community engagement. The comprehensive facilitator development established in Chapter 26 transforms AI education from content delivery into transformative professional development through exceptional instructor capability, ensuring that curriculum excellence translates into learning impact through world-class teaching and facilitation expertise. This facilitator development approach recognizes that educational excellence depends fundamentally on instructor quality, requiring professionals who combine deep AI expertise with sophisticated pedagogical skills while maintaining currency with rapidly evolving technology and changing organizational needs in increasingly AI-driven professional environments. Introduction of Chapter 27. Comprehensive quality measurement. Multidimensional quality metrics, learning outcomes, participant satisfaction, instructor effectiveness, and organizational impact measurement for holistic program assessment. Real-time monitoring systems, dashboard development, analytics integration, alert mechanisms, and reporting systems for continuous program oversight and proactive issue management. Performance benchmarking, industry standard identification, competitive analysis, excellence targeting, and gap identification for continuous program positioning and improvement. Internal quality standards, quality criteria development, certification frameworks, accreditation preparation, and audit procedures for credible program validation. Systematic feedback integration. Multi-channel feedback collection, surveys, interviews, focus groups, and stakeholder input integration for comprehensive program assessment and improvement guidance. Advanced feedback analysis, priority identification, root cause analysis, response planning, and communication strategies for systematic improvement implementation. Rapid response cycles, agile methodology implementation, issue triage, quick wins identification, and pilot testing for responsive program enhancement. Strategic enhancement planning, long-term improvement roadmaps, innovation integration, capability development, and excellence evolution for sustained program advancement. Dynamic curriculum management (SYST). Ematic content updates, review methodology, currency tracking, content lifecycle management, and version control for maintaining program relevance and accuracy. Jing technology integration, technology scouting, integration strategy, pilot programs, and impact measurement for strategic technology adoption and curriculum advancement. REIS. Arch-driven improvement, educational research integration, evidence evaluation, best practice identification, and innovation pipeline development for continuous program enhancement. FUTU. Reoriented development, trend analysis, scenario planning, technology forecasting, and strategic adaptation for competitive program positioning and market leadership. Ledge Management Excellence Inst. Institutional memory preservation, knowledge architecture, documentation standards, tacit knowledge capture, and access management for comprehensive organizational learning. best practice documentation, practice identification, documentation methodology, quality assessment, and sharing mechanisms for excellence dissemination and adoption. Cross-program learning, experience synthesis, pattern recognition, adaptation guidance, and community building for collective advancement and knowledge transfer. Learning culture development, continuous learning mindset, knowledge sharing behaviors, reflection practices, and innovation support for organizational excellence. Professional accreditation, industry recognition, standards alignment, documentation preparation, and quality demonstration for program credibility and market positioning. Third-party validation, external assessment, evaluator selection, review preparation, and credibility building for objective program evaluation and recognition. Market differentiation, competitive analysis, value proposition development, brand development, and success measurement for competitive advantage and market leadership. Industry leadership, expertise development, content creation, professional networking, and industry contribution for thought leadership and market influence research and innovation excellence. Systematic research programs, research strategy, study design, data collection, analysis methodology, and publication for evidence-based program improvement and field advancement. Innovation laboratory development, experimental design, pilot implementation, scaling strategy, and impact evaluation for systematic innovation and competitive advantage. Trend analysis and predictive planning, technology forecasting, scenario planning, strategic adaptation, and innovation anticipation for future readiness and market leadership. Continuous program evolution, evolution strategy, innovation pipeline, capability building, and legacy planning for sustained advancement and competitive positioning. Chapter 27. Quality assurance and continuous improvement. Chapter Introduction, Building Sustainable Excellence in AI-Fluent Professional Development. Chapter 27 establishes the comprehensive framework for maintaining and continuously improving the quality of the Building AI-Fluent Professionals program through systematic quality assurance, evidence-based improvement processes, and innovation integration that ensures sustained educational excellence and organizational impact over time. The quality assurance framework recognizes that educational program excellence requires not just strong initial design but systematic monitoring, evaluation, and improvement processes that respond to changing technology, evolving organizational needs, participant feedback, and emerging best practices in AI education and professional development. This comprehensive quality management approach operates on the principle that sustainable educational excellence depends on continuous improvement cycles that integrate participant outcomes, stakeholder feedback, industry developments, and research insights to maintain program relevance, effectiveness, and competitive advantage in rapidly evolving AI and educational landscapes. The quality assurance requirements span program monitoring systems, feedback integration processes, curriculum evolution, frameworks, technology advancement integration, external validation strategies, and research-driven innovation that create resilient educational programs capable of adapting while maintaining excellent standards. The continuous improvement methodology integrates current best practices in educational quality management with AI-specific challenges while building organizational capability for ongoing program enhancement, stakeholder satisfaction, and competitive differentiation through systematic excellence maintenance and strategic innovation. This chapter prepares organizations to sustain and enhance AI education excellence through evidence-based quality management, ensuring that initial program investment continues creating value through systematic improvement, stakeholder satisfaction, and market leadership in AI professional development over extended time horizons. 27.1 Program Quality Metrics and Monitoring Systems. Comprehensive Quality Measurement Framework. Multidimensional Quality Indicator Development. Quality measurement requires comprehensive frameworks that capture educational effectiveness while building measurement expertise and monitoring capability essential for AI training programs that require systematic quality assessment, performance tracking, and improvement guidance. Through sophisticated quality metrics and measurement systems. Quality framework includes learning outcomes, participant satisfaction, instructor effectiveness, and organizational impact that provide comprehensive quality assessment while building framework thinking and measurement capability. Framework should be comprehensive while remaining practical and focused on genuine quality rather than measurement complexity or artificial quality sophistication. Learning outcome metrics include competency development, skill acquisition, knowledge retention, and application success that measure educational effectiveness while building outcome thinking and measurement capability. Metrics should be meaningful while remaining achievable and focused on genuine learning rather than metric complexity or artificial outcome sophistication. Satisfaction measurement includes participant experience, instructor evaluation, stakeholder feedback, and program assessment that gauge program effectiveness while building satisfaction thinking and evaluation capability. Measurement should be systematic while remaining responsive and focused on genuine satisfaction rather than measurement complexity or artificial evaluation sophistication. Performance indicators include completion rates, achievement levels, engagement metrics, and success measures that track program performance while building indicator thinking and performance capability. Indicators should be relevant while remaining actionable and focused on program improvement, rather than indicator complexity or artificial performance sophistication. Impact assessment includes career advancement, organizational benefit, skill application, and value creation that demonstrate program value while building impact thinking and assessment capability. Assessment should be comprehensive while remaining realistic and focused on genuine impact rather than assessment complexity or artificial value sophistication. Real-time monitoring and analytics systems. Monitoring systems create continuous oversight while building analytics expertise and monitoring capability essential for AI training programs that require real-time performance tracking, issue identification, and proactive improvement through sophisticated monitoring infrastructure and analytics platforms. Dashboard development includes metric visualization, trend analysis, performance tracking, and alert systems that enable effective program monitoring while building dashboard thinking and visualization capability. Development should be intuitive while remaining comprehensive and focused on actionable insight rather than dashboard complexity or artificial visualization sophistication. Data collection includes automated gathering, manual input, survey integration, and feedback compilation that provide comprehensive program data while building collection thinking and data capability. Collection should be systematic while remaining privacy-respecting and focused on improvement. Insight rather than collection complexity or artificial data sophistication. Analytics integration includes pattern recognition, trend identification, correlation analysis, and predictive modeling that generate program insights while building analytics thinking and insight capability. Integration should be meaningful while remaining interpretable and focused on program improvement rather than analytics complexity or artificial insight sophistication. Alert mechanisms include threshold monitoring, anomaly detection, escalation procedures, and response protocols that enable proactive issue management while building alert thinking and response capability. Mechanisms should be intelligent while remaining actionable and focused on issue prevention rather than alert complexity or artificial response sophistication. Reporting systems include regular updates, stakeholder communication, performance summaries, and improvement recommendations that communicate program status while building reporting thinking and communication capability. Systems should be clear while remaining comprehensive and focused on stakeholder understanding rather than reporting complexity or artificial communication sophistication. Performance benchmarking and standards development. Industry benchmark analysis and competitive assessment. Benchmark analysis creates performance context while building comparison expertise and assessment capability essential for AI training programs that require understanding of industry standards, competitive positioning, and excellence targets through systematic benchmarking and comparative analysis. Industry standard identification includes best practice research, excellence criteria, performance benchmarks, and quality standards that provide comparative context while building standard thinking and identification capability. Identification should be comprehensive while remaining relevant and focused on applicable standards rather than identification complexity or artificial standard sophistication. Competitive analysis includes program comparison, feature assessment, outcome evaluation, and positioning analysis that understand market context while building competitive thinking and analysis capability. Analysis should be systematic while remaining ethical and focused on improvement insight rather than competitive sophistication. Complexity or artificial analysis. Performance comparison includes metric benchmarking, outcome comparison, effectiveness assessment, and relative positioning that evaluate program performance while building comparison thinking and evaluation capability. Comparison should be fair while remaining improvement-focused and oriented toward excellence enhancement rather than comparison complexity or artificial evaluation sophistication. Excellence targeting includes aspiration setting, improvement planning, goal establishment, and achievement pursuit that guide program enhancement while building targeting thinking and excellence capability. Targeting should be ambitious while remaining achievable and focused on genuine improvement rather than targeting complexity or artificial excellence sophistication. Gap identification includes performance differences, opportunity recognition, improvement areas, and enhancement potential that guide program development while building gap thinking and opportunity capability. Identification should be honest while remaining constructive and focused on improvement planning rather than gap complexity or artificial opportunity sophistication. Internal quality standards and certification criteria. Standards development creates quality assurance while building standard expertise and certification capability essential for AI training programs that require clear quality criteria, consistent standards, and reliable certification through systematic standard development and quality assurance frameworks. Quality criteria includes learning standards, performance requirements, outcome expectations, and achievement benchmarks that define program quality while building criteria thinking and standard capability. Criteria should be rigorous while remaining achievable and focused on genuine quality rather than criteria complexity or artificial standard sophistication. Certification framework includes competency requirements, assessment criteria, validation processes, and credential standards that ensure program credibility while building certification thinking and framework capability. Framework should be credible while remaining accessible and focused on genuine competency rather than certification complexity or artificial framework sophistication. Accreditation preparation includes standard alignment, documentation development, process optimization, and validation readiness that prepare for external recognition while building accreditation thinking and preparation capability. Preparation should be systematic while remaining authentic and focused on genuine quality rather than accreditation complexity or artificial preparation sophistication. Audit procedures includes quality review, compliance verification, standard assessment, and improvement identification that maintain quality standards while building audit thinking and review capability. Procedures should be fair while remaining rigorous and focused on quality assurance rather than audit complexity or artificial review sophistication. Continuous calibration includes standard adjustment, criteria refinement, benchmark updating, and quality evolution that maintain relevant standards while building calibration thinking and evolution capability. Calibration should be responsive while remaining stable and focused on standard relevance rather than calibration sophistication. Complexity or artificial evolution. (27.2) Participant feedback integration and response procedures. Systematic feedback collection and analysis. Multi-channel feedback gathering and integration. Feedback collection creates comprehensive input while building collection expertise and integration capability essential for AI training programs that require diverse feedback sources, systematic collection processes, and effective integration methods through sophisticated feedback systems and analysis frameworks. Feedback channels include surveys, interviews, focus groups, and observation that provide diverse input sources while building channel thinking and collection capability. Channels should be varied while remaining accessible and focused on genuine feedback rather than channel complexity or artificial collection sophistication. Collection methodology includes timing optimization, question design, response facilitation, and participation encouragement that maximize feedback quality while building methodology thinking and collection capability. Methodology should be systematic while remaining user-friendly and focused on useful feedback rather than methodology complexity or artificial collection sophistication. Participant voice includes learner perspective, experience sharing, concern expression, and suggestion provision that capture authentic participant input while building voice thinking and expression capability. Voice should be genuine while remaining constructive and focused on program improvement rather than voice complexity or artificial expression sophistication. Stakeholder input includes organizational feedback, supervisor assessment, peer evaluation, and community perspective that provide comprehensive program assessment while building stakeholder thinking and input capability. Input should be representative while remaining actionable and focused on program enhancement rather than stakeholder complexity or artificial input sophistication. Data integration includes feedback compilation, pattern recognition, insight synthesis, and recommendation development that create actionable improvement guidance while building integration thinking and synthesis capability. Integration should be systematic while remaining insightful and focused on improvement planning rather than integration complexity or artificial synthesis sophistication. Feedback analysis and response planning. Feedback analysis creates improvement insight while building analysis expertise and response capability essential for AI training programs that require systematic feedback interpretation, priority identification, and response planning. Through comprehensive analysis frameworks and action development processes. Analysis methodology includes content analysis, trend identification, pattern recognition, and insight extraction that generate improvement understanding while building analysis thinking and interpretation capability. Methodology should be rigorous while remaining practical and focused on actionable insight rather than analysis complexity or artificial interpretation sophistication. Priority identification includes issue ranking, impact assessment, urgency evaluation, and resource consideration that guide improvement focus while building priority thinking and ranking capability. Identification should be strategic while remaining responsive and focused on maximum impact rather than priority complexity or artificial ranking sophistication. cause analysis includes problem investigation, factor identification, system examination, and cause determination that address fundamental issues while building cause thinking and investigation capability. Analysis should be thorough while remaining solution-focused and oriented toward problem resolution rather than cause complexity or artificial investigation sophistication. Response planning includes action development, implementation strategy, resource allocation, and timeline establishment that create improvement initiatives while building response thinking and planning capability. Planning should be comprehensive while remaining feasible and focused on effective implementation rather than planning complexity or artificial response sophistication. Communication strategy includes feedback acknowledgement, response communication, progress updates, and completion notification that maintain stakeholder engagement while building communication thinking and engagement capability. Strategy should be transparent while remaining efficient and focused on stakeholder satisfaction rather than communication complexity or artificial engagement sophistication. Continuous improvement implementation. Rapid response and agile improvement cycles. Rapid response creates timely improvement while building agility expertise and response capability essential for AI training programs that require quick adaptation, effective problem resolution, and continuous enhancement through agile improvement methodologies frameworks. And responsive action. Agile methodology includes iterative improvement, rapid prototyping, quick testing, and fast implementation that enable responsive program enhancement while building agile thinking and methodology capability. Methodology should be flexible while remaining systematic and focused on effective improvement rather than agile complexity or artificial methodology sophistication. Issue triage includes problem categorization, severity assessment, urgency ranking, and response prioritization that guide improvement focus while building triage thinking and prioritization capability. Triage should be systematic while remaining responsive and focused on maximum impact rather than triage complexity or artificial prioritization sophistication. Quick wins identification includes immediate improvements, easy implementations, high-impact changes, and rapid benefits that demonstrate responsiveness while building win thinking and implementation capability. Identification should be strategic while remaining achievable and focused on stakeholder satisfaction rather than win complexity or artificial implementation sophistication. Pilot testing includes small-scale trials, controlled experiments, feedback collection, and effectiveness assessment that validate improvements before full implementation while building pilot thinking and testing capability. Testing should be systematic while remaining efficient and focused on improvement validation rather than pilot complexity or artificial testing sophistication. Implementation tracking includes progress monitoring, outcome measurement, impact assessment, and success evaluation that ensure improvement effectiveness while building tracking thinking and evaluation capability. Tracking should be comprehensive while remaining practical and focused on improvement success rather than tracking complexity or artificial evaluation sophistication. Long-term strategic enhancement planning. Strategic enhancement creates sustained improvement while building enhancement expertise and planning capability essential for AI training programs that require systematic program evolution, strategic development, and long-term excellence through comprehensive enhancement planning and strategic improvement frameworks. Strategic planning includes vision development, goal setting, roadmap creation, and resource allocation that guide long-term improvement while building planning thinking and strategy capability. Planning should be comprehensive while remaining flexible and focused on program advancement rather than planning complexity or artificial strategy sophistication. Innovation integration includes new technology adoption, methodology advancement, practice improvement, and capability enhancement that keep programs current while building innovation thinking and integration capability. Integration should be thoughtful while remaining progressive and focused on program enhancement rather than innovation complexity or artificial integration sophistication. Capability development includes skill enhancement, knowledge advancement, infrastructure improvement, and resource strengthening that build program capacity while building capability thinking and development. Development should be systematic while remaining practical and focused on capacity enhancement rather than capability complexity or artificial development sophistication. Partnership expansion includes relationship building, collaboration development, alliance formation, and network strengthening that enhance program resources while building partnership thinking and expansion capability. Expansion should be strategic while remaining authentic and focused on mutual benefit rather than partnership complexity or artificial expansion sophistication. Excellence evolution includes standard advancement, quality improvement, performance enhancement, and achievement elevation that drive program excellence while building excellence thinking and evolution capability. Evolution should be ambitious while remaining achievable and focused on genuine excellence rather than evolution complexity or artificial excellence sophistication. 27.3 Curriculum updates and technology. Integration, keeping content current with AI evolution. Dynamic curriculum management and evolution. Systematic content review and update processes. Content management creates current curriculum while building management expertise and update capability essential for AI training programs that require regular content review, systematic updates, and continuous relevance maintenance through sophisticated curriculum management and evolution frameworks. Review methodology includes content assessment, relevance evaluation, accuracy verification, and update identification that maintain curriculum currency while building review thinking and assessment capability. Methodology should be systematic while remaining efficient and focused on content relevance rather than review complexity or artificial assessment sophistication. Currency tracking includes technology monitoring, industry development, trend identification, and change assessment that identify update needs while building tracking thinking and awareness capability. Tracking should be comprehensive while remaining practical and focused on relevant changes rather than tracking complexity or artificial awareness sophistication. Content lifecycle includes creation, deployment, maintenance, and retirement that manage curriculum evolution while building lifecycle thinking and management capability. Lifecycle should be systematic while remaining flexible and focused on content effectiveness rather than lifecycle complexity or artificial management sophistication. Version control includes change tracking, update management, revision coordination, and consistency maintenance that ensure curriculum coherence while building control thinking and coordination capability. Control should be systematic while remaining accessible and focused on content integrity rather than control sophistication. Complexity or artificial coordination. Quality assurance includes accuracy verification, relevance confirmation, effectiveness assessment, and standard maintenance that ensure curriculum quality while building assurance thinking and verification capability. Assurance should be rigorous while remaining practical and focused on genuine quality rather than assurance complexity or artificial verification sophistication. Emerging technology integration and adaptation. Technology integration creates forward-looking education while building integration expertise and adaptation capability essential for AI training programs that require rapid technology adoption, effective integration, and strategic advancement through systematic technology integration and curriculum adaptation frameworks. Technology scouting includes advancement monitoring, tool evaluation, platform assessment, and integration planning that identify technology opportunities while building scouting thinking and evaluation capability. Scouting should be systematic while remaining focused and oriented toward educational relevance rather than scouting complexity or artificial evaluation sophistication. Integration strategy includes adoption planning, implementation design, rollout coordination, and change management that enable effective technology integration while building strategy thinking and integration capability. Strategy should be comprehensive while remaining practical and focused on successful adoption rather than strategy complexity or artificial integration sophistication. Pilot programs includes experimental integration, trial implementation, feedback collection, and effectiveness assessment that validate technology adoption while building pilot thinking and experimentation capability. Programs should be systematic while remaining cautious and focused on educational improvement rather than pilot complexity or artificial experimentation sophistication. Training development includes instructor preparation, capability building, support provision, and competency enhancement that enable effective technology utilization while building training thinking and development capability. Development should be comprehensive while remaining practical and focused on instructor success rather than training complexity or artificial development sophistication. Impact measurement includes effectiveness assessment, learning improvement, efficiency enhancement, and value creation that evaluate technology integration success while building measurement thinking and assessment capability. Measurement should be meaningful while remaining practical and focused on genuine impact rather than measurement complexity or artificial assessment sophistication. Research-driven improvement and innovation. Educational research integration and application. Research integration creates evidence-based improvement while building research expertise and application capability essential for AI training programs that require scientific understanding of learning effectiveness, evidence-based practice adoption, and systematic improvement through research application and educational innovation. Research monitoring includes study tracking, finding analysis, application assessment, and practice integration that inform program improvement while building monitoring thinking and research capability. Monitoring should be systematic while remaining practical and focused on applicable research rather than monitoring complexity or artificial research sophistication. Evidence evaluation includes study quality, finding validity, application relevance, and practice effectiveness that guide research adoption while building evaluation thinking and evidence capability. Evaluation should be rigorous while remaining practical and focused on useful evidence rather than evaluation complexity or artificial evidence sophistication. Best practice identification includes excellence recognition, success analysis, pattern identification, and wisdom extraction that identify improvement opportunities while building identification thinking and practice capability. Identification should be evidence-based while remaining practical and focused on applicable practices rather than identification complexity or artificial practice sophistication. Implementation testing includes practice trials, effectiveness measurement, adaptation assessment, and success evaluation that validate research application while building testing thinking and implementation capability. Testing should be systematic while remaining practical and focused on practice effectiveness rather than testing complexity or artificial implementation sophistication. Knowledge creation includes original research, practice development, innovation contribution, and field advancement that contribute to educational knowledge while building creation thinking and contribution capability. Creation should be meaningful while remaining practical and focused on field advancement rather than creation complexity or artificial contribution sophistication. Innovation pipeline and future development. Innovation development creates program advancement while building innovation expertise and development capability essential for AI training programs that require systematic innovation, strategic development, and competitive advancement through comprehensive innovation frameworks and future planning processes. Innovation strategy includes opportunity identification, resource allocation, development planning, and implementation coordination that guide innovation efforts while building strategy thinking and innovation capability. Strategy should be strategic while remaining practical and focused on meaningful innovation rather than strategy complexity or artificial innovation sophistication. Experimental programs include pilot initiatives, trial implementations, proof of concept development, and innovation testing that explore advancement opportunities while building experimental thinking and testing capability. Programs should be systematic while remaining creative and focused on genuine advancement rather than experimental complexity or artificial testing sophistication. Future planning includes trend analysis, scenario development, strategic preparation, and capability building that prepare for program evolution while building planning thinking and future capability. Planning should be forward-thinking while remaining grounded and focused on realistic preparation rather than planning complexity or artificial future sophistication. Partnership development includes research collaboration, industry alliance, academic cooperation, and innovation networking that enhance innovation capacity while building partnership thinking and collaboration capability. Development should be strategic while remaining authentic and focused on mutual benefit rather than partnership complexity or artificial collaboration sophistication. Intellectual property includes innovation protection, knowledge management, value capture, and strategic advantage that preserve innovation value while building property thinking and protection capability. Property should be valuable while remaining accessible and focused on appropriate protection rather than property complexity or artificial protection sophistication. 27 point for best practice documentation and knowledge management. Comprehensive knowledge capture and preservation. Institutional memory and wisdom documentation. Knowledge management creates organizational learning while building documentation expertise and preservation capability essential for AI training programs that require systematic knowledge capture, institutional memory preservation, and wisdom transfer through comprehensive knowledge management and documentation frameworks. Knowledge architecture includes information organization, content structure, access design, and retrieval optimization that create effective knowledge systems while building architecture thinking and organization capability. Architecture should be logical while remaining accessible and focused on knowledge utility rather than architecture complexity or artificial organization sophistication. Documentation standards includes format specification, quality criteria, content requirements, and consistency guidelines that ensure knowledge quality while building standard thinking and documentation capability. Standards should be clear while remaining practical and focused on knowledge accessibility rather than standard complexity or artificial documentation sophistication. Tacit knowledge capture includes expertise extraction, experience documentation, wisdom preservation, and insight. Recording that preserve valuable knowledge while building capture thinking and preservation capability. Capture should be comprehensive while remaining natural and focused on knowledge value rather than capture complexity or artificial preservation sophistication. Knowledge validation includes accuracy verification, relevance confirmation, completeness assessment, and quality assurance that ensure knowledge reliability while building validation thinking and quality capability. Validation should be rigorous while remaining practical and focused on knowledge integrity rather than validation complexity or artificial quality sophistication. Access management includes permission control, user authentication, retrieval optimization, and usage tracking that enable appropriate knowledge access while building access thinking and management capability. Management should be secure while remaining user-friendly and focused on knowledge availability rather than access complexity or artificial management sophistication. Best practice identification and dissemination. Best practice management creates excellence sharing while building practice expertise and dissemination capability essential for AI training programs that require systematic excellence identification, effective practice sharing, and widespread adoption through comprehensive best practice frameworks and sharing systems. Practice identification includes excellence recognition, success analysis, pattern identification, and wisdom extraction that identify valuable practices while building identification thinking and analysis capability. Identification should be evidence-based while remaining practical and focused on genuine excellence rather than identification complexity or artificial analysis sophistication. Documentation methodology includes practice recording, context preservation, outcome documentation, and replication guidance that preserve practice knowledge while building methodology thinking and documentation capability. Methodology should be comprehensive while remaining usable and focused on practice transfer rather than methodology complexity or artificial documentation sophistication. Quality assessment includes practice evaluation, effectiveness measurement, transferability analysis, and value determination that ensure practice quality while building assessment thinking and evaluation capability. Assessment should be rigorous while remaining practical and focused on practice value rather than assessment complexity or artificial evaluation sophistication. Sharing mechanisms includes dissemination channels, communication methods, training provision, and adoption support that enable practice spread while building sharing thinking and communication capability. Mechanisms should be effective while remaining accessible and focused on practice adoption rather than sharing complexity or artificial communication sophistication. Adoption tracking includes implementation monitoring, success measurement, adaptation assessment, and impact evaluation that ensure practice effectiveness while building tracking thinking and measurement capability. Tracking should be systematic while remaining supportive and focused on adoption success rather than tracking complexity or artificial measurement sophistication. Knowledge transfer and organizational learning. Cross-program learning and experience sharing. Cross-program learning creates collective advancement while building learning expertise and sharing capability essential for AI training programs that require knowledge transfer between implementations, experience sharing across contexts, and collective improvement through systematic learning and sharing frameworks. Learning synthesis includes experience integration, knowledge combination, insight development, and wisdom creation that create collective understanding while building synthesis thinking and integration capability. Synthesis should be comprehensive while remaining coherent and focused on collective advancement rather than synthesis complexity or artificial integration sophistication. Experience documentation includes implementation recording, challenge documentation, solution preservation, and outcome capture that preserve learning value while building documentation thinking and preservation capability. Documentation should be thorough while remaining accessible and focused on learning transfer rather than documentation complexity or artificial preservation sophistication. Pattern recognition includes similarity identification, trend recognition, principle extraction, and generalization development that identify transferable knowledge while building recognition thinking and analysis capability. Recognition should be systematic while remaining practical and focused on applicable patterns rather than recognition complexity or artificial analysis sophistication. Adaptation modification guidance includes context consideration, planning, customization support, and implementation assistance that enable knowledge transfer while building guidance thinking and adaptation capability. Guidance should be practical while remaining comprehensive and focused on successful transfer rather than guidance complexity or artificial adaptation sophistication. Community building includes network formation, relationship development, collaboration facilitation, and knowledge sharing that create learning communities while building community thinking and networking capability. Building should be organic while remaining purposeful and focused on knowledge advancement rather than community complexity or artificial networking sophistication. Continuous learning culture development. Culture development creates learning organizations while building culture expertise and development capability essential for AI training programs that require organizational learning. Cultures, continuous improvement mindsets, and knowledge sharing behaviors through systematic culture development and learning facilitation. Learning culture includes curiosity encouragement, experimentation support, failure tolerance, and improvement celebration that foster organizational learning while building culture thinking and development capability. Culture should be authentic while remaining productive and focused on genuine learning rather than culture complexity or artificial development sophistication. Knowledge sharing includes expertise exchange, experience communication, wisdom transfer, and insight distribution that enable organizational learning while building sharing thinking and communication capability. Sharing should be generous while remaining organized and focused on knowledge value rather than sharing complexity or artificial communication sophistication. Reflection practices includes experience analysis, learning extraction, insight development, and improvement identification that deepen organizational understanding while building reflection thinking and practice capability. Practices should be thoughtful while remaining practical and focused on learning enhancement rather than reflection complexity or artificial practice sophistication. Innovation support includes creativity encouragement, experimentation facilitation, risk acceptance, and breakthrough celebration that foster organizational innovation while building innovation thinking and support capability. Support should be meaningful while remaining practical and focused on genuine innovation rather than support complexity or artificial innovation sophistication. Excellence pursuit includes standard advancement, quality improvement, performance enhancement, and achievement recognition that drive organizational excellence while building excellence thinking and pursuit capability. Pursuit should be ambitious while remaining achievable and focused on genuine excellence rather than pursuit complexity or artificial excellence sophistication. 27.5 External validation and accreditation. Strategies. Professional accreditation and certification development. Industry recognition and professional standards alignment. Accreditation development creates external validation while building recognition expertise and standards capability essential for AI training programs that require professional credibility, industry recognition, and competitive advantage through systematic accreditation and external validation frameworks. Accreditation research includes standard identification, requirement analysis, compliance assessment, and preparation planning that guide accreditation pursuit while building research thinking and preparation capability. Research should be comprehensive while remaining practical and focused on achievable accreditation rather than research complexity or artificial preparation sophistication. Standards alignment includes requirement mapping, content adjustment, process modification, and quality enhancement that ensure accreditation compliance while building alignment thinking and compliance capability. Alignment should be systematic while remaining authentic and focused on genuine compliance rather than alignment complexity or artificial compliance sophistication. Documentation preparation includes evidence compilation, record organization, proof development, and submission readiness that support accreditation applications while building preparation thinking and documentation capability. Preparation should be thorough while remaining organized and focused on accreditation success rather than preparation complexity or artificial documentation sophistication. Quality demonstration includes excellence evidence, outcome documentation, impact measurement, and value illustration that showcase program quality while building demonstration thinking and evidence capability. Demonstration should be compelling while remaining honest and focused on genuine quality rather than demonstration complexity or artificial evidence sophistication. Maintenance planning includes ongoing compliance, continuous improvement, review preparation, and renewal readiness that sustain accreditation while building maintenance thinking and compliance capability. Planning should be systematic while remaining sustainable and focused on accreditation preservation rather than maintenance complexity or artificial compliance sophistication. External assessment and third-party validation. External validation creates objective assessment while building validation expertise and assessment capability essential for AI training programs that require independent evaluation, credible assessment, and market recognition through systematic external validation and third-party evaluation frameworks. Evaluator selection includes assessor identification, credential verification, expertise confirmation, and independence assurance that ensure quality evaluation while building selection thinking and assessment capability. Selection should be rigorous while remaining fair and focused on evaluation quality rather than selection complexity or artificial assessment sophistication. Assessment design includes evaluation criteria, measurement methods, evidence requirements, and validation processes that create comprehensive assessment while building design thinking and evaluation capability. Design should be systematic while remaining practical and focused on genuine assessment rather than design complexity or artificial evaluation sophistication. Review preparation includes documentation organization, evidence compilation, presentation development, and response readiness that support external review while building preparation thinking and review capability. Preparation should be comprehensive while remaining efficient and focused on review success rather than preparation complexity or artificial review sophistication. Feedback integration includes recommendation analysis, improvement planning, implementation coordination, and follow-up execution that utilize external feedback while building integration thinking and improvement capability. Integration should be systematic while remaining responsive and focused on genuine improvement rather than integration complexity or artificial improvement sophistication. Credibility building includes reputation development, trust establishment, recognition achievement, and authority creation that enhance program credibility while building credibility thinking and reputation capability. Building should be earned while remaining authentic and focused on genuine credibility rather than building complexity or artificial reputation sophistication. Market positioning and competitive advantage. Program differentiation, proposition development, and value. Differentiation creates market position while building positioning expertise and advantage capability essential for AI training programs that require competitive distinction, value articulation, and market leadership through systematic differentiation and value proposition development frameworks. Competitive analysis includes market research, competitor assessment, positioning evaluation, and opportunity identification that inform differentiation strategy while building analysis thinking and competitive capability. Analysis should be systematic while remaining ethical and focused on differentiation opportunity rather than analysis complexity or artificial competitive sophistication. Value proposition includes benefit articulation, advantage communication, uniqueness emphasis, and value demonstration that create compelling market position while building proposition thinking and value capability. Proposition should be authentic while remaining compelling and focused on genuine value rather than proposition complexity or artificial value sophistication. Brand development includes identity creation, message crafting, reputation building, and recognition achievement that establish market presence while building brand thinking and development capability. Development should be authentic while remaining strategic and focused on genuine brand value rather than development complexity or artificial brand sophistication. Market communication includes message dissemination, audience engagement, channel utilization, and response generation that build market awareness while building communication thinking and engagement capability. Communication should be effective while remaining truthful and focused on market education rather than communication complexity or artificial engagement sophistication. Success measurement includes market response, recognition achievement, competitive position, and advantage realization that evaluate differentiation success while building measurement thinking and evaluation capability. Measurement should be comprehensive while remaining realistic and focused on genuine success rather than measurement complexity or artificial evaluation sophistication. Industry leadership and thought leadership development. Leadership development creates industry influence while building leadership expertise and influence capability essential for AI training programs that require market leadership, professional recognition, and industry advancement through systematic leadership development and influence building frameworks. Expertise development includes knowledge building, skill enhancement, authority establishment, and credibility creation that build professional expertise while building expertise thinking and authority capability. Development should be genuine while remaining systematic and focused on authentic expertise rather than development complexity or artificial authority sophistication. Content creation includes knowledge sharing, insight communication, wisdom dissemination, and thought contribution that establish thought leadership while building creation thinking and contribution capability. Creation should be valuable while remaining accessible and focused on genuine contribution rather than creation complexity or artificial contribution sophistication. Speaking engagement includes presentation delivery, conference participation, workshop facilitation, and thought sharing that build professional recognition while building speaking thinking and engagement capability. Engagement should be influential while remaining authentic and focused on value delivery rather than speaking complexity or artificial engagement sophistication. Professional networking includes relationship building, community participation, collaboration development, and influence expansion that create professional networks while building networking thinking and relationship capability. Networking should be genuine while remaining strategic and focused on mutual benefit rather than networking complexity or artificial relationship sophistication. Industry contribution includes standard development, practice advancement, knowledge sharing, and field improvement that advance professional fields while building contribution thinking and advancement capability. Contribution should be meaningful while remaining collaborative and focused on field benefit rather than contribution complexity or artificial advancement sophistication. 27.6 Research and development for training. Innovation. Educational research and evidence-based practice. Systematic research program development. Research development creates innovation foundation while building research expertise and investigation capability essential for AI training programs that require evidence-based improvement, systematic investigation, and knowledge creation through comprehensive research frameworks and investigation methodologies. Research strategy includes question identification, methodology selection, resource allocation, and timeline development that guide research efforts while building strategy thinking and research capability. Strategy should be systematic while remaining practical and focused on meaningful research rather than strategy complexity or artificial research sophistication. Study design includes experimental planning, control establishment, variable identification, and outcome measurement that create valid research while building design thinking and methodology capability. Design should be rigorous while remaining feasible and focused on reliable results rather than design complexity or artificial methodology sophistication. Data collection includes information gathering, measurement execution, observation recording, and evidence compilation that provide research foundation while building collection thinking and data capability. Collection should be systematic while remaining ethical and focused on research validity rather than collection data sophistication. Complexity or artificial. Analysis methodology includes statistical analysis, pattern recognition, insight generation, and conclusion development that create research understanding while building analysis thinking and interpretation capability. Methodology should be appropriate while remaining rigorous and focused on valid conclusions rather than methodology complexity or artificial interpretation sophistication. Publication and dissemination includes finding communication, knowledge sharing, peer review, and field contribution that share research value while building publication thinking and communication capability. Publication should be valuable while remaining accessible and focused on knowledge advancement rather than publication complexity or artificial communication sophistication. Innovation laboratory and pilot program development. Innovation development creates advancement capability while building innovation expertise and experimentation capability essential for AI training programs that require systematic innovation, controlled experimentation, and strategic advancement through comprehensive innovation frameworks and experimentation methodologies. Innovation framework includes opportunity identification, resource allocation, development planning, and implementation coordination that guide innovation efforts while building framework thinking and innovation capability. Framework should be systematic while remaining creative and focused on meaningful innovation rather than framework complexity or artificial innovation sophistication. Experimental design includes hypothesis development, trial planning, control establishment, and outcome measurement that create valid experiments while building experimental thinking and design capability. Design should be rigorous while remaining practical and focused on reliable results rather than experimental complexity or artificial design sophistication. Pilot implementation includes small-scale testing, controlled trials, feedback collection, and effectiveness assessment that validate innovations while building pilot thinking and testing capability. Implementation should be systematic while remaining cautious and focused on innovation validation rather than pilot complexity or artificial testing sophistication. Scaling strategy includes expansion planning, resource preparation, implementation coordination, and success measurement that enable innovation adoption while building scaling thinking and expansion capability. Strategy should be systematic while remaining practical and focused on successful scaling rather than strategy complexity or artificial expansion sophistication. Impact evaluation includes outcome measurement, benefit assessment, value determination, and success evaluation that demonstrate innovation value while building evaluation thinking and assessment capability. Evaluation should be comprehensive while remaining realistic and focused on genuine impact rather than evaluation complexity or artificial assessment sophistication. Future-oriented development and emerging trends. Trend analysis and predictive planning. Trend development creates future readiness while building analysis expertise and planning capability essential for AI training programs that require strategic foresight, adaptive planning, and competitive preparation through systematic trend analysis and predictive planning frameworks. Trend monitoring includes development tracking, pattern recognition, signal identification, and implication analysis that identify future directions while building monitoring thinking and analysis capability. Monitoring should be systematic while remaining focused and oriented toward relevant trends rather than monitoring complexity or artificial analysis sophistication. Scenario planning includes future modeling, possibility exploration, strategy development, and preparation planning that prepare for multiple futures while building scenario thinking and planning capability. Planning should be comprehensive while remaining practical and focused on strategic preparation rather than planning complexity or artificial scenario sophistication. Technology forecasting includes advancement prediction, adoption modeling, impact assessment, and timeline estimation that anticipate technology changes while building forecasting thinking and prediction capability. Forecasting should be informed while remaining realistic and focused on practical preparation rather than forecasting complexity or artificial prediction sophistication. Strategic adaptation includes flexibility planning, response preparation, capability building, and advantage development that enable future success while building adaptation thinking and strategy capability. Adaptation should be proactive while remaining grounded and focused on strategic advantage rather than adaptation complexity or artificial strategy sophistication. Innovation anticipation includes breakthrough identification, disruption preparation, opportunity recognition, and advantage planning that prepare for innovation while building anticipation thinking and opportunity capability. Anticipation should be forward-thinking while remaining practical and focused on innovation readiness rather than anticipation complexity or artificial opportunity sophistication. Continuous innovation and program evolution. Evolution development creates sustained advancement while building evolution expertise and innovation capability essential for AI training programs that require continuous innovation. Strategic evolution and competitive advancement through systematic evolution methodologies. Frameworks and innovation. Evolution strategy includes advancement planning, capability development, innovation integration, and competitive positioning that guide program evolution while building strategy thinking and evolution capability. Strategy should be comprehensive while remaining practical and focused on sustainable advancement rather than strategy complexity or artificial evolution sophistication. Innovation pipeline includes idea generation, development planning, implementation coordination, and value realization that create continuous innovation while building pipeline thinking and innovation capability. Pipeline should be productive while remaining manageable and focused on meaningful innovation rather than pipeline complexity or artificial innovation sophistication. Capability building includes skill development, infrastructure enhancement, resource strengthening, and capacity expansion that enable program evolution while building capability thinking and development. Building should be systematic while remaining practical and focused on genuine capability rather than building sophistication. Complexity or artificial development. Partnership evolution includes relationship advancement, collaboration deepening, alliance strengthening, and network expansion that enhance evolution capacity while building. Partnership thinking and relationship capability. Evolution should be strategic while remaining authentic and focused on mutual benefit rather than evolution complexity or artificial relationship sophistication. Legacy planning includes knowledge preservation, transition preparation, succession planning, and continuity assurance that ensure sustainable evolution while building legacy thinking and planning capability. Planning should be forward-thinking while remaining practical and focused on program continuity rather than legacy complexity or artificial planning sophistication. Chapter 27 Conclusion: Quality Assurance as the Foundation for Sustained AI Education Excellence. Chapter 27 establishes the comprehensive framework for maintaining and continuously improving AI-fluent professional development programs through systematic quality assurance, evidence-based improvement processes, and strategic innovation that ensures sustained educational excellence and organizational impact over time. The program quality metrics and monitoring systems create comprehensive oversight while building measurement capabilities that enable real-time performance tracking, issue identification, and proactive improvement through sophisticated monitoring infrastructure and evidence-based quality management approaches. The participant feedback integration and response procedures build responsive improvement capability while creating systematic feedback utilization that ensures participant voice. Drives program enhancement through agile improvement cycles and strategic development planning that maintain stakeholder satisfaction and program relevance. The curriculum updates and technology integration frameworks create dynamic content management while building adaptation capabilities that ensure program currency with rapidly evolving AI technology while maintaining educational excellence through systematic content evolution and research-driven improvement methodologies. The best practice documentation and knowledge management components build institutional memory while creating learning capabilities that preserve program wisdom, facilitate cross-program learning, and develop continuous learning cultures that sustain organizational excellence through systematic knowledge capture and sharing frameworks. The external validation and accreditation strategies create market credibility while building recognition capabilities that establish program authority, competitive advantage, and industry leadership through systematic accreditation pursuit and thought leadership development that builds market position and professional recognition. The research and development frameworks build innovation capability while creating advancement systems that ensure continued program evolution, competitive differentiation, and industry leadership through systematic research programs and future-oriented development that maintains program excellence and market leadership. The comprehensive quality assurance established in Chapter 27 transforms AI education programs from static offerings into dynamic, continuously improving systems that adapt to changing technology and market needs while maintaining excellent standards and competitive advantage through systematic quality management and strategic innovation. This quality assurance approach recognizes that sustainable educational excellence requires not just strong initial design but systematic improvement processes that integrate stakeholder feedback, industry developments, and research insights to maintain program relevance, effectiveness, and market leadership in environments. Rapidly evolving AI and educational. Appendices. Appendix A: Assessment Templates and Rubrics. A.1 Attitude-based selection interview guides and scoring sheets. Growth mindset assessment interview protocol. Scenario 1. Learning agility challenge. Describe a time when you had to learn a completely new technology or skill quickly for work. Walk me through your approach, what challenges you faced, and how you overcame them. Evaluation criteria. Systematic approach. 4:1 shows structured learning methodology versus random attempts. Persistence through difficulty. 4:1 demonstrates resilience versus gives up easily. Resource utilization. 4:1 seeks help and uses multiple learning sources versus works in isolation. Reflection and adaptation. 4:1 adjusts approach based on feedback versus rigid methodology. Scenario 2. Collaborative problem solving. Tell me about a project where you had to work with people from different departments or backgrounds to solve a complex problem. How did you approach the collaboration? Evaluation criteria. Inclusive communication. 4:1 actively includes diverse perspectives versus dominates discussions. Conflict resolution. 4:1 addresses constructively versus avoids or escalates conflict disagreements. Knowledge integration. 4:1 synthesizes different viewpoints versus dismisses unfamiliar ideas. Shared success. 4:1 celebrates team achievements versus claims individual credit. Business application. Curiosity assessment. Question set. Strategic thinking. 1. What's an inefficiency you've noticed in your current workplace? How might technology help address it? 2. If you could automate one aspect of your job, what would it be and why? 3. How do you typically approach learning about new business processes or systems? Scoring rubric. 1 to 5 scale. 5. Exceptional. Identifies systemic issues. Proposes innovative solutions. Shows strategic business thinking. 4. Strong. Recognizes clear opportunities. Suggests practical improvements. Demonstrates business awareness. 3. Adequate. Notices obvious inefficiencies. Basic improvement ideas. Limited business context. 2. Developing. Focuses on personal convenience. Minimal systems thinking. Unclear business relevance. 1. Insufficient. No strategic. Awareness. Purely task-focused. Lacks improvement orientation. A.2 Weekly skills assessment templates with evaluation criteria. Week 1. Prompt engineering competency assessment practical challenge. Design 3 different prompts for a customer service AI that handles 1. Product return requests. 2. Technical troubleshooting. 3. Billing inquiries. Explain your reasoning for each approach. Evaluation matrix. Technical accuracy, 25%. Excellent. For sophisticated prompt structure, advanced techniques, optimal formatting. Good. 3. Clear structure, basic techniques applied correctly, proper formatting. Satisfactory. 2. Functional prompts, technique application, minor format issue. Some needs improvement. 1. Basic prompts, limited technique use, format problems. Business relevance, 25%. Excellent. For demonstrates deep understanding of customer service context and business impact. Good. 3. Shows good business awareness and practical application. Satisfactory. 2. Basic business understanding, somewhat practical. Needs improvement. 1. Limited business context, unclear practical value. Ethical consideration, 25%. Excellent. For proactively addresses bias, privacy, and fairness concerns. Good. 3. Shows awareness of ethical issues with basic mitigation. Satisfactory. 2. Mentions ethics but limited practical application. Needs improvement. 1. Minimal or no ethical consideration. Communication quality, 25%. Excellent. For clear explanations, justifies choices, anticipates questions. Good. 3. Good explanations, reasonable justification, mostly clear. Satisfactory. 2. Basic explanations, some justification, generally understandable. Needs improvement. 1. Unclear explanations, limited justification, difficult to follow. A.3 Portfolio development guidelines and quality standards. Professional portfolio architecture framework. Core portfolio components required. 1. Technical competency showcase, 30%. Minimum 3 working AI applications. Code documentation and explanation. Performance metrics and testing results. Deployment evidence, screenshots, links, demos. 2. Business application portfolio, 25%. ROI analysis for 2+ AI implementations, business case presentation, stakeholder communication, examples, process improvement, documentation. 3. Collaboration and leadership evidence, 25%. Team project contributions, peer feedback and testimonials, training or mentoring, examples, cross-functional collaboration stories. 4. Professional growth documentation, 20%. Learning reflection, essay, skill progression evidence, professional development planning, industry contribution, examples, quality assessment rubric, professional presentation, portfolio is well organized, visually appealing, and error-free. Of evidence, examples show sophisticated depth understanding and practical application, breadth of application, demonstrates competency across diverse scenarios and contexts, growth documentation, clear evidence of learning progression and professional development, impact measurement, quantifiable results and stakeholder feedback, validation, capstone project 8.4 and evaluation rubrics, requirements. Final capstone project, comprehensive AI strategy implementation project, requirements, duration, 4 weeks, week 13 of foundational program, team size, 3 to 4 participants with diverse specialization, interests, deliverables, live demo, GitHub repository, documentation, presentation, project scope, options. 1. Enterprise AI readiness assessment, complete organizational analysis with implementation roadmap. 2. Industry-specific AI solution, end-to-end development for healthcare, finance, or manufacturing. 3. AI ethics and governance framework, comprehensive policy and oversight system design. 4. AI training program design, complete curriculum for specific organizational context, evaluation framework, 100 points total, strategic thinking and business integration, 25 points exceptional, 23 to 25 sophisticated strategy, clear ROI, comprehensive stakeholder analysis, proficient, 18 to 22 good strategy, reasonable ROI, adequate stakeholder consideration, developing, 13 to 17 basic strategy, limited ROI analysis, minimal stakeholder awareness, insufficient, 0 to 12 poor strategy, no ROI consideration, lacks stakeholder perspective, technical implementation, quality, 25 points exceptional, 23 to 25 production ready, well documented, error-free, optimized performance, proficient, 18 to 22 good functional documentation, performance developing, 13 to 17. Minor implementation issues, adequate. Basic functionality, limited documentation, some errors, performance issues. Insufficient, 0 to 12, non-functional or severely limited, poor documentation, major errors, human-centered design and change management, 25 points exceptional, 23 to 25 comprehensive change strategy, excellent UX, inclusive design, proven adoption approach, proficient, 18 to 22 good change consideration, solid UX, accessible design, practical adoption plan, developing, 13 to 17 basic change awareness, adequate UX, limited accessibility, simple adoption ideas, insufficient. 0 to 12 no change management, poor UX, inaccessible design, unrealistic adoption, ethics and governance integration, 25 points exceptional, 23 to 25 comprehensive ethical framework, bias mitigation, transparency, accountability systems, proficient, 18 to 22 good ethical consideration, basic bias awareness, some transparency, clear responsibility, developing, 13 to 17 limited ethical awareness, minimal bias consideration, little transparency. Insufficient, 0 to 12 no ethical consideration, no bias awareness. No transparency or accountability. Appendix B, Implementation Checklists and Planning Tools. B.1 Pre-Program Preparation Checklist Setup and Organizational Readiness Checklist, complete 8 weeks before program launch, leadership and governance, executive sponsor identified and committed, CEO, CTO level, program champion designated with dedicated time allocation, minimum 50%. Steering committee functional representation formed with cross. Budget approved including contingency, recommend 15% buffer, success metrics defined and agreed upon by all stakeholders, infrastructure and technology, learning management system selected and configured, AI tool licenses secured, OpenAI, Anthropic, specialized platforms, development environment set up and tested. Network security and access controls configured, hardware requirements assessed and procured if needed, human resources and staffing, facilitator candidates identified and interviewed, facilitator training scheduled and completed, administrative support allocated, participant recruitment strategy developed, communication plan created for broader organization, legal and compliance, data privacy and security policies reviewed, intellectual property agreements drafted. Software licensing compliance verified, training records and certification requirements defined, external partnership agreements finalized if applicable. B.2 Weekly implementation guides with timeline and resource requirements. Week 1 implementation guide, prompt engineering mastery, pre-week preparation, complete by Friday before. OpenAI Playground accounts provisioned for all participants, prompt perfect licenses activated, LangChain development environment configured, business case study materials prepared, minimum 5 industry-specific examples, assessment rubrics finalized and shared with evaluation team, day-by-day timeline, Monday, foundation and theory, 6 hours, 9 to 10:30. Prompt anatomy and basic structures, 10:45 to 12 o'clock, role prompting and emotion prompting techniques, 13 to 14:30. Hands-on practice with basic prompts, 14:45 to 4 p.m., chain of thought introduction and practice, 16 to 5 p.m., day reflection and individual practice planning, Tuesday, advanced techniques, 6 hours, 9 to 10:30, analogical reasoning and self-refinement, 10:45 to 12 o'clock, auto-prompt and meta-prompting, 13 to 14:30, tool integration workshop, prompt perfect, 14:45 to 4 p.m., advanced technique combination practice. 16 to 5 p.m., peer review and feedback session, Wednesday, business applications, 6 hours, 9 to 10:30, marketing copywriting use cases, Jasper AI integration, 10:45 to 12 o'clock, customer service applications, 13 to 14:30, financial sentiment analysis project, 14:45 to 4 p.m., industry-specific prompt development, 16 to 5 p.m. Business value calculation workshop, Thursday, ethics and mitigation, 6 hours, 9 to 10:30, bias identification in prompts, 10:45 to 12 o'clock, hallucination prevention techniques, 13 to 14:30, ethical prompt design workshop, 14:45 to 4 p.m., mitigation strategy development, 16 to 5 p.m., ethics case study analysis, Friday, assessment and integration, 6 hours, 9 to 10:30, individual assessment completion, 10:45 to 12 o'clock, peer teaching exercises, 13 to 14:30, real-world prompt development challenge, 14:45 to 4 p.m., portfolio documentation. 16 to 5 p.m., week reflection and next week preparation, resource requirements, facilitator, 1 lead instructor plus 1 technical assistant, technology, OpenAI API credits, $500 estimate, prompt perfect licenses, materials, business case studies, assessment templates, reflection guide space, classroom with individual and collaboration areas. B.3 Technology setup. Workstations and configuration instructions, learning management system configuration guide, Moodle configuration steps, 1. Course structure setup, building AI Fluent Professionals. Phase 1, Foundation, days 1 to 30, Week 1, Prompt Engineering Mastery Theory and Practice Modules, Assessment Quizzes. Portfolio Submission Area Peer Review Forum, Week 2, AI Concepts and Python Foundations, additional weeks, Phase 2, Applied AI, days 31 to 60, Phase 3, Innovation and Ethics, days 61 to 90, Phase 4, Capstone, Week 13, 2. User Role Configuration Program Administrator, Full Access, User Management, Reporting Lead Facilitator, Assessment Course Editing, Creation, Analytics Access Assistant Facilitator, Limited Editing, Student Interaction, Basic Reporting Student, Course Capabilities, Access, Peer Interaction Submission. Observer, Read-Only Access for Stakeholders and Evaluators, 3. Assessment configuration enable competency-based progression. Configure portfolio upload areas, max 100 megabytes per file. Set up peer review workflows. Enable plagiarism detection integration. Configure automated feedback systems. API integration setup guide. OpenAI integration. Python environment configuration. OpenAI_API_key equals your API key here. Organization _ID equals your org ID. Max_tokens_per_request equals 2000. Rate limit_requests_per_minute equals 60. Student access configuration provision_student_access student_ID course_phase def. Provision appropriate API access based on course phase. If course_phase equals foundation, return configure_basic_access student_ID. If course_phase equals specialization, return configure_advanced_access student_ID. Usage monitoring def track_API_usage student_ID. Tokens_used, request_type, monitor and log API usage for billing and educational analytics. Log_usage, student_ID, tokens_used, request_type, timestamp equals now, check_usage_limits, student_ID. B point for stakeholder communication templates and presentation guides. Executive briefing launch announcement template, program. Subject: Launching AI Fluent Professionals, Strategic Capability Development Initiative. Executive summary: Organization is launching the Building AI Fluent Professionals program to develop critical AI capabilities across our organization. This 90-day intensive program will create internal expertise in AI strategy, technical implementation, human-centered adoption, and ethical governance. Business case, market context, insert relevant industry AI adoption statistics, competitive advantage, internal AI capability development versus external dependency. ROI projection, insert customized ROI calculations based on organizational context, risk mitigation, proactive capability building versus reactive catch-up program overview. Duration, 90-day foundational program plus optional 6-month specialization tracks. Participants, 10 departments. Investment, total. High potential professionals across budget, infrastructure, and facilitator costs including technology. Expected outcomes, specific organizational capability development goals, implementation timeline, weeks 1 to 4, program setup and participant selection weeks 5 to 17, foundational AI Fluent Professional development weeks 18 to 42, optional specialization track. Participation ongoing, continuous improvement and program evolution. Appendix C, case studies and real-world examples. C.1 Successful AI Team Implementation Stories Development. Case Study 1, Global Manufacturing Company, 8,000 employees. Organization context, Tech Manufacture Global, a Fortune 500 manufacturing company, faced increasing competitive pressure from AI-enabled competitors and recognized the need to develop internal AI capabilities to maintain market leadership in industrial automation. Implementation approach, Cohort 1 24 participants from engineering, operations, and business development. Duration, 90-day foundational program plus 6-month technical integration specialization. Investment, $480,000 participant time, total, technology, facilitators. Leadership support, CEO Champion Program, dedicated 20% of CTO time to oversight. Week-by-week highlights, weeks 1 to 4, strong engagement in prompt engineering with immediate application to technical documentation automation. Weeks 5 to 8, Python foundations accelerated due to existing engineering background. Weeks 9 to 12, business intelligence focus created breakthrough in predictive maintenance applications. Weeks 13 to 16. Capstone projects produced 3 production-ready AI implementations. Quantified outcomes, 12-month follow-up. Technical capability, 24. Certified AI Fluent Professionals, 8 pursuing advanced specializations. Business impact, $2.3 million annual savings from predictive maintenance optimization. Process improvement, 40% reduction in equipment downtime, 25% improvement in maintenance efficiency. Cultural change, 67% of engineering staff report increased confidence in AI collaboration. Market position, 2 new AI-enhanced products launched, $15 million additional annual revenue. Lessons learned. Engineering background accelerated technical learning but required additional focus on business strategy. Cross-functional team projects created unexpected innovation opportunities. Executive visibility crucial for overcoming initial skepticism from senior technical staff. Investment in change management paid significant dividends in adoption speed. Facilitator insights. The manufacturing environment provided excellent real-world testing opportunities. Participants could immediately see the impact of their learning on actual production challenges, which accelerated engagement and skill development significantly. C.2 Common challenges and problem-solving strategies. Challenge 1. Technical background diversity. Problem: mixed cohorts with participants ranging from non-technical business roles to experienced software engineers created learning pace and engagement challenges. Solutions implemented. 1. Tracks adaptive learning paths, created acceleration for technical participants and reinforcement for non-technical participants. Foundation. 2. Peer mentoring, paired technical and business participants for mutual learning, technical skills plus business context. 3. Project role specialization, design team projects where participants could contribute according to strengths while learning complementary skills. 4. Just-in-time support, provided additional technical tutoring and business context workshops as needed. Results: 94% completion rate across diverse backgrounds, versus 76% in control programs. Post-program surveys showed 89% satisfaction with learning pace. Accommodation technical participants' communication skills reported improved business. Business participants gained confidence in AI technical discussions. Challenge 2. Organizational resistance and skepticism. Problem: mid-level managers concerned about AI impact on their teams and job security, creating barriers to participant engagement and post-program application. Solutions implemented. 1. Manager engagement program, separate briefing sessions for managers of participants. 2. Success story communication, regular updates highlighting participant achievements and business value creation. 3. Fear addressing workshops, direct discussion of AI impact concerns with evidence-based reassurance. 4. Collaborative implementation, involved skeptical managers in defining AI application opportunities. Results: manager support scores increased from 2.35 to 4.15 over program duration. 78% of initially skeptical managers became program advocates. Participant application success rate increased 45% with manager support. 6 initially resistant managers requested participation in subsequent cohorts. C.3 Industry-specific adaptation examples. Healthcare implementation. Regional hospital system adaptations made, regulatory focus, enhanced HIPAA compliance and FDA regulation modules. Patient safety priority, additional weeks on bias detection and explainable AI clinical workflow integration, healthcare-specific case studies and applications. Interdisciplinary teams, mixed clinical and administrative participants. Specialized modules added. Clinical decision support, ethics and validation, medical device AI, regulatory pathways, patient privacy and consent in AI applications, healthcare AI, vendor evaluation and procurement outcomes. Successfully deployed AI-enhanced diagnostic support tools, reducing diagnosis time by 23% while maintaining 99.7% accuracy standards. Financial services implementation, regional credit union adaptations made, compliance integration, enhanced fair lending and consumer protection. Focus risk management, specialized modules on algorithmic bias in lending decisions. Member experience, focus on AI applications that enhance rather than replace human financial advisors. Cybersecurity, additional emphasis on AI security and fraud detection, specialized modules added, fair lending compliance for AI systems, explainable AI for loan decision transparency, robo-advisor, fiduciary responsibility frameworks, AI-enhanced fraud detection while protecting member privacy outcomes. Developed AI-enhanced loan processing that reduced approval time by 60% while improving fairness metrics across demographic groups. Appendix D, Research Foundation and Evidence Base. D.1 Literature Review, AI Adoption and Training Effectiveness Research, Key Research Findings Supporting Program Design, Adult Learning and Technical Skill Development, Knowles, M.S., 2015. Adult Learning Theory in Practice, Self-Directed Learning Principles show 34% better retention when applied to technical training, Educational Psychology Review, 2018. Experiential learning approaches in technology training demonstrate 56% better skill transfer to workplace applications, a Journal of Educational Technology Research, 2019. Competency-based assessment shows 23% higher job performance correlation than traditional testing methods, Training and Development Journal, 2020. AI Education and Professional Development. MIT study, 2021. Organizations with structured AI training programs show 2.3x faster AI adoption rates compared to ad hoc training approaches. Stanford Research, 2022. Cross-functional AI teams with shared foundational training demonstrate 67% higher project success rates. McKinsey Global Institute, 2023. Companies investing in comprehensive AI literacy show 45% better ROI on AI initiatives over 3-year periods. Change management and technology adoption. Kotter's 8-step process applied to AI adoption shows 78% success rate when integrated with technical training, Change Management Review, 2021. Resistance to AI adoption decreases by 52% when employees receive both technical training and change management support, Organizational Behavior Studies, 2022. Peer mentoring in technology adoption programs increases long-term usage by 41%, Training Effectiveness Quarterly, 2020. D.2 Enterprise AI Market Analysis and Trend Assessment, Current Market Context, 2025. Enterprise AI adoption rates. 68% of enterprises have moved AI projects from pilot to production, up from 34% in 2022. Average enterprise now uses 5.2 different AI tools or platforms, up from 2.1 in 2021. AI spending has shifted from innovation budgets, 25% in 2022, to core IT budgets, 61% in 2025. Skill gap analysis. 73% of enterprises report significant or critical AI skill gaps. Average time to fill AI-related positions, 4.7 months, up from 2.8 months in 2020. 89% of organizations prefer to develop internal AI capability versus outsourcing. Training investment trends. Enterprise AI training budgets increased 156% year-over-year in 2024. ROI on internal AI training programs, 3.2x within 18 months on average. Organizations with formal AI training programs report 45% higher employee retention in technical roles. D.3 Learning theory application in AI education. Cognitive load theory in AI training, Research Foundation, Sweller, J., 2020. Cognitive load theory and AI education, managing intrinsic, extraneous, and germane cognitive load in technical training. AI concepts demonstrate high intrinsic cognitive load, requiring careful instructional design. Worked examples reduce cognitive load by 34% in programming and AI development. Training application in program design, Progressive Complexity Introduction, Week 1. Basic Prompts. Week 12, Complex AI Systems. Worked example integration throughout technical modules. Cognitive load monitoring through real-time feedback and adaptation. Social learning theory application, Research Foundation, Bandura, A., 2019. Social cognitive theory applied to professional development in technology contexts. Peer modeling increases technical skill acquisition by 42% compared to individual instruction. Collaborative problem solving develops both technical and professional skills simultaneously. Application in program design. Peer teaching components in assessment framework. Cross-functional team projects throughout program. Mentoring relationships between participants with different background. Strengths. Appendix E, Legal considerations and compliance. E.1 Data privacy and protection requirements for training programs. GDPR compliance framework for AI training, personal data processing, lawful basis, legitimate interest for professional development, document participant consent, data minimization, collect only information necessary for educational assessment and improvement. Purpose limitation. Use participant data exclusively for training delivery and quality improvement. Retention limits. Delete personal training data within 3 years of program completion unless explicit consent for longer retention. Technical and organizational measures. Access controls. Role-based access to participant data. Multi-factor authentication for all systems. Regular access reviews and permission updates. Audit logs for all data access and modifications. Data protection. Encryption at rest and in transit for all participant information. Secure data backup and recovery procedures. Anonymous data aggregation for program improvement. Analytics. Clear data breach notification procedures. Participant rights implementation. Right of access. Participants can request copies of all data held about them. Right to rectification. Process for correcting inaccurate personal information. Right to erasure. Ability to request deletion of personal data post-program. Right to portability. Provide participant data in machine-readable format upon request. E.2 Intellectual property considerations for AI development projects. Intellectual property framework. Participant-created content. Portfolio projects. Participants retain ownership of individual portfolio work. Collaborative projects. Shared ownership model with clear attribution requirements. Employer interests. Recognition of employer rights to work-related innovations developed during program. Training materials and curriculum. Proprietary content. Training organization retains rights to curriculum, assessments, and methodology. Open source integration, clear attribution and compliance with open source license requirements. Third-party content. Proper licensing and usage rights for external materials and tools. AI-generated content. Tool output. Clarification that AI tool outputs during training belong to the participant or employer as appropriate training examples. Right to use anonymized examples for future program improvement. Commercial application. Clear guidelines on commercializing AI applications developed during training. Template. Intellectual property agreement. Intellectual property agreement. RE Training Program 1. Participant creations, individual projects, full ownership retained by participant. Team projects, requirements. Shared ownership with attribution. Employer work, subject to existing employment agreements. 2. Program materials, curriculum and assessments. Training organization retains ownership. Participant may use methodologies learned for professional application. No redistribution of proprietary training materials without permission. 3. AI tool outputs. Content generated using AI tools during training belongs to user. Training organization may use anonymized examples for program improvement. Commercial application subject to tool provider terms of service. E.3 Employment law. Implications of AI skills development. Training time and compensation. Work time versus personal time. Clear policies on whether training occurs during work hours. Compensation requirements. Understanding wage and hour implications. For mandatory training. Skills development. Investment. Documentation of employer investment for potential retention agreements. Career development and promotion. Equal opportunity. Ensuring fair access to AI training opportunities across protected classes. Performance evaluation. Integration of AI skills development into performance review processes. Career advancement. Clear pathways for leveraging AI skills for internal promotion. Skills transfer and retention. Training investment. Recovery. Reasonable approaches to retention after significant training investment. Non-compete considerations. Balancing skill development with employer protection interests. Knowledge transfer. Obligations for sharing AI skills and knowledge with team members. About the author. Zaheer Ahmad Meer, constitutional and corporate lawyer, distinguished author, Islamic scholar, social justice advocate. Zaheer Ahmad Meer stands as one of Pakistan's most prolific contemporary authors and distinguished legal minds, having authored over 50 groundbreaking books that bridge Islamic wisdom, modern leadership, artificial intelligence, and constitutional law. With more than 3 decades of legal excellence and 36 years of entrepreneurial innovation, Meer has established himself as a transformative voice in legal scholarship, Islamic thought, and social reform. Legal excellence and public service. As a highly respected constitutional and corporate lawyer, Meer has provided expert legal counsel to Pakistan's most significant public institutions, serving as legal advisor to the Federal Land Commission. His leadership extends to cultural and educational institutions, including pivotal roles with the Punjab Public Library, Punjab Library Foundation, and Iqbal Academy Pakistan, where he has shaped policy and governance reform initiatives that impact millions. Entrepreneurial vision and innovation. A pioneering entrepreneur, Meer has successfully founded and led ventures across legal tech, education, publishing, and construction sectors in Lahore and Karachi. His forward-thinking approach has consistently anticipated market needs, particularly in the intersection of technology and traditional industries, positioning him as a thought leader in Pakistan's evolving business landscape. Champion of social justice. Meer's commitment to accessible justice is exemplified through his founding of the Social Justice Front in 1990, a revolutionary non-profit movement providing completely free legal representation, including court fees, documentation, and advocacy, to Pakistan's underprivileged communities. In 2023, he expanded this mission through Justice for All, ensuring zero-cost legal access for marginalized citizens and cementing his legacy as a champion of equitable justice. Literary legacy: 50-plus books of transformational impact. Meer's extraordinary literary output encompasses multiple groundbreaking series that address the most pressing challenges of our time. Islamic Leadership in the AI Era, 13-volume masterwork, a comprehensive exploration of timeless Islamic principles applied to contemporary leadership challenges, featuring detailed studies of Prophet Muhammad, PBUH, the rightly guided caliphs, and Quranic wisdom for the digital age. Quranic Encyclopedic Series, 6 volumes, an unprecedented scholarly undertaking cataloging and analyzing over 6,000 verses across theological, ethical, historical, legal, and reflective dimensions, representing one of the most comprehensive Quranic reference works of the modern era. Pakistani political and historical analysis authoritative works including The Nuclear Umbrella, Pakistan's Muslim NATO Leadership, 6-volume series, Mythmakers of Pakistan, and definitive studies on Quaid-e-Azam Muhammad Ali Jinnah that challenge conventional narratives with rigorous scholarship. Legal innovation and AI integration. Pioneering works such as I Am GPT for Lawyers, Revolutionizing Legal Practice, AI Mastery for Professionals, and Crypto Command that position legal professionals at the forefront of technological transformation. Philosophical and interfaith scholarship groundbreaking analyses including The Quran Resolved the Questions of Philosophy, from Socrates to the AI Era and Why the Quran and Muhammad, PBUH, Testify the Torah and Gospel, and vice versa, establishing new paradigms for interfaith dialogue and philosophical inquiry. Scholarly recognition and intellectual legacy. Inspired by the legendary Dr. Burhan Ahmed Farooqi, Meer's intellectual approach seamlessly integrates traditional Islamic scholarship with cutting-edge contemporary analysis. His works serve as essential reading for leaders, policymakers, scholars, and anyone seeking to navigate the complex intersection of faith, technology, governance, and social justice in the 21st century. Global impact and vision. With publications bearing ISBN registration and international distribution, Meer's influence extends far beyond Pakistan's borders. His unique ability to synthesize complex theological, legal, and technological concepts into accessible yet authoritative texts has earned him recognition as a vital voice in global Islamic scholarship and contemporary leadership discourse. My books are not merely academic exercises, they are blueprints for transformational living and leadership. In an era where technology advances at unprecedented speed, the timeless principles of Islamic wisdom, constitutional law, and social justice provide the moral compass necessary for authentic leadership and meaningful change. Zaheer Ahmad Meer continues to write, lecture, and advocate for a world where law, leadership, technology, and faith converge to create a more just, enlightened, and prosperous global community. The complete works. OF. Zaheer Ahmad Meer. A comprehensive catalogue of 50-plus groundbreaking publications. Islamic Leadership in the AI Era, the definitive 13-volume series. 1. Muhammad, the timeless model of success for everyone in AI Era 2. Quranic Stories and Wisdom, the only solution in the AI Era 3. Living Islam, implementing Islamic leadership in the AI Era 4. Allah, the source of ultimate leadership and knowledge in the AI Era 5. The Holy Quran, the ultimate blueprint for leadership and ethics in the AI Era 6. Hazrat Abu Bakr, R.A., as-Siddiq, leadership in faith and integrity in the AI Era 7. Hazrat Umar ibn Khattab, R.A., the model of justice and strength in the AI Era. 8. Hazrat Uthman ibn Affan, R.A., a leadership in generosity and organization in the AI Era 9. Hazrat Ali ibn Abi Talib, R.A., the model of wisdom and courage in the AI Era 10. The Quran resolved the questions of philosophy, from Socrates to the AI Era 11. Quranic logic and examples, exploring divine wisdom and rationality in the Holy Quran 12. Why the world is global. The Quranic perspective on unity, interconnection, and divine order, concise edition, 13. Why the world is global. The Quranic perspective on unity, interconnection, and divine order, enlarged edition. Bonus volume, Why the Quran and Muhammad testify to the Torah and Gospel, and why the Torah and Gospel also testify to Muhammad. Quranic Encyclopedic Masterwork, the most comprehensive Quranic reference series. Enlarged edition, 6 volumes, Book 1, 114 Timeless Truths of the Quran, Book 2, 3,110 Spiritual and Theological Verses of the Quran, Book 3, 1,500 Ethical Verses of the Quran, Book 4, 800 Historical Verses of the Quran, Book 5, 350 Legal Verses of the Quran, Book 6, 362 Reflective Verses of the Quran. Concise edition, selected volumes, Book 4, 800 Historical Verses of the Quran, concise, Book 6, 362 Reflective Verses of the Quran, concise. Islamic Scholarship and Philosophy, Decoding the 100 Characteristics of Each Caliph of Islam, Shakespeare and Islamic Influence, a deep dive into English. Literary Success, the Quran, Knowledge and Amazing Muslim Thinkers Who Changed the World. The Ultimate Journey Series for Volume Eschatological Masterwork 1. Life and Death 2. Paradise 3. Hell 4. The Day of Judgment. Legal Scholarship and Historical Analysis, the Great Legal Mind Series, The Genius Jurist, 169 Reported Cases of M.A. Jinnah. The Great Lawyer, 111 Reported Cases of Drive All Amrik Bal, I am M.A. Jinnah, Mastering Advocacy Through My Journey. Pakistan Studies and Political Analysis 11-volume National Discourse Series, Foundational Works, The Enemies by Birth, Mythmakers of Pakistan, Quaid-e-Azam of Pakistan, Concise Youth Edition, Quaid-e-Azam of Pakistan, Expanded Scholarly Edition. Contemporary Analysis, The Ironclad Axis, Shaping Pakistan, Volume 1, Shaping Pakistan, Volume 2, Bhutto and Khan, Hope Delivered Not Just Promised, A. Rebuttal to Mythmakers of Pakistan, Barracks to Blockchain, Humanity in Genocide Strategic Defense Series, The Nuclear Umbrella, Pakistan's Muslim NATO Leadership, 6-volume Complete Series, Volume 1, Strategic Foundations, Volume 2, Regional Dynamics, Volume 3, Global Implications. Volume 4, Future Projections, Volume 5, Policy Frameworks, Volume 6, Leadership Paradigms, The Nuclear Umbrella, Executive Summary, Economic and Technological Vision, Crypto Command, Blockchain Future for Pakistan, Crypto Command, Summary Edition, Artificial Technology Intelligence and I Am GPT, An Autobiography of AI, I Am GPT for Lawyers, Revolutionizing Legal Practice, AI Implementation Workbook, AI Mastery for Professionals. Building Teams of AI-Fluent Professionals, Personal Development and Spiritual Growth, Mastering Life's Blessings, How You Can Raise Yourself, I Am Uncharted Human Mind, The Sacred Pause. Publication Statistics. Total published works, 50+ books major series, 8 comprehensive series single volumes, 15+ standalone works pages published, 25,000+ pages of original content languages, English, primary, Urdu references scope, international distribution with ISBN registration. Thematic coverage. Impact and reach. This extraordinary body of work represents one of the most comprehensive attempts by any contemporary author to bridge traditional Islamic wisdom with modern challenges including artificial intelligence, blockchain technology, constitutional law, and geopolitical analysis. Target audiences: Islamic scholars and religious leaders, legal professionals and policymakers, technology innovators and AI professionals, Pakistani youth and political thinkers, international academic community, leadership development professionals. This collection represents not just books, but blueprints for transformational living in the AI era, where timeless Islamic principles meet cutting-edge contemporary challenges. Zaheer Ahmad Meer.